ഹലോ, വർക്കിംഗ് അല്ല.
Hello.
Sir, last.
Esteemed dignitaries, scholars, delegates, ladies and gentlemen, a very pleasant morning to each one of you. Welcome to the second International Conference on Advances in Naval and Ocean Engineering, iCANOE 2023, organized by the Department of Ship Technology, Cochin University of Science and Technology. Today, this esteemed gathering brings together the finest minds in the realm of maritime advancements and promises to navigate the uncharted horizon of naval and ocean engineering. The ocean, vast and teeming with potential, have long been humanity's frontier for exploration and innovation. From ancient voyages to modern maritime technology, The journey across these great waters has fueled our progress and piqued our curiosity. Today, as we stand at the cusp of technological revolutions and environmental challenges, our discussions and collaborations here are poised to shape the very fabric of our future maritime endeavors. To embark this insightful journey, let us first seek the divine blessings that guide our deliberations. Please join in a moment of prayer. I request everybody to switch off the mobile phones.
ഈശ്വരനാമം എന്നും എന്നോടെ അധരം ഉരുവിടണം. ഈശ്വരനാമം എന്നും എന്നോടെ അധരം ഉരുവിടണം. ഈശ്വരമൊഴികൾ എന്നും എന്നോട് കാതിൽ മുഴങ്ങിടണം. ഈശ്വരമൊഴികൾ എന്നും എന്നോട് കാതിൽ മുഴങ്ങിടണം. ഈശ്വരപാദയിലെന്നും എന്നോട് പാദം നീങ്ങിടണം. ഈശ്വരപാദയിലെന്നും എന്നോട് പാദം നീങ്ങിടണം. ഈശ്വര ചേതികൾ എന്നും എന്നോടെ കൈകൾ ചെയ്തിടണം. ഈശ്വര ചേതികൾ എന്നും എന്നോടെ കൈകൾ ചെയ്തിടണം. ഈശ്വരനാമം എന്നും എന്നോട് അധരം ഉരുവിടണം. ഈശ്വരനാമം എന്നും എന്നോട് അധരം ഉരുവിടണം.
Thank you for that serene beginning. To set the tone for this event, it's an honor to invite our respected Professor Dr. K. Shivaprasad from the Department of Ship Technology to extend a warm welcome to all present. Please, sir.
Good morning to all. It's very difficult to offer a welcome speech when dignitaries are sitting on the either side stage and the room, seminar room. It is very certain that the next era is going to be an era of blue economy. The focus of development, sustainable development especially, will come towards ocean from land. Are we prepared for that? That shift of focus from land to sea, are we prepared for that? That's the question here. And that is why we are gathered here. We have to turn our face towards developing ocean, developing inland waters. India has got a very vast and very spread coastline of around 8,000 kilometers. And our inland waters are very huge. The connectivity is very huge. Are we going to exploit that? It will not simply fall from blue sky. Blue economy is not going to fall from blue sky. We have to do research, teaching, training, or whatever it is. So we are gathered here for discussing the research part of blue economy. Though it is economy, it's a kind of technology involved in that. We will not be able to start an economy without technology. So we are here to discuss the possibilities of the technology towards blue economy. That is why we are here. Respected Head of the Department, Dr. P.K. Sadish Babu, the President of this inaugural function of iCANOE 23, respected Dr. Ajit Kumar, Present Director of Naval Physical and Oceanographic Laboratories, Kochi, Rear Admiral Bimal Kumar, Director of Naval Warship Design Bureau, New Delhi, Mr. Sumitran Sampath, Head of Operations in India of Class NK, distinguished guests, keynote speakers, invited speakers, participants, officers from Indian Navy, our alumni members, participating delegates, scholars, students, and my respected teachers, colleagues, students. Let me go to my duty. First of all, the president of this function, inaugural function of iCANOE 23, Dr. P.K. Sadish Babu, he does not require a formal welcome, but he needs some introduction. When he joined here in this department in 2021, before that, the Department of Ship Technology community was trying to, trying to organize some international seminars, but it failed miserably. As soon as he came, he started. 2021, he started iCANOE #1. Now he's again, he was not the head of the department, then he was the coordinator. Now he's as head of the department. He's arranging another seminar, international conference, iCANOE 23. He is a naval architect. He's a metallurgist. He's an academician. Overall, he's a good teacher. So on behalf of you, I wholeheartedly welcome Dr. P.K. Sadish Babu, president of this function. When we approached Dr. Ajit Kumar, I think a few days back, very pleasantly, he offered his presence here. Now he's with us and he's going to inaugurate the second version of iCANOE, iCANOE 23. If I speak about his achievements and awards, I'm afraid I will be taking the entire session for that. So I will restrict myself to some important aspects only. I think he's the first director of NPOL with a mechanical engineering background. Am I correct, sir? Yes. NPOL used to be they used to be ruled by electronics and electrical engineers generally. I think Antnarayan sir will be telling yes to that. So he's the first mechanical engineer to head NPOL. There is something catchy in that because it is close association with naval architecture. No, I don't say that electronics is different from naval architecture. It is there, but there is a close relation. And he's a graduate, as we used to discuss about ISRO success. The ISRO success on Chandrayaan is basically from engineers from the state government colleges, engineering colleges. He's from CET Trivandrum. He took his MTech from IIT Madras, and his PhD is in engineering management, which is you should be thinking about that engineering management and NPOL. Everything has got a management content in that. Technology will not be able to solve all problems. And his success in this as a director is attributed towards his background as and management academician. He's having PhD in management from Anna University. So we are not fortunate to have him in his service for many years. He is going to retire soon. And we are fortunate to have him in his capacity as a director in this inaugural session. I welcome, on behalf of all those who are assembled here, wholeheartedly welcome Dr. Ajit Kumar for this function. We have with us one of the proudest products from this department. It's none other than Rear Admiral Bimal Kumar. He was an 11th batch graduate from this department. The first admiral from this department. We have reached, before him, we had reached up to a Commodore level. Now he is an admiral. And this is one of the proudest moments for us, that one of our products from this department has reached up to admiral level. I still remember him as a first year student, I think second semester student, receiving American Bureau of Shipping silver medal for his performance in first semester academics. So he's an academician, he's an administrator, he's a kind of a logistics manager, he's a researcher, and what else? We will be able to say many things about him. He's heading the Warship Design Bureau of Indian Navy. And he's heading most of the strategic designs in India now. And we are becoming one of the biggest powers in naval defense in the world. So he's taking us towards that #1 position in naval defense. So I take this opportunity to welcome, on behalf of you, Rear Admiral Bimal Kumar towards this function. Mr. Sumitran needs no introduction here because he has been visiting this department many occasions, probably from last 10 years. And he is the regional head of Class NK, which is the biggest ship classification society in India. But most interestingly, institutes and industry will have many MOUs. Something will be live, something will be for namesake. But here we have an MOU, a long-lasting MOU for the last 17, 18 years with Class NK. That is live. This MOU is live because of him, because of his active involvement in implementing the MOU, whatever stated in MOU as different clauses. Sumitran Sampath is making our collaboration, industry institute collaboration, always live. So he's a special guest here. And I, on behalf of you assembled here, I welcome Mr. Sumitran Sampath to this function. We have very distinguished guests like Anthony Prince, a doyen in shipbuilding, Sri Ananta Narayan sir, former director of NP Oil, who is going to give a keynote in this seminar. We have another, he's not a special, he's not a guest. Probably he can be a guest. Dr. Ebinit sir. Sir was a director in NP Oil, and I have found him one of the dynamic hydrodynamics engineer, one of the sound structural engineer, a good teacher, and an elegant guide. And after his arrival here, the entire research scenario in this department has changed completely. He is inspiring the scholars and students to take up studies and research in a better way. So I take this opportunity to welcome Dr. Ebinit sir. He's a naval architect turned acoustics engineer. That is why I said sound structural engineer. So I take this opportunity to welcome Ebinit sir. Since sir has asked a seat there, they're locating. Thank you, sir. The success of any seminar or conference depends on the theme delivered here. So we have keynote address speakers, invited speakers, other participants and delegates and sponsors in this house. I take this opportunity to welcome all those who are assembled here, students, scholars, colleagues, everybody is welcome. Thank you.
Thank you, sir. To provide an overview of the conference, I now invite the convener of iCANOE 23, Dr. Rajesh P. Nair, to share the vision and purpose behind this remarkable gathering.
Thank you, Hasina teacher. Dear all dignitaries on the dais and off the dais, welcome to second edition of iCANOE. As Shivprasad sir has rightly mentioned, this is the second version. Our first one was in 2001. At that time, Sadiq sir was the convener and Fawaz sir and Bina teacher was there. 21, yeah, 21. So this is 23. So every year our department will have conference in the sense that we have DIMS being conducted on 22 and it's coming on 24. So 1 year if it's conducted by department, next year it will be by the alumni DOSTAS, Department of Ship Technology Alumni Society. So the main aim of any conference is to make the participants interact with each other and to share ideas and to make and to create some new research collaborations. And so that's the main objective of our conference, in order to make people to come together and to interact. People are, especially researchers, are reluctant to publish papers in conference, thinking that it's not valid up to journals. But I believe that even in IITs also, 2 conference papers is equivalent to 1 journal paper. So I believe that conference should happen and make things happen like that. And we are pleased to have Dr. Ajit Kumar sir, NPL director, to inaugurate our conference, and Rear Admiral as chief guest to release our conference proceedings. We received around 43 abstracts, out of which 22 full papers were accepted for publishing in conference proceedings. And this conference is a hybrid version in the sense that we have 2 online presentations and the remaining will be oral presentation here. And conference is available in Zoom link and it will be live streamed using YouTube channel. So here, this conference is becomes colorful because of the financial support from the sponsors, and we are lucky to have our alumni in the companies, and we don't find any much difficulty to get sponsorship. So our sponsors are especially from DRDO, SETS, S&O Maritime, CSS, and Ares Energy. We are also thankful to CUSAT administration for funding the initiative of this conference. And today evening, we are planning to have a water metro for the registered delegates. So we are planning to take the participants from here to Marine Drive and to Vipin and come back here. And so those who are participants are requested to register in the conference desk, registration desk for water metro also. And feel free to contact us for any other help, especially in registration desk. And all the participants and anybody interested can get the electronic copy of proceedings. Thank you very much. Thank you all. Thank you.
Thank you, sir. Moving forward, it's an esteemed privilege to welcome our head of the department, Dr. Satish Babu PK, to present the presidential address. Please, sir.
Okay, good morning. Respected Director, NPOL, and outstanding scientist, Dr. Ajit Kumar sir. Our chief guest of the day, Rear Admiral Bimal Kumar, Director, Warship Design Bureau, Indian Navy. Dr. K. Shivaprasad, our constant supporter from Class NK, Mr. Sumitran Sambad sir. And all distinguished guests, invited speakers, delegates, students, sponsors, media, and all my friends watching online and offline. Very good morning to one and all. I'm really humbled to stand in front of you today morning because of the participation from the for the conference, as well as the number of esteemed guests who have turned up for the inaugural function. As it was mentioned, the first iCANOE 21 was conducted 2 years back as part of the Golden Jubilee celebration of our university. And it is a coincidence that we are conducting the second version of iCANOE, that is iCANOE 23, when the department is going to the Golden Jubilee year of the department. The department was established in 1974, and the first batch classes started in 1975. So we have decided to conduct, to have our Golden Jubilee year in 2024 and 25. So the department has made a tremendous journey in its progress. And I remember all those who has contributed to the success of the department at this moment. This time, the response from all stakeholders has been excellent. We are privileged that the conference is jointly organized by Royal Institution of Naval Architects, London. They were more than happy to support our department. And we got support from Naval Research Board, and they have also given participation amount. And it's a privilege. It's the first time I think we are conducting a conference supported by an international organization, and also one of the finest research organization in our country. I'm sure that over the years, iCANOE will be a go-to event in the maritime history of our country. I'm sure the people will be looking forward to come to this conference over a period of time. We are living in an era of automation, digitization, more numerical techniques, more artificial intelligence. So the kind of shifts we make today, tomorrow, kind of building, kind of operation, everything is going to be different. And the department knows that a lot of research is happening at various places related to this industry. And as a leader or as a pioneer of naval architect education in our country, we feel that it is our responsibility to bring all stakeholders together, from academia, from R&D institution, from defense, and to bring together and provide a forum for deliberation of their ideas, their research findings. And I'm sure that, in fact, we are committed to make this conference a good experience for all the participants. So apart from the 22 research papers which will be published today, we have 2 keynote address by our most respected friend, sir, and sir, today and tomorrow. And also we have 4 invited speakers from the industry leaders. And these, I'm sure, will definitely be helpful for the participants. So before I conclude, I want to say that apart from being a continuous supplier or provider of qualified naval architects to the industry, the department is also aiming to become a good research center by research center where the industry can come and do research here. And very happy to report that already we are carrying out industrial project for more than 1.5 crores. And it's a matter of pride that being once upon a time, we were only doing undergraduate course. Now we have a very well established MTech program. All MTech students are doing industry related MTech projects. Even BTech 6 projects are supported by Cochin Shipyard. We have already produced 27 PhDs and many more are doing excellent job. So I compliment my team, all professors, all research scholars, non-teaching, teaching, everyone who has worked hard for this conference. And I'm sure that this conference will be a grand success. I look forward to being with you for the next 2 days, and I wish the conference all the very best. And before I conclude, I want to say special thanks to Ajit Kumar sir, who without any hesitation, he has agreed to come here. And also Admiral Bimal Kumar. We were together in hostel. I learned a lot of naval architecture from him. We did some project, not sub work, but some work for his project. So that, and we learned a lot by doing work for people like him. And we always respected him. Sir, so I would like to congratulate you, sir, for getting promoted to the first admiral from our department. So, and also I would like to thank Sumitran sir for his constant support to our students in terms of giving awards and also many times financial assistance. Special thanks to our sponsors, without whose support this wouldn't have been possible. So once again, thank you everyone. Thank you very much. Have a nice day.
Thank you, sir. We are honored to have amongst us an eminent personality whose contributions have made significant strides in naval and oceanographic research. Dr. Ajit Kumar joined DRDO at NPOL in 1987, and over the 34 years of distinguished service, he had served the various capacities, which includes prestigious and strategic projects like Advanced Torpedo Defense System. For the outstanding contributions made by the pious soul, the Government of India had honored Sir with the DRDO ACNE Award for Excellence in Self-Reliance 2018. I would like to invite Dr. Ajit Kumar K., an outstanding scientist and director from the Naval Physical and Oceanographic Laboratory, for the inauguration. We request Sir to officially inaugurate the conference by turning the hem wheel, a symbolic representation which marks the start of our exciting voyage for the next 2 days. Please, sir.
A very good morning to all of you. The president of today's meeting, Dr. Satish Babu, the head of the Department of Ship Technology. The chief guest, Rear Admiral Bimal Kumar, Additional Director General, Warship Design Bureau, New Delhi. Dr. K. Shiva Prasad, Dr. Rajesh Nair, Sri Sumitran Sambat, the General Manager, Class NK. My former director, Anandaran sir, Dr. Ebenezer, dignitaries of the dais, all the scholars, all the people, all the research scholars who are presenting papers, the students, members who are joining this conference online, ladies and gentlemen. It's indeed a pleasure for me to be part of this inaugural function of these second international conference on advances in ocean and naval engineering. Two subjects, very important subjects. One related to the float part of it, the ships and all the moving platforms. And the second part on the ocean engineering aspects, how we can really exploit the ocean by embedding with sensors, systems, all those engineering systems which can help us to understand the ocean in a better manner and to utilize it actually. I'm also extremely happy to note that we are located in this country where we have the largest shipyard, our own Cochin shipyard. And also, we are also going to have one more port coming up south of Cochin, that is at Trivandrum, which is going to be again a transshipment port which is coming up. We also have the academic institution, the Department of Ship Technology, CUSAT, which has in fact taught and brought up many stalwarts in the field of naval architecture. When I was introduced as the first mechanical engineer, as you all know. Engineering is one subject, irrespective of your domain. As you grow up, you should have a systems view on any development or any activity what you are undertaking, and towards that effect. I can also see the subjects of this conference which touches upon materials. It talks about new computational techniques. It talks about planning for inland, in fact, the waterways. So it's a holistic view that actually will enable any person to be in this field. And I'm sure the industry reps also will vouch for that. So as naval architects, as students in the area of naval and ocean engineering, irrespective of your domain or study of research, definitely the holistic aspect about the complete ecosystem needs to be understood before venturing out into any activity, whether it is business, research, or anything. So that will actually help you in a better manner in your activities. And for those things, this kind of conferences where we have the networking happening between the research scholars, the industry, the academia, will actually help you empower that. And at the outset, for that, I congratulate the Department of Ship Technology who have taken all the initiative to conduct this conference. Well done, actually. The government of India, in fact, as you all know, have got many programs, out of which the Ministry of Shipping has come out with the Sagarmala program, a very focused approach which started in 2015 for development of new ports, development of additional facilities in the existing ports. It's a focused approach from the ministry with a number of projects being sanctioned all along the country at various locations. It's all done to actually help the country grow in the field of shipping. Actually, as you all know, we are 20th in the world actually when it when compared to the overall shipping industry as such. And not only that, the shipbuilding industry also needs to grow. The supporting infrastructure also needs to grow along with this. Altogether, it brings about a winning combination actually. So towards that, the Sagarmala program is in place. And on top of it, we have the Honorable Prime Minister's program of Sagar, that is security and growth for all the countries in the IOR region. Actually, it's a very ambitious program where all the stakeholders, people who all those matter in the field of ocean and marine industry, they join together to understand what we call as the underwater domain awareness actually. So underwater domain awareness encompasses both civil and military applications, and I'm sure the naval officer over here will vouch for that. We have a maritime security domain, which is very important as part of UDA. And some of the security agencies, including the Indian Navy, the Coast Guard, and DRDO, we are all focused on working towards that. Likewise, the maritime industry, the maritime mercantile MMD departments, they're all concentrated in other Ministry of Earth Sciences, METI. All these departments are focused on the other aspect of it, the civil aspect of it. So altogether, if we understand the ocean in a better manner, we focus all our activities together so that it's a win-win combination for all the departments, in fact. So this calls for voluminous data collection, sharing of this information, assimilation of this information, and dissemination. All these things are important. So this is happening in a silent way in all the departments. So with these programs in place, steered by the government of India, definitely it's going to be a winning combination. But as practicing engineers, naval architects of this country, we should tag along with this program and make the best use of it. To that effect, I am very happy to note that the Naval Research Board of DRDO is also sponsoring this program. And we at NPOL, I can very proudly say that we have a very long association with the Department of Ship Technology. From our legacy sonar systems, as you all know, nowadays we are going for autonomous systems, autonomous vehicles, where the man in the loop is taken out. And in the future, this is going to be the warfare, what the digitization of the war field is happening, and this is going to be the future. So towards that also, naval architecture, shipbuilding, platform designs, all these things have got a very important role in empowering not only the civil shipping industry, but also the military and the naval applications. The autonomous vehicles and completely embedded with various types of sensors, they are going to be the future. They are going to undertake all the missions actually. So from our legacy sonar systems, which we were, in fact, I can proudly say that all our ships of Indian Navy are carrying NPOL design sonars. Likewise, the submarines of Indian Navy are also carrying, in fact, operational with NPOL design sonars. From that sonars to platform-centric integration and network-centric operation is the future. And also, we also have to develop autonomous systems, autonomous AUVs, ROVs, and different kinds of autonomous systems, which will actually help in all our anti-submarine warfare program. So the future is promising. And as always said, those who understands the ocean will actually rule the world, in fact. So it's very important from this point of view. Today, we hear about our own scientists, our own people doing the research and trying to understand the space in all our programs, and we have achieved huge success. So there is at another domain down below the surface of water, the underwater domain also needs to be understood properly. And it's a huge thing which has to be exploited actually. And I'm sure in the years to come, that is going to happen actually. I also take this opportunity to thank the organizers and Professor Satish Babu and all the faculty members who have given me an opportunity to speak about this. I wish this conference all the very best, lots of interaction, networking, and data dissemination happening, lots of learning. And with these few words, I inaugurate the second edition of this conference on advances in naval and ocean engineering. Thank you.
Thank you, sir, for such an insightful and informative talk. Our conference is graced by the esteemed presence of Rear Admiral Bimal Kumar, Additional Director General of the Warship Design Bureau in New Delhi. Rear Admiral Bimal Kumar brings a wealth of experience and profound insights in the field of naval architecture and shipbuilding. His remarkable career in Indian Navy has been marked by significant contributions and leadership in the domain of warship design and construction. We eagerly anticipate the invaluable insights and expertise he brings to our discussions today. Ladies and gentlemen, it's an honor to welcome Rear Admiral Bimal Kumar. We look forward to the wisdom and experience he shares, guiding us towards a deeper understanding of naval and ocean engineering. Please, sir.
Good morning to all. Dr. Ajit Kumar, Director NPOL, distinguished guests, professors, invited speakers, delegates from the industry, research organizations, authors, and my dear students. A very good morning to all of you. At the outset, I thank the Department of Ship Technology for inviting me to this international conference in advances in naval and ocean engineering as a chief guest. It's indeed an honor and a privilege to be back in the same university, same department from where I passed out almost in 1990, where I graduated 33 years back, that is. The department plays a pivotal role in shaping the future of Indian Navy and the shipbuilding prowess of India. It has produced some of the best naval architects in the country, and it is continuing to do so every year. It's indeed a great achievement, and I sincerely hope that it continues in the same ethos and with more spirit in the coming years. This grand conference and the gathering present here are testimony to the tireless efforts of the department over the last 50 years. We will be celebrating I'm told that next year there's going to be a grand occasion and celebration, and I hope to be able to participate in that. The theme of this conference is extremely relevant in the context of our indigenous maritime industry, which is at the cusp of transformation. The significance of this is the background in which this is happening. It is happening in the present geopolitical scenario, and the focus of the current government in deriving strategic benefits for the nation in the realm of economic growth and achieving Atmanirbharta in defense production. We are well aware that recent advances in autonomous underwater vehicle technology, advanced materials to improve corrosion resistance and durability, underwater acoustics, ocean sustainability, and cybersecurity over the last decades have significantly changed the course of shipping industry world over. I would now take this opportunity to highlight some of the emerging technology which have huge potential in defining the future of shipbuilding industry in the present dynamics. The fourth industrial revolution has made inroads into diverse applications in the maritime world. It is a fusion of diverse technologies and their interaction across the physical and digital domains that makes it fundamentally different from previous revolutions. These technologies have found generic applications in the diverse fields and have also had an impact on mercantile marine and more so in warship building. Against this backdrop, it is essential to examine some of the new technologies that have potential for implementation in ship design and construction, which is the main theme of this conference. Some of them I would like to state here are already deployed or are under deployment within our ecosystem itself. To start with, the VR and AR, that is virtual reality and augmented reality, are revolutionizing design, maintenance, and training in shipbuilding. Architecture of an integrated enterprise-wide solution typical to warships and merchant building consists of a VIS layer, that is visualization and interaction layer, of handheld and head-mounted devices used by workers on board ships under construction or on the shop floor. This is already happening. DTS, that is a data transport system, which is a combination of wireless and fiber optic networks transport data to a DAS, that is data acquisition abstraction system, integrated with the cloud, ERP, third-party software, and mobile edge computing systems to harness the potential of industrial Internet of Things. Then comes the 3D virtual reality models, which are replacing the erstwhile wood or cardboard mock-ups. Stakeholders can now walk through the ship even before it gets off the drawing board to indicate changes as required. Unlike the 2D CAD drawings, which we were all familiar with when we were undergoing our courses, which required deep engineering skills and knowledge, The 3D models are now contributing in a major way in ensuring that the stakeholders can immerse themselves and contributing to redefining the layout and also the piping, mainly the piping and electrical cable routing, the unshipping routes and access for maintenance of a fitted equipment, etc. This obviates rework and optimizes overall cost and build period. We are deriving the benefits even in the naval warship, in the shipbuilding programs also now. AR is replacing drawings, bringing cameras into shipyards and putting computers in the hands of all. It builds on the inputs from the 3D models and is extensively used for training, knowledge management, and to add value in construction activities such as welding, painting, quality control, etc. You must have heard about the various startups which have already started delivering and showing promises in this field. They are also attempting AI applications in the field of optimizing fuel consumption and for undertaking condition-based preventive maintenance. AI-enabled advanced robotics are increasingly used in the workflow of shipbuilding, where RPA, that is robotics process automation, are programmed to perform high volume repeatable tasks. Another area where AI has great potential is in the field of knowledge management. However, enterprise-based applications of AI is increasingly difficult to implement and data discovery remains a challenging task. AI is also expected to play a significant role if autonomous ships and underwater vehicles, as our director, Dr. Ajit sir mentioned here, if it has to become a reality. We are also getting into the field of AI in the field of warship design, how AI can enable us and be the key enabler in moving on to getting the data from existing warship designs, layouts, and integrating them into the future designs. Shipyards are making smart ships by fitting hull monitors, equipment sensors, machinery diagnostics, devices, and CCTVs, etc. during the construction, and integrating them with compatible software platforms provided by global mobile satellite operators to implement the IoT for real-time expert system support from a remote location. Large volumes of data available from ships at sea are transforming maintenance as well as accurate planning of forthcoming refits, sorties. These are also the building blocks for improving the design of the follow-ons and will help in the evolution of autonomous ships. We are already in the process of doing this, and we hope to carry it forward in a better fashion in the coming designs. Ship design is shifting from analytical calculations to computational methods. With an increase in computational powers, these tools are now being used for early estimation of the ship's parameters, which were otherwise calculated either by model testing or by physical validation. We are not there yet. We are in the hybrid stage now, where in which we have the computational methods as well as the model testing being carried out. Such tools have found increasing application in optimization of hydrodynamic parameters and signature management. Digital twins are also being effectively used for configuration management of the platforms. 3D printing is another area which has found application in the generation of the scale models of ships during design for hydrodynamic research. We have just taken baby steps in some of them now. Use of 3D printed models makes it possible to undertake more iterations for early finalization of design and creation of models for better appreciation of the customer. The technology also has wide-scale application at OEM level for component manufacturing and during the life of the ship for undertaking repairs at the shipyards. Coming to the last point, which is the blockchain technology in the whole network. The blockchain can integrate the entire supply chain of designers, financiers, subcontractors, equipment and material suppliers, quality control inspectors, auditors, and customers. The transparent and secure transactions inherent to the blockchain technology will ensure that multiple agencies involved at each stage of construction are on the same page, ensuring trust and removing bottlenecks caused by communication gaps. This technology can also be effectively integrated with the PLM solutions being used by the ship designers and shipyards. This is an area which we have not The blockchain is an area which we have not yet stepped in. We would like to. And to conclude, I would reiterate the significance of technology development in the maritime domain and safeguarding our maritime interests and emerging as a driver of indigenization and innovation in this quest. However, this would require sustained efforts by the industry. To achieve this goal, the R&D and capability development at the concept level is to germinate, incubate from the academia, in which the Department of Ship Technology, CUSAT, is at the forefront. I wish this conference a grand success and hope that new initiatives in the shipping and shipbuilding technology emerge from the global leaders and think tanks gathered here to further enhance a sustainable technological development in the shipping and shipbuilding industry. I have just touched upon certain key technology areas in which we are already stepping in or would like to step in. So I would look forward to the proceedings of this to see where we can move next and with how we can move next. And to that end, I wish this conference a grand success. Thank you all. And not the last, but I would certainly thank Dr. Satish and Dr. Shivaprasad for giving me an opportunity to be here to my alma mater. And incidentally, I'm sorry to state that this is the first time I'm coming back to the department after my graduation, mainly because I was never had an opportunity to be posted in Cochin. Otherwise, I would have loved to. And I hope to see the proceedings of this conference so that, as I mentioned before, I'm sure that there will be many cases which we would like to take forward. Thank you all. All the best.
Thank you, sir. As we move ahead, I request the chief guest to kindly release the conference proceedings, a repository of scholarly works and research contributions. Please, sir. Thank you, sir. The stage is now set to honor and felicitate individuals whose expertise and dedication have significantly contributed to this field. Let's welcome Mr. Sumitran Sampath, General Manager of Class NK Japan, for the felicitation. Please, sir.
Respected Dr. Ajit Kumar, Director NPOL, Rear Admiral Bimal Kumar, Warship Design Bureau, Indian Navy, Dr. Satish Babu PK, Head of the Department, Dr. Shivaprasad, dignitaries of the dais, faculty members, delegates, ladies and gentlemen, a very good morning. It is indeed a privilege for me to be here in the inaugural session. And, such for on the second edition of the iCANOE 23. I was there for the first edition also, but I was a delegate. And such conferences provide an ideal platform for various research scholars to present their papers, also showcase the research that they have carried out. And it is ideal such conferences be held in academic institutions like the Department of Ship Technology, because the students can benefit from hearing these research, the prevalent research that is going on today. And in addition, they can also benefit from hearing the eminent speakers speak about the topics that are very relevant to today's industry. Research is very important for any economy to grow, and such conferences also provide us with a great opportunity to enhance research. Unfortunately, in India, research is restricted to few government and academic institutions. Though the quality of research has been validated by outcomes of construction of indigenous technologies and construction of indigenous aircraft carriers, our Chandrayaan missions and Mangalyaan missions, it is still not reached an optimum level because there is still a lack of funding, adequate funding or participation by the private sector. But I hope that as Indian economy grows, this will change and we will have more private participation, because for any economy to grow, research is going to be very important. I come from an organization, Class NK, where research plays a very important role for us because our rules are based on research. We also have many awards in various institutes across the world as a means to encourage research activities among students. And as Dr. Shiva Prasad said earlier today, we are having awards instituted at CUSAT. Also, we have 3 awards, and which will be presented later today. And as you know, there are 2 hot topics today in the maritime industry. That's digitalization and decarbonization. And in both these aspects, research plays a very important role. And research becomes the backbone for developing new technologies and futuristic technologies. And therefore, I take this opportunity to really thank and appreciate the organizers and the faculty of the Department of Ship Technology, CUSAT, for their painstaking efforts to organize this conference. I also hope the delegates could find the various papers interesting and take away some new concepts and ideas in this conference. Thank you.
Thank you, sir. Now I invite Dr. D.D. Ebenezer, Adjunct Professor from the Department of Ship Technology, for the felicitation. Please, sir.
Good morning to everyone, and a special warm welcome to Rear Admiral Bimal Kumar, Dr. Ajit Kumar of NPL, and Mr. Sampath Kumar, and Mr. Anthony Prince, as well as former director of NPL, and who are sitting off the dais. All our speakers who are here, thank you for coming. I've been very happy to be in the Department of Ship Technology in CUSAT for the past 3 years. And I'm happy to see that the second conference is being organized. It is the brainchild of our head of the department. And so we should give him thanks for bringing together here many people. Conferences are part of an ecosystem. I think we should not see them in isolation. We have to see it as part of what the department is doing. Conferences serve many purposes. We are very grateful to our sponsors for giving us money to run this conference. We are grateful to them for being here. We're grateful to them for providing job opportunities to our graduates, students who come out of the BTech program, the MTech program. When an R&D institution runs a conference, the objectives are perhaps a little different. The people there are already employed, secure. Whereas when a department runs a conference, we have different aims, we have different goals. As I said, this is part of an ecosystem. So the conference is there to encourage research within the department, primarily. Ideally, you would like to see a large number of papers in the conference based on work which is done in the department. So even today, as we are in the midst of the conference or just at the inauguration, we have to think ahead to iCANOE 2025 and see what we can do to make it what it should be. While we are happy to be where we are, we need to think ahead. Research in the department can be done at various levels. It can be done at the PhD level, MTech level. I don't think we are present, we are in a position to say that our BTech research level is very strong. But if you look at the institutions who have a higher NIRF ranking, you will see that their BTech students are doing a lot of work. We are very blessed because people with the highest CAT ranks come to our department, partly because a job is virtually assured for them when they graduate. And we need to find a way to tap this intelligence, the hard work that can come from the BTech students. So we have made a start with the MTechs, and I think we need to carry this forward to the BTechs and see how we can tap their potential. I'm glad that our sponsors are here so that they can come and talk with the department and see what is happening here. Perhaps the research in the department is not very well showcased in this conference. We'd like to see it showcased in a better way. And I think the conference organizers ought to think about how and where we should peg our conference level in order to induce our researchers to present their work here. If you peg it at the right level, then you will get more big papers being presented here. I think we need to think about that. And today, whether your conference is indexed, whether your paper is going to be accessible to people around the world is very important. And so I think we need to think about that while deciding on how we are going to publish the work that is presented here, how to make it available to more people, etc. Let me thank all the conference organizers as well. A lot of faculty have put in a lot of effort. Students are there who have put in a lot of effort. Thank you one and all, and I hope that our research findings will be of interest to everybody. Thank you.
Thank you, sir. Now it's time to honor our dignitaries with a token of appreciation. Let me invite Dr. Satish Babu PK, Head of the Department of Ship Technology, to present the memento to Dr. Ajit Kumar K. Now I request Dr. Shiva Prasad K to give away the memento to Rear Admiral Bimal Kumar. Let me invite Head of the Department, Dr. Satish Babu PK, to give away the token of appreciation to Mr. Sumitran Sambat. Please, sir. Thank you, sir. Before we draw this inaugural session to a close, let's extend our gratitude to all who have made this event possible. To express our thanks, I request Dr. Fawaz TK, the convener of iCANOE 23, to deliver the vote of thanks. Please, sir.
Good morning, all. First of all, I would like to express sincere gratitude to the president of this inaugural function, Dr. Satish Babu PK, who is also the chairman of the organizing committee of iCANOE 23. In fact, Dr. Satish Babu PK can be called as the founder of iCANOE, as he was the convener of first iCANOE held in November 2021. The first iCANOE was held as part of Golden Jubilee celebrations of CUSAT, as he mentioned, while the second iCANOE is at the verge of the start of Golden Jubilee celebrations of the department. Realistically speaking, his diplomatic administrative skills, vision in academics, passion for research, extraordinary global relationships, and active networking turned this period into golden days of the department. As far as any extension and outreach activities are considered, in his great vocabulary, we cannot see the word no. Thank you, sir, for your invaluable support for the conference. Then I would like to extend my sincere gratitude to Rear Admiral Bimal Kumar, who is one of the most prestigious alumnus of our department, for attending our conference in the capacity of chief guest of the day. Today, we are truly proud. Thank you, Admiral Sir, for traveling the whole way from Delhi in spite of his busy schedules and for showing the true spirit and love towards the alma mater. Thank you, Admiral Sir. Now, I would like to express gratefulness to Dr. Ajit Kumar K, Distinguished Scientist and Director of NPOL, for inaugurating iCANOE 23. It was my first visit to NPOL, a fantastic research laboratory, last week when we went to invite Dr. Ajit Kumar Sir. His readiness, willingness, and humbleness to accept our invitation was truly inspirational to us. Thank you very much, sir. Thank you, Dr. Sumitran Sampath, General Manager of Class NK, for facilitating this event. We have a prestigious Class NK award function happening this afternoon itself in the same venue. Thank you very much, sir, for all your initiatives to motivate our students and the department in promoting naval and ocean engineering studies. Thank you, sir. Thank you, Dr. D.D. Ebenezer, sir, Adjunct Professor of the department, for facilitating this event. Really, Dr. D.D. Ebenezer is the spirit and soul of research in the department. His contributions in the computational hydrodynamics and structural engineering lab, our CHASE lab, is really invaluable. Thank you very much, sir. Thank you, Dr. Rajesh P. Nair, the convener of the conference, for providing precise overview of the conference. His sleepless involvements for the conference for the past 6 months really made this conference in this manner. Thank you very much, sir. Now, I would like to extend gratitude towards Dr. K. Shivaprasad, former head of the department, who cherished us with an enlightening opening speech delivered in a philosophical and psychological way, packed with the historical highlights of the department. Thank you very much, sir. Thank you very much, Mr. Arvind K.R., joint convener of the conference, for all the support, and Dr. Hasina K. also. I would like to express sincere gratitude towards all the keynote speakers. We are having Mr. Anthony Prince, sir, here of SERS, Dr. Anantanarayanan, sir, of NPOL, and also we have invited speaker, Dr. M. Ravi of NIST here, and our presenting authors like our former HOD, James KJ, sir, and Captain Nitin Agarwal, and the presenters from IRS, the presenters from NPOL, and also the Mr. Girish from S1 Maritime, Mr. Anu from SERS, and all others who came for presenting the papers, and the co-authors, participants, our active BTech and MTech and PhD students, faculty members, technical staff, office staff, our SNAS, DOSTAS, and CUSAT administration for their active involvement. Last but not least, I would like to express thanks to our sponsors, SERS, S1 Maritime, CSS, ARIS, and Naval Research Board of DRDO, and RINA for their support. Thank you all.
Thank you, sir. With that, we conclude this inaugural session of the second International Conference on Advances in Naval and Ocean Engineering, iCANOE 2023. We hope that the proceedings of today set the stage for an enriching and enlightening conference. Thank you all for your presence and active participation. Right now, let me request to assemble now at the department entrance for a group photo. Thereafter, let's have the high tea arranged outside this conference venue. Thank you all.
Hello. ഹലോ ഹലോ എടാ, ഞാൻ അവിടെ നിന്ന് ജസ്റ്റ് കാഷ്വലായിട്ട് സംസാരിക്കാം. നീ ബാക്ക് കേൾക്കുന്നവർക്ക്, അതായത് ഒരുപാട് സൗണ്ട് അല്ല, ജസ്റ്റ് സൗണ്ട് കേൾക്കുന്നുണ്ടെന്നോ? അത്ര ആ ഒരു പൊസിഷനിൽ ഇരിക്കുന്ന സമയത്ത് ഞാൻ പറയുന്നത് കേൾക്കുന്നുണ്ടോ? ആ, അതല്ല, സിഗ്നൽ കുഴപ്പമില്ല, പക്ഷെ നമ്മൾ പറയുന്ന കാര്യങ്ങൾ കുറച്ച് സൗണ്ട് കൂട്ടണം, കുറച്ചുകൂടെ സൗണ്ട് കൂട്ടണം അല്ലേ? അത് ഒഴിവാക്കാം. ആ, ബോക്സസ് അവസരം ഇപ്പൊ ഞാൻ പറയുന്നത് ക്ലിയർ ആയിട്ട് കേൾക്കുന്നുണ്ടോ? ഐക്കനോയിൽ ഇപ്പൊ ഞാൻ പറയുന്ന കാര്യങ്ങൾ ക്ലിയർ ആയിട്ട് കേൾക്കുന്നുണ്ടോ? അത് സൗണ്ട് കുഴപ്പമില്ലല്ലോ? ഹമ്മിങ് വരുന്നുണ്ടല്ലേ? ഇപ്പോഴാ എളുപ്പമുണ്ടോ? ഹലോ ഹലോ, സംസാരിക്കുന്ന സമയത്ത് എരപ്പ് കണക്കുണ്ടോ? ഹലോ, കുഴപ്പമില്ലല്ലോ. അത്ര ബാക്ക് പണ്ടോ, ഇവിടെ എവിടെയെങ്കിലും ഇരുന്ന് നോക്കി. അവിടെ എന്തായാലും അത്ര കാണും, ഇവിടെ എല്ലാവരും ഇരിക്കുന്ന. ഹലോ എടാ, മറ്റേ എടാ, ലാപ്പില് അവിടെ ഞാൻ ഇപ്പൊ മ്യൂട്ട് ചെയ്തേക്കണം സൂമില്. അല്ല, ഞാൻ ജസ്റ്റ് സംസാരിക്കുന്ന കാര്യം കേൾക്കുന്നുണ്ടെന്ന് അറിയാനായിട്ട്. ടിവിയുടെ അടുത്ത് ഇതുണ്ടോ? സ്പീക്കർ ഇവിടെ മ്യൂട്ട് ചെയ്തേക്കല്ലേ? അല്ല, ഇപ്പൊ സംസാരിച്ചു കഴിഞ്ഞാൽ അവിടെ സ്പീക്കറിൽ ഇട്ടേക്കല്ലേ? കേൾക്കൂലേ? ഇപ്പൊ ഇവിടെ സംസാരിക്കുന്ന കേൾക്കാൻ കുഴപ്പമില്ലല്ലോ. അല്ല, മൈക്കിന്റെ അത്ര വരില്ല. ഇപ്പൊ സംസാരിക്കും, ജസ്റ്റ് കേൾക്കുന്നുണ്ടല്ലോ, അത്ര. ഹലോ 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 ഹലോ, എത്ര സൗണ്ട് പോരെ? അവിടെ കേൾക്കുന്നുണ്ടല്ലോ. ഒന്നുകൂടെ ചെക്ക് ചെയ്യണം. അവിടെ കേൾക്കുന്നുണ്ടോ? ഓക്കെ. ഇപ്പൊ ജസ്റ്റ് സൗണ്ട് കേൾക്കുന്നില്ലേ? സൗണ്ട് കുറവുണ്ടോ? പക്ഷേ ഹമ്മിങ് വരുന്നുണ്ടല്ലോ കൂട്ടുമ്പോ. അല്ല, ഇപ്പോഴാണോ? ഇപ്പൊ ഓക്കെയാ? ഇപ്പൊ സൗണ്ട് എങ്ങനെ? കുഴപ്പമില്ലല്ലോ. ക്ലാസ് എനിക്ക് ബെസ്റ്റ് പ്രൊജക്ട് അവാർഡ് 2014 വരെ ഹമ്മിങ് ഉണ്ടോ ഇല്ലല്ലോ ശരി അങ്ങനെ ഞാൻ വിളിക്കാം ഞാൻ ഒന്ന് ഫോൺ ചെയ്തേ
Okay, then.
The first keynote session will about to start. I request all to gather the conference venue within 3 minutes. Welcome all. Now I invite our head of the department, Dr. Satish Babu PK, to introduce our esteemed keynote speaker.
Good morning and welcome back, dear delegates. So we are going to start the technical sessions. First, we have a keynote address by Mr. Anthony Prince. I got some brief from SEDS about you, sir. Mr. Anthony Prince is the president of GTR Campbell Marine Consultants, GTRC, and also Smart Design Solutions, SEDS. SEDS is also one of our sponsors for the conference. Mr. Prince was educated at TKM College of Engineering and is a chief engineer by training. He had 14 years stint in Japan with the legendary GTR Campbell. Mr. Prince's association with Cochin Shipyard has been from 2004, when he successfully negotiated a 6 numbers 3,000-ton deadweight bulk carrier order for the reputed Clipper Group based in Denmark, Bahamas. The 6th vessel was delivered more than 100 days ahead of schedule, earning the yard a substantial bonus payment. That was one of the achievements. Understanding the need for a world-class design house in India, Mr. Prince set up SEDS, Smart Engineering Design Solutions, in 2006. SEDS has developed many designs for vessels ranging from high-speed petrol boats to fuel-efficient bulk carriers, and developing indigenized design capacity for naval vessels, which is very important considering the national security. Apart from this, Mr. Anthony Prince is a thorough gentleman. He is fully committed to the growth of shipbuilding in our country. He is part of many statutory committees. He is advisor to many government agencies. He has got business not in India and abroad, and the department in iCANOE especially is really fortunate to have you, sir, today for the first keynote address. I'm sure it will be very interesting. So after the address, if delegates want to have any questions, you are free to ask. With this brief introduction, let me invite Mr. Anthony Prince, sir, to take over the proceedings.
A very good morning to all of you. Commodore Satish Babu, faculty, students, alumni of CUSAT. I'm asked to speak on 2 topics. One is the importance of design in shipbuilding. And the second is the future opportunities in naval architecture and ship design. So I'll deal with one by one. The success of a shipbuilding project and its profitability is determined on the drawing board and not on the building berth. So how do you make a design, an optimum design that satisfies all the stakeholders? That is the key point to understand the end user's requirement, the one who's getting this product. It must be fit for service. So as a designer, your role starts way before everyone else by understanding the utilization of the platform, as well as the operation of the platform. That's only one part of it. So this helps you to come up with a concept that will be acceptable to the end user. But the end user is not the only stakeholder in this whole business. The next comes in commercial ship, it is the owner, whereas the user is a charterer. But in the case of naval platforms, it is the Navy or the Coast Guard, that's the end user, and they are also the owner. So we need to now understand the owner's needs. Of course, in the commercial world, the owner is there to make money. So whatever product that you are making, you're designing, it has to make money. How do you do that? First of all, keeping the capex, the capital cost, as low as possible. That's not the only thing. The OpEx also plays a big role in the life of the vessel. So you need to keep the OpEx down. So that's fine. You have satisfied the ship owner. Then comes the ship operator. He need not be the ship owner, but it could be a technical manager or a commercial manager. So we must have sound knowledge how this ship is technically operated and commercially operated. So the designer will now come into play with designing of the systems, the maintenance of the systems, the monitoring of the system. So that is, again, should be the knowledge of the ship designer. Okay. Now it doesn't end there. Now we are coming to building of these ships. So the shipbuilder comes into picture. What are the two things what the shipbuilder wants? It should be the easiest ship to build. For that, what you need to know how ships are built. So just being a drawing board designer doesn't help you. You need to crawl in the tanks and you want to climb on the ships and see how the ship is really built. Okay. So this is why and how you can produce a buildable ship. And he also has to build it at the least cost, because the price of a ship is not the cost of a ship. The price of a ship is a market price. We can say it is going to cost me $25 million to build the ship. But if the market is only for $20 million, then that's all you get. So you really need to get a $25 million for $20 million and try to stay afloat. So that's the role. There also the ship designer plays a big role. Okay, so the designer's playground is very vast. It starts from conceiving to scrapping. Okay, so the entire life. Now what has happened today is there is disruptive change in shipping and shipbuilding, mainly because of decarbonization and digitalization. So what we have to do, we have to unlearn, relearn, and find adaptable to the new technologies and new demands that is put on us. So many of us old timers, we really had to start from scratch, learn from our juniors about all these type of things. And decarbonization itself is a very complex and very wide area where we are talking about multiple solutions to reduce the carbon footprint. There is on one side multiple fuels, carbon-free fuels. Then there is about the electric propulsion. Then there is wind-assisted propulsion. So a whole host of new things are coming up. A lot of these things are very old technology, like Flettner rotor or wind sails, but they were not required to be applied because oil was cheap and free and pollution was not a concern. But these technologies have now become commercially viable because of the pressures that is being put on the industry with regard to the fuel. So the young people like you, the students, you have the whole world open to you because we are almost same as you. We both are studying from scratch, you know. So You have a better advantage because you're a lot younger than us. Your absorption capacity is better. Your thinking capacity is better. We may have some experience. So there's absolutely a great opportunity for the up and coming naval architects and ship designers. So when it comes to the design itself, we also have to optimize the design. Once we have, anybody can make a design, but can you make an optimum design? That is where everything lies. So today, there has been a lot of tools that is available. For example, CFD. That is something that was not accessible previously or freely available, but it is very commonly used nowadays. There are also various efforts that is being made to increase the efficiency of the vessels. So many devices have come up, like Navy's duct or rudder bulb or low friction paints. There's a lot of devices. So that's all okay. Individually, they all have certain percentage of advantage. But when you combine together, how does it work? So it all opens up lots of opportunity for designers, students, people involved in the development of designs. There's a huge opportunity in front of you. When we all came up, we just designed one standard ship and that's okay, it sells and it goes on. But today, first of all, designs are compared. There's national and international competition with regard to the competitiveness of a design. So we need to go and enter into all these domains, which was not necessary so much when I was a young designer. And but it also gives you an opportunity to research and develop and improve on designs. So that's when we talk about the very hydrodynamic efficiency of a ship's hull. But that's not the end of the story. But today we have also very wide application of finite element analysis, application of all kinds of softwares in structural design, and how can we reduce the steel weight at the same time maintaining the structural integrity. So that becomes a subject itself. Now, with the structural design, also now comes to various aspects that is mainly applied to naval platforms, but it is also coming into commercial shipping. One of the things is underwater radiated noise. That is very critical in terms of a naval platform. But it doesn't end there. Today, it is extended to research vessels, commercial vessels. For example, the vessels that are operating along the Canadian coast, they are now asking for underwater noise control. So right from day one, when we start designing a ship, we have to design for less noise. The killer whales in the Canadian coast are disturbed by the noise produced by ships. So certain ports have now required that the ships design based on these requirements. And DNV has come up with a silent notation, and there are some other classification societies are coming up with their own rules and regulations. And we are actually presently getting involved with a ocean-going lake project, where the ship will also go into the Great Lakes and it will also go out of the ocean going. And that will be probably the very first ship where the silent notation has to be applied. We have to all study from scratch. None of us were taught that in our university or when we were doing. So it's a lifelong education, lifelong research, which makes it very interesting for those who are academically oriented, those who are interested in research and development. This is great, the opportunity that is on. So you go on that in every section, there is an improvement that is taking place from a conventional ship design to modern ship design. So at the end of it, all this knowledge is contributing to a better design from sustainability, habitability, operability, and environmentally responsible product, because we really now have to see the carbon footprint right from the raw materials till the ship is scrapped. So the face of ship design has really changed in the very last few years, giving challenging opportunity for ship designers. And the net result is you're coming out with a product that is economically viable to build and operate. And the competitiveness of nations will be determined that how competitive design that your country's fleet has. Because after all, you know, commercially, 80% of the goods move on ships. So many people are not realizing this one. For example, we do get requests for proposals and things like that are not properly engineering-wise prepared. So as a result, we end up compromising the design. Whereas if we spend some time and effort and money, then we can have better RFPs and better product. It is very difficult to improve a product once you have been tied up with an RFP that is not properly researched and properly matured, you know. So as an industry, there are both. In commercial shipbuilding, there is more research done before an RFP is issued. Whereas in the naval platforms, it's both, you know, yes and no. We do find challenges once we start designing the ship, that there are certain requirements we are not able to meet on the ships. So that is an area probably that we can think about. And also, as naval architects, you know, you are all going to grow up and become seniors and controlling shipyards and other decision-making area. One regret I have is that there is very less understanding and respect for design, even among naval architects, when they are in a position of power. So today, design cost is haggled like a fish market. And the cost is never more than 1% of the ship's cost. So very little money is there for all these research and development, that some way or other you make the drawings and submit, and that gets built. So we need to have respect for ship design, which I find regrettably not there in India. So then product suffers because there's lack of money and lack of talent that is utilized for developing the design. So this has to change. Our own company, SEDS, is trying to maintain a high standard in engineering and also somewhat decent returns we expect. And unfortunately, that has not spread among the industry. So we find it extremely difficult to sustain a high quality with a reasonable compensation. So all of you who are going to grow one day, please respect your own profession and the value of that profession and how much it can contribute to shipbuilding. Now, I'm sure that I don't have to say anything more about the importance of design. We are involved for last 15 years in India with the establishment of smart engineering and trying to support the nation and provide the state-of-the-art design. So that is equivalent to any international design. The proof of that is that we are requested by international clients to provide design. So recently we made a breakthrough into European market where there are almost 30,000 European short sea ships, which is less than 10,000 ton. And they are a monopoly of European designers and of course, European owners. So when we made a design and provided to Danish owner, the traditional design companies told that is not a buildable design, that we are making tall claims and we are just a copy-paste people. And that was the thing. But the ship owner stayed with us. But at one point, the same designer approached the ship owner and told him, now we can do sets design and we can meet all the claims that they have made, you know. So they had to eat their own words. See, that has established us as a designer in the European market. So one thing you have to understand, we are second to none. We are brilliant, smart people. And if we put our mind, we can achieve anything. And so I want you to think beyond India, think global, because that is our potential. And with regard to the opportunities, this is the golden time in shipbuilding. For the next 20, 30 years, we need to replace 30 to 40,000 ships because of decarbonization and digitalization. So the opportunities galore for all of you in future, either working in India or working abroad. This is where I want to touch upon to all of you. I am one who got benefits by getting educated in my engineering in India. But of course, I graduated in 1968. At that time, there were 60,000 unemployed engineers, and we would be happy if we could get a lower division clerk's job. It was that bad. That was the time that when I researched, I found out there's an opportunity to go out to sea if I got a year's apprenticeship in one of the shipyards approved by DG Shipping. So I decided to take it up and I got a job and I joined the ship. And when I joined the ship and I started operating the ship, I started feeling this could be done better. This could be done differently. And whoever who designed the ship really didn't have a clue how it is operated, you know. So that is the start of my career in ship design. So the moment I got a chance to get involved, I started making the changes that I wanted when I was sailing on the ship. The first of all, one of the changes that was made, that we design an engine room that would be closed on a Friday evening and open on a Monday morning, giving the engineers a weekend off. That is a 36-hour unmanned engine room with no control room in the engine room. You know, everything is controlled from the bridge. But then likewise, so many changes were made. So the immense pleasure that you get, that something that you recognized to be changed can be changed and it becomes the industry standard one day. So how many engineers have that opportunity in other industries? So here you have great, you are really creating a benchmark in the industry with your designs. So your trademark, your nameplate is global now. And when the industry start adopting your standards, that means you know you have reached there. So immense opportunities, but you really have to decide whether you are looking for a career or whether you're looking for a job. There are two kinds of people. Some people are happy with a job. And if it's a government job, it's even better, done for life. Now I only have to look for my pension. But there are career-oriented people. They are not satisfied with a job, but they are really interested in their profession. So I want you to be one of that. And when you do that one, you really have to decide what's your vision, what is your dream, what is that you want to do in life, short term or long term. That's okay. But you need to have that understanding. And then you have to find out the right company or institution to work so that you get that opportunity to grow. One of the things that we don't really research so much is what type of company we are going to apply for. Okay, let's apply to Cochin Shipyard, let's apply to Mazagon Dock or whatever it is. But does that company's activities meet with your goals? So you really have to find out where you can find that balance of a job and a career. So I was very fortunate. In 1972, I came across a book. The book name is this: What Color is Your Parachute? So today I'm going to brought a copy to give to Dr. Satish Babu. So all of you are interested. This one tells you before you jump, you look at where you're going to land. The entire career selection. It is a bestseller even today after 50 years. This book was published in 1972. 2022, it is the bestseller. So I would like you to read this book before you make that decision to decide where you want to start your career and which path you want to take. That's exactly what I did. And that is where I ended up. There's also another book called Psycho-Cybernetics. That is automatic goal-seeking mechanism. That means if you settle the right goals, you will automatically reach it. It's also a book. It's published in 1965, still a bestseller today. So I was very fortunate to come across these two books and not only read it, but apply it in my life. So that explains very simply where I reached to this position. On top of all these things, I want to tell you something else. We need to have patriotism. Patriotism, when I say our obligation to our motherland. So we often forget that obligation and we look at obligation to ourselves or our family and we go away and do things. The country is investing in us, and we really need to give back at some point of our life, whether it's early part or later part, we have to think about it. So that's the reason I came back to India. I was very comfortable, but at one point I always wanted to come back to India, but I never got a chance and give all this know-how, data, legacy experience of an 80-year-old company with 600 ships to its credit. But I got that opportunity in 2003 when I came to Cochin Shipyard. There was a time that the shipyard needed help, and I decided that I could provide that help. And it was a huge success story, as all of you know. Then I realized that the euphoria will not last very long unless we have ship design capability. And as a country, we are becoming self-sufficient. We are growing and things like that. So we built up a design company from scratch. Thanks to CUSAT, we have a number of brilliant CUSAT graduates in our company. In fact, our general manager, Hari Raj, has been a general manager for the last 13 years, and he's only 40 years old, and he is probably one of the most respected ship designer in India and abroad. So that's a CUSAT product. Now we are probably 75 strong. But more than being 75 strong, these are 75 are experts in their own fields. And today, when the country need support in design, we are there to provide it. And we are waiting for this moment. Actually, I was not to be here. I just came on an emergency call for a very strategically important project that's very much part of making the Indian Navy a blue water Navy, So we are happy that we could come up with the indigenous expertise to assist in this kind of project. So all of you, please don't forget your obligation to the country at one point of time in your life, and also your individual social responsibility. The individual social responsibility, when I tell all my graduates that you should provide maximum internship to the students, because once you were students, you had already hoped that somebody gave me an opportunity as an intern. So you should intern, you should interact with your alma mater, and you must take classes. For example, I think Vivek has taken classes here, and have that interaction between academia and industry, and also to look after your youngsters so that they are inducted to the profession the right way. So that social responsibility is also very important. And the opportunities, you really don't have to worry for a job for future. There is plenty that is coming. But the only question is that the country and we should be ready to take that challenge, because when all these orders come into the country, we must have sufficient number of shipbuilding engineers, ship design engineers, not only just naval architects and marine engineers. That's a different thing. So I wish all of you who have taken this great profession of naval architecture all the best in your future endeavors, and wishing you all good luck. Thank you very much. And if anyone wants to talk to me personally, I'm always available. Thank you.
We can take one or two questions, anybody? So I think
I will be happy to take any questions.
I'll be the first one to read it, and then I will distribute. I think many of us can't talk without a slide, and it's great that you came and spoke from your heart out, and that will come only when you have a vision for the company, for the profession as a whole. It will come only if you are involved in a company which is developing future designs. You know what is coming in the policy. So I think the talk was, I think the messages that was put subtly through the talk, I think everybody would have got it. And I think, sir, with the shortage of time, they can come to you. For one question, we can take anybody. Sir, okay. So Dr. Ravi from...
From the design perspective, ship is a very massive structure.
Yes.
The fresh engineer, when he is coming to the job, his exposure to design aspect will be limited to very few things, like component or subsystem or small systems. How much time in his career he will be spending to learn things, to be a student, to be an expert designer when completed the entire studies?
As you know, the learning never stops. It's a lifelong learning, and I think there is no specific period you can put, because you are maturing every day into a different grade. But I would roughly put, for a smart person, 2 years. For another person, probably 5 years. If he's dedicated, that's all required to capture 90% of ship design. The rest 10% is refinement, and for which he need not be the only person who's contributing in a project. His seniors would be contributing. So I would say 2 to 5 years. That's a good period. We do take a lot of fresh graduates and train them up and to be independent designers. Maybe even less than 1 year, they are able to start handling by themselves. Because, you know, they do have very good academic foundation, but they don't have the application of that theoretical knowledge into practical thing. So that transition is what we are trying to do. But generally people do pick up very, very good, especially CUSAT graduates, you know.
That was a compliment.
Yeah, no, it's true. But we employ several of CUSAT graduates with us, and they definitely are a class above everybody. Thank you.
Okay, ladies and gentlemen, please give a good round of applause to Sir. I have a small token of appreciation.
Distinguished guests and esteemed participants, welcome to first session of iCANOE 2023. We are gathered here to exchange ideas and open discussions on the topic materials and corrosion. Without further ado, let's dive into our promising schedule. Now, it's my pleasure to welcome our session chair and co-chair who will be guiding us through this enlightening session. This session will be chaired by Dr. M. Ravi, retired Chief Scientist, National Institute for Interdisciplinary Science and Technology, Trivandrum. And the session will be co-chaired by Professor Dr. A. Madiyalagan, Department of Ship Technology, CUSAT. Professor Dr. A. Madiyalagan joined the department in 1994. Presently, he is working as professor and former head of the department. His qualifications are MSc Applied Science from Anna University, Chennai, ME in Metallurgical Engineering from NIT Trichy, PhD from Cochin University of Science and Technology. He has published more than 70 papers in both conferences and journals. He is a member of Bureau of Indian Standards and chairman of Board of Studies, CUSAT. He has organized conferences and seminars within and outside CUSAT and is a reviewer of journals in material science and corrosion engineering. He has served in various academic bodies in and outside CUSAT. He has attended around 21 short-term training programs in his chosen area. His fields of interest are material technology, corrosion engineering, welding technology, failure analysis, and nano-composite materials. He has delivered around 15 invited talks in seminar, conferences, and training programs. Now I welcome Professor Dr. A. Madiyalagan onto the dais to introduce our session chair.
So this first session is about materials for the ocean engineering and naval architecture. And every product, whatever the product you are developing or producing, is based on the materials. Without materials, we cannot produce any products. So with this intention, we have started with the first session, which is going to be chaired by Dr. Ravi. He is a retired chief scientist from NIST, Trivandrum. He worked in various capacities in various research institutions. He is basically a metallurgical engineer. I graduated from Government College of Engineering, Salem, and then he moved to IISc Bangalore, where he did MSc Engineering in Metallurgy and PhD in Metallurgy, and followed by which he also moved to German under that fellowship, has completed his short-term research there, and after that, he also worked in various industries, including Hindustan Aeronautics Limited, Bangalore and Orissa, and also he has served as visiting professor in various institutions, universities, in and abroad, and he is advisory committee member of Advanced Manufacturing Technology from 2016 to 2021 in DST and also VSSC. He has been awarded various accolades and awards, and he has contributed to research community in the form of publications. He has also guided a research scholar from various institutions. And with this brief introduction about Dr. Ravi, I invite Ravi to chair the session. Thank you.
Shall I say good morning and good afternoon together? Yeah, it's time is running out. To the given choice of task, I have to complete the session before 1:30. 1:30. That means we have to. Are you audible? Yeah. I think we have to excuse the timings accordingly. I will be the first choice to excuse my timings. I have a presentation to make maybe for more than 45 minutes, but I will try to make it as quick as possible. I'm supposed to talk on the topic called aluminum alloy for shipping, defense, and other engineering applications. Instead of talking only on aluminum, since ship is involved with many materials, I would like to touch upon some of the most important and then proceed to aluminum in a better way. I'm from CSIR, NIST, that's National Institute for Interdisciplinary Science and Technology, situated in Trivandrum, southernmost part of the country, and also similar to our institute. CSIR has 38 laboratories around the country, and ours is one of the interdisciplinary institutions. This is the institute main building where we are located. Coming straight to the technological perspectives, every technology has the period of initiation, sustainable, and also end. If you look at the last 2-3 centuries, first part of from 1771 to maybe 1850, the entire world was focusing only on textile. That time, there was no inventions with respect to engines, machines, materials, but only the human interest was only to cover their body through textile developments. But when it came to the engine invention, rail engine, then only rail and its infrastructure costs started on that. And subsequent to that, automobiles came into the picture in the 18th century beginning itself, and it dominated for almost 200 years now. And next era came from computer. It is 1950 or 60s to 2025. It is up to date. From now onwards, it is apart from computer, it is going to be nanotechnology, electrical, and digital. So many things which we can cover in that. But This is only to give you a perspective where every technology has maturity time and sustainable time and also end by the time new things come to the picture. And in the global level, I think there are many challenges which need to be focused. As a researcher, we need to have some understanding of the entire things. I will not be able to cover all of them, but this I'm only giving you exposure such a way that let us think something which is more, towards sustainable development. Climate is the most important, and clean water is still the need of the country and also for the population at different resources. Going back, everything, there is a big rich and poor gap which need to be brought closer, and health issues are very common, which we have experienced last 4 years, 3 years, which is more important. And education and learning is part and parcel of every development, and everything should be directed towards peace and conflict aversion, which is every day threatening us with so many difficulties. And status of women need to be improved, which is particularly reference to the country, which is we all have to focus on that. This all thing can be possible only when we go into good science and technology with the good global ethics to follow in that. And if you look at the computing capability for the last 100 years, it is tremendous improvement has come, and all of them are putting a very, very different perspective for the future R&D as well as the technologies. Now man is committing himself to compete with machines in terms of its behavior, in terms of its architecture, in terms of its intelligence, and maybe at sometimes whether there is a win by machine or man, we do not know, and it is resting with the hands of the future generations. And we are concerned with a concept called human body 2.0 or 3.0, where the heart is going to be optional. You don't have to worry about heart. This is the situation. You can remove your heart and keep somewhere else, and somebody will operate, some system will operate on that. Sorry, am I? Closed. Okay. Yeah. Okay. Maybe it got pressed here. Yeah. So engineering and future technologies are going to be mostly interdisciplinary in nature. Mostly interdisciplinary nature, and we have to take note of it. As I kept on talking, many of our speakers also spoke about it. The future is going to be on robotics, quantum computing, virtual reality, artificial intelligence. Everything is focused towards affordable life. And coming to the very topic, very close to that, we are going to work on the materials for engineering application, particularly transportation, which involves shipping as the first preference. Any material selection, whether it is for construction, automotive, or aerospace, or military, which involves shipping and biomedical, the performance is one side and the cost is other side. This is the most important thing to note. And the low cost, high performance is the criteria which has to be kept in mind. And also, when you talk about the high performance, you need to have the glimpse of the behavior of the material at different conditions in terms of strength, toughness, ductility, weldability, formability, and so on. All the materials have certain unique properties at different conditions. So the suitable condition or the optimum conditions has to be arrived so that the material can be used in a better way. To be very close, look at it in terms of cost and performance again. Steel has very low cost and also abundantly available. And coming to the high performance, titanium is very costly and also high performance. In between these two comes the aluminum, where I'm going to talk a little bit about it. And materials as a whole, it has two types. One is one of the metallic materials and non-metallic materials. My concern will be to talk more about the metallic materials, particularly steel, aluminum, magnesium, copper, titanium, and so on. And every materials has three characters. One is to understand about the structure, its processing, and its performance, so that the entire properties can be optimized. All this can be done through proper understanding of the characterization techniques. And as I indicated earlier, metals, ceramics, glasses, composites, polymers, these are all constituting the major constituents for the shipping industries. If you remove the aeroplane here and imagine it's only ship, the entire spectrum of activities will be similar to aerospace, where probably we are familiar here, where materials like tubes or plates or things are familiar, which is understood in terms of microstructure and their behavior during operation. But going further deep into that, smaller in sizes, the mechanisms involving like dislocation, motion, precipitation, hardening, strengthening, and so on, and also the configurations, atomic configurations, electronic. This much basic understanding is required in order to put the performance of the transport vehicles, whether it's a ship or aerospace, something. The entire spectrum has to be understood in terms of the size of the information, as also the intricacy of the things. As a whole, material properties required for design. Our design chief was talking many things about design perspectives, but everything has to be concerned with the entire spectrum of activities. Okay. Yeah. The density, thermal expansion, heat capacity, and mechanical properties like tensile, compression, shear, and all these things. Many materials has a combination of all of them. Not all of them are together, and some materials has better properties for one aspect, some are having different properties. So similarly, the understanding of the entire mechanisms are required in order to make a system structure like aeroplane, ship, or anything else. Coming to the shipping industry, the global scenario is given here in terms of the US dollars and the millions of things like that. Similarly, for the Indian shipping also, there is good amount of economy is involved, where the improvement is in this scale. So our focus must be in this regime, where what contributions we can make towards this. As a whole, I'm not expert in any of these design informations except the materials which are required for that. I can only speak something about materials like aluminum, where what contributions it can make. For example, 5000 series, 6000 series, or 7000 series, which are all the alloys which could be suitable for various locations and things. Coming to the materials and its perspective, steel is most important and well known, and it is well developed for long years. But only the super special materials are coming to the picture in terms of R&D. Whereas in the case of aluminum, it is having evergreen situation next maybe 50 years, 100 years, and so on. And the perspective of aluminum understanding is more important to cater to the needs of the industry. Coming to steel and iron, the manufacturing routes are starting from ore to the extraction and melting, casting, and formation of so many products through various processing routes. We need to have the understanding of how the material is made and what type of materials are available in terms of steel. Steel means it is allied with iron and carbon together to form various strengthening regimes. In terms of that, low alloy, medium, low carbon, medium carbon, high carbon steels are available. Special steels like stainless steel, tool steels, and these are all more important. This application of stainless steel is becoming more critical for shipbuildings. And many structures have corrosion resistance requirements, so stainless steel is highly preferred compared to other steels. Similarly, for other automobile and other equipments also, the metal requirements are very high. I am specifically looking into focus on marine applications, where what type of steel and other things can be used, and how the performance can be improved without degradation of its corrosion properties. Steel for submarines is also very important to learn about it. And there are so many steels like 316 and 904. They are all having certain properties at certain locations. How to optimize all of them towards the structure requirements is important. And duplex stainless steel is more important, and some contributions from this institute is also happening in terms of projects. We will be listening to them for the future. Some of the products for duplex steel is also given. Then is a copper alloys. Copper is very popular for long terms, and in terms of brass, bronze, allied with nickel and other elements. We need to have some knowledge about copper, and particularly cupro-nickel is very popular for very high performance materials products. Yeah, with this small introduction to rest of the materials, I will go to aluminum alloys. You can tell times. I will stop it. Yeah, aluminum is basically made from bauxite ore converting to alumina, and with high energy input for the electrolysis process by which pure aluminum is made. And this primary aluminum is allied with aluminum, various alloying elements like silicon, copper, magnesium, and zinc, etc., to make various material, and are processed through casting route, followed by rolling and extrusion, forging, and also. And these products are going into these structures. But now it is possible that recycling is at least to 95% of aluminum can be recycled. That's one great thing from the material perspectives. And the applications starting from oil and gas, where shipping is most important, marine and solar energy, telecommunications, aerospace, naval, defense, everywhere, aluminum is finding very widespread applications. As indicated earlier, the most important factor is cost and the performance together. And in terms of availability, India is ranking somewhere at the 5th level, and producing also India has a good capability. Only thing, converting the high performance material is still the issue, where we are importing a lot of material from outside, where up to 2030, good amount of scope is available. At least 300% improvement in R&D is required to be in sustainable material user for applications like shipping or any other industries. Because aluminum possesses very high strength to weight ratio and density 1/3 of steel, excellent corrosion resistance, weldability, it's very easily weldable and machinable, and availability is also abundant. It is having special properties like high thermal conductivity and also recyclable, which gives a better material for applications in shipping. Alloys of aluminum can be made with copper, magnesium, zinc, silicon, manganese. I will not deal much about its alloy things. And various designations are available, like 2000 series, 5000 series, 6000 series, 7000 series. And one is whenever any material is being referred, it is referred with the designation number. So we have to have some knowledge about it. It is both for the wrought alloys as well as for the cast alloys. And the entire spectrum of processing is initially to melt it and make billets like rod and slabs, which can be further processed through rolling, extrusion, forgings, and so on, so that the required proper products can be made from these alloys. This is one example of Hindalco aluminum, Alumex in the Aurangabad industry, where 32 tons of capacity of melting is possible in one single stroke to make all the high performance materials which is required for shipping as well as for other industries. But only the issue is that they have little scope for any R&D, because the 32 tons means one experiment will cost you something around 30 lakhs, 40 lakhs. So we cannot afford to do it. And we need to have a similar setup in the smaller scale, laboratory scale, to do the various developments of alloy processing. One such effort is direct shell casting facility, which has been established in our institute with capacity like 100 to 150 dia rods and plates can be made and studied for all their properties, so that this can be produced in the industrial scales. And coming to the various products possible from aluminum, which is most important for the shipping industries, the plate making through continuous casting process. And this continuous casting process gives you products of various thickness and length and breadth. This is one facility which is almost like air-conditioned laboratory, where the processing of the aluminum alloy for sheet making is happening. And this is another extrusion process. These are the process by which maybe pipes and other things can be made. Yeah, forging is another technique where material is heated to some temperature and force is applied, so that very different shapes can be obtained, and also the high temperature high performance structure can be made from this. And forging has certain difficulties like oriented microstructure and defect processed in particular directions. To overcome that, there are other processes possible. And most of the alloys like 2000 series, 6000 series, these are all forged and used as a components. And it may be difficult for me to cover all of them information. These are these very important alloys like 5083, 5086, 5454, 6000 series like 6005, 6082, 6061. These are all the alloys which are very essential for shipping industries, where so many components, starting with the decks and hulls of ships, maybe stack enclosures, hulls, all these components can be made from these alloys, where the strength and again the alloying elements are more important to choose which alloy will be more reasonably suitable for these applications. But this is the same case with the aerospace also. And to understand the genesis of the material, one has to look into the details covering from which stage to which stage, how these metals are developed and how much time it takes for any material to be matured so that easily it can be made available for regular uses. One such example I'm just processing is 7050 alloy, starting from its direct shell casting, then rolling and heat treatment, leading to various microstructural refinements, which can give you very high strength, more than steel, such a way that this alloy can be used for multi-purposes. But the microstructural understanding is more important in terms of corrosion as well as the strength performance here. And most important, we are talking about 5000 series with aluminum magnesium alloy, where we are working on aluminum, magnesium, scandium, zirconium, manganese alloys. And this particular alloy is very, very interesting for shipping industries, where it is easily formable and also easily weldable, and high strength also can be obtained about it. And these are the few processes where the microstructural control is possible, like rolling, severe plastic deformation, and so on. And these are some of the these are some of the microstructural characteristics I wanted to share with you. And a very fine microstructure and a very high ductility material with high strength can be made through 5000 series, which is of interest to this. And weldability also is possible. This is friction stir weld to get a very fine microstructure, both in the weldment and other things. And these are some of the contributions we made for ISRO. Some components are already in the space from our institute. And these are the microstructures which has been strengthened through various heat treatment process. And some of the microstructure understanding is based on the phase diagrams of the alloy. The component to be made from these alloys are also just shown for your information. And the skews casting is another area where we are working right now for the cast alloy making, in which liquid metal is subjected to pressure to give very intricate as well as very uniform microstructure to get a very complicated products with very high strength as well as high ductility together in this. And some of these are our facilities, like how we are melting and casting. Some of our students are here who have used it in our institute. And we have very sophisticated instruments for all the analytical as well as the characterization requirements. And this is one of the institutes where all the facilities are available for material characterization, including simulation and other day-to-day activities. This is one facility I'm talking about. It's the skews casting, where recently we have established. And this can be used for making any intricate shapes with very, very focused functional applications. And some of these microstructural characterizations, I am skipping it so that we can go for. This is one example I wanted to show. For the defense requirements, they were looking for a very high strength material. And originally, the material which was having only the 280 megapascal strength with 3% elongation, we converted it to 450 megapascal strength and 3 to 5% elongation, leading to fabrication of very sophisticated components called piston for various big applications in that. Without compromising any of the properties, we have established high temperature as well as strength properties in the room temperature. This is the one perfect material and product development. I'm just showing it as an example for R&D activities here. But all of them needs thorough understanding of the microstructure and also its behavior during operations. Fatigue is one property which we should be in a position to understand what it is, and also high temperature behavior, how the metal can be strengthened towards high temperature requirements. And also wear resistance is one aspect, and also thermal expansion studies can also be a requirement for any of the engineering applications. So all of their efforts have led to some technological transfers for defense as well as for the aerospace. For want of time, I will not cover all of them. And now we are on the lookout for collaborating with any of the requirements for naval vessels as well as for the commercial vessels. And we would be very keen to work for development of aluminum alloys, particularly with respect to corrosion resistance. And I think we have expertise in this institute. We would like to have a collaboration such a way that process development from our side and characterization in terms of corrosion can be possible from CUSAT. Yeah, in summary, we can think of what for various developments for shipping the industries. I am looking forward to extend our support as well as help to the people who are interested. Thank you very much. If there are any questions, I can take one. Yes.
Thank you, sir. There is a lot of knowledge, so much of analysis. I'm a naval architect and I'm a scientist of Central Institute of Physics Technology. I used to keep designing boats and construct boats using many materials, steel, aluminum also I tried twice. So one issue what I found is I was trying to use, actually I used the 5000 series, 508586 I forgot, but it's not so easily available in the market.
Yeah.
Second thing is that not only plate, the sections also.
Yeah.
The
For
stiffness.
that only I quote the requirement of the new material, R&D has to be done. For example, only the Hindalco has a facility which is bigger for any new development. We are putting a new facility in our institute for lab scale to pilot scale. The development is in very advanced stage. Maybe we will be collaborating with some industries to come out with a product which will be suitable to you.
We need only 3mm, 4mm like that.
Yeah.
And the problem is Hindalco, so many people are manufacturing. Where is they are selling? They are exporting or where? That's what I am wondering.
We are collaborating with a few small industries. We'll be in a position to supply to.
The cost is also so high. The fishermen cannot afford. But the quality is
definitely taking this type of requirements. We are working on product developments. We can work together to make your.
I will be in touch with you. Thank you.
Thank you.
Any other questions?
I think for want of time, we will skip it and go for the next level. And thank you very much.
Thank you, sir, for the insightful talk. Now we move on to the technical presentations. We have 5 fantastic speakers lined up to share their expertise with us today. Each speaker will have 12 minutes for their presentation, followed by a 3 minutes Q&A session. A reminder bell will be ringed at 10 minutes and final bell will ring at 12 minutes, at which the speakers should stop the presentation. Audience may save your questions until the end of each presentation. Our first speaker today is Mr. Himanshu Uppal from Indian Register of Shipping. The title of his paper is A Review on Managing Biofouling on Ships for Enhanced Hydrodynamic Performance. Now I welcome Mr. Himanshu onto the dais.
I need to. Good afternoon, one and all. Can you make it easy? Full screen? Right. Good afternoon, one and all. The title of my paper is Marine Biofouling, Its Impacts, Assessment and Remedial Strategies. The paper is written by all of us. I'm presenting, I'm Himanshu Uppal. This is the flow of my presentation here. I'll be covering in brief about all the things which are required to cover the overall aspect. And in-house at IRS, we have developed a tool in order to estimate the biofouling and its impact on engine power or the total resistance of the ship. To introduce the topic, hull biofouling is a common challenge and it creates a lot of problems, mainly to the operational costs. Biofilm, it starts with, and it grows from like an hour, and in days it can expand to a larger scale of length. As you can see in this slide, the fouling hull starts with the formation of a biofilm, and it rapidly increases with time as the ship spend more time at sea in the idling condition. Typically, it can also be understood from the aspect of IMO's regulation and its MEPC's discussion in their brief guidelines, where they are talking about biofouling and how to control its effects during various aspects of running the ship, and how the flag states can actually contribute towards its control from being an invasive species to actually gain benefit out of when we are controlling it. So these guidelines are developed to address the biofouling and its impacts on the ship's power consumption. Apart from that, the pollution, as we now talk about the Paris Agreement, which has been signed by India, and the global scenario has changed from talking only on the performance to the climate change aspects. So a much more efficient ways are required and desired for the ecosystem to look forward towards battling around biofouling. The common impacts of biofouling is towards the power losses, the economic impacts towards longer dry dock intervals and its intended costs. And the recent ones, we can address them as the GHG emissions, which can be controlled. If we control biofouling, we can control it by 4 to 10%, as published in various literatures and reports at IMO. It is also considered that underwater radiated noise can be controlled by 5 decibels if we actively clean the hull. And a prominent aspect of energy efficiency by 5% can also be addressed if we control biofouling. And these are the major impacts which can be understood on an overall level. The factors affecting biofouling are typically categorized under two aspects. One is the environmental factor. The other ones are the physical factors. These are the factors which are typically responsible from the environment side, which is nutrient concentration, light intensity, salinity, acidity or pH, seawater surface temperature. And the physical factors are which type of paint we are using on the hull, exposure time spent on the sea, at the sea, the surface charge, which is the potential difference, the micro texture of the surface, and so on. Out of all these factors, 3 factors can be primarily important, held responsible for the biofouling growth, which I'm discussing. We see that biofouling growth is currently more impactful when there is an exposure time or an idle time associated. The anti-fouling coating parameters comes out of the coating types and its performance at sea within various environmental conditions. Another aspect is sea surface temperature, which is the change in sea surface temperature, which we can affect it abruptly. Why this sea surface temperature is important? Because ship can not be in a particular temperature regime. It can be in equatorial region, it can be in Mediterranean region, and the fouling aspects changes in every other region likewise. Coating efficiency parameter could be one of the important parameter from the paints aspect, which is also dependent on sea surface temperature, and that is where the interaction between the two could lead to increased biofouling. A typical assessment of increased in ship resistance can be seen from certain equations which are displayed on this slide. My focus is to I think there's an animation coming. Yeah, my focus is to give a highlight on the increased skin friction coefficient, which is a time-dependent factor in increasing the total overall skin friction coefficient for a ship. These equations are typically calculated by various means, but typically International Towing Tank Conference, they have suggested a certain methodology in order to calculate the coefficients associated with ship resistance. And therefore, an overall increase in the skin friction coefficient could lead to the increase in resistance and power for the ship, and the associated power, increase in power. Now, when I was talking about the skin friction coefficient, Townsend's formula is used and as suggested by ITTC. This formulation is used for calculating the increase in skin friction coefficient. The main parameter here is this Ks parameter, which is the average roughness height. This average roughness height for a new constructed vessel is considered to be undertaken as 150 mu-meter for a smooth hull, and this was also being studied by a lot of other researchers, where they have given a scale of associated biofouling and its related skin friction, average skin friction height. The average hull roughness height parameter, the Ks parameter, in this particular chart. For various types of biofouling, this chart can be referred out of a lot of work which has been done in the background. Typically, for a newly constructed ship, this light slime condition is considered, which might not be appropriate for all the conditions and all the environments for a ship. This is considered to be a little conservative value when a ship goes to sailing, and therefore a need became there was a need in the ship building area to understand how this Ks value could be a time dependent value, which might also help a lot of shipbuilders, the people from the crew side, to take a decision whether what is the right time they should go for hull cleaning, whether it should be done at the dry docks or in water cleaning. A decision was important. So out of a lot of literature which I have recently reviewed, this study was holding an importance around something where the author have presented the work experimentally and tried to physically model biofouling for a flat plate. And the experiment was done using 3D printing of barnacles, which was of different scales. And he had a finding like this, which is shown on this particular photograph, which you see on the left. The size of biofouling is shown here on the left is small, medium, and big. And its spread across the table was being modeled, and the plates on which the barnacles were modeled, it was stored in a towing tank, and the results of increase in resistance was being experimentally identified. And this is the average change in CF value, which was being obtained out of experiments. This became a very important benchmark problem, as this problem was also being supported by European Union to understand the effect of biofouling in the realistic terms. So this experiment became an initial benchmark for the study in this realm. Next comes how the biofouling is spatially varied. So biofouling does not happen uniformly on a ship hull. It happens. Sorry, I think I have to increase my speed here. I'll just go ahead onto the tool which we have developed. Concluding this, there is a spatial distribution which is responsible for biofouling and its spread onto the hull, which also tells us that the associated skin friction could be varying at different levels when biofouling happens in certain areas or the roughness is increased in certain areas differently. What is the individual increase in resistance when we talk about bow, aft, or maybe parallel mid-body when they are considered to be rough? How much is the individual increase in total resistance? This could help in understanding and connect all these lines together to develop something as a solution to the industry, which is a work which I have tried to maneuver ahead. So what I did initially, I developed, I took this inputs from the literature where a time-dependent equation was being established and suggested by certain authors, which could be integrated with the KS in one of the very unique problem statement where I used Holtrop-Menon method. I used Holtrop-Menon method in order to predict the hull resistance for a ship, and in which the delta CFS was being modeled as a time-dependent coefficient. What happens with the time-dependent coefficient? I've used these expressions which are suggested by the recent studies in the literature, and also integrated with the spatial distributed in a spatial distributed manner. I'll come to the tool here. In this tool, these are the inputs which are shown in pink. It typically talks about the principal parameters and the related coefficients for the hull. And we try to identify what is the hull resistance for a smooth case, where KS is initially identified as 150 mu meters. And when we talk about those equations, which we saw earlier, these parameters are being quantified, as well as actually these parameters have been experimentally identified from a literature, and they have done this experiment in equatorial region as well as in Mediterranean region. To identify these parameters, they have done a sea trial analysis for a span of 3 years. But they have concluded that in their paper that they have collected data continuously for an year to determine these factors. These factors were used as an input. From our database, we have derived there are certain factors which are responsible for the spatial distribution, where we have correlated the overall length and the wetted surface area in a particular ratio. In order to demonstrate it for different types of conventional ships, we have developed this particular database and derived these ratios out of it. Our results, I'll come to the results directly. Out of 100 out of idle days for a ship, we predicted that for a 60 days idle ship, we may have 4 to 9% of increase in hull resistance for a variety of speeds, starting from 9 knots to 17 knots. And when we increase the number of idle days, the resistance increases in such fashion as represented in the table. So biofouling might be considered as not as a threat to the initial designer in the minds of the designers, but it is actually a lot of cost for the operators and the people who are maintaining the hull. And therefore, I can say in one go that it can also be looked in a precise manner, and we can actually predict how much is the increase in resistance on the basis of idle time, which is being spent at sea. And these numbers could be for a conventional ship as well as for naval vessels as well. So the literature which was being undertaken for developing this tool has considered all the aspects of idle days spent at sea.
Please wind up.
Yes. So any questions can be asked. These are the future works we are planning to proceed with. We are going to integrate computational fluid dynamics for modeling the hull surface and making it more accurate for a realistic validation.
Any questions?
These are the references. If you have any. Actually, the locations are across. So for Mediterranean and equatorial region, both has been considered for the present study. So we'll be developing this tool and we'll be publishing maybe on the website as well.
And for normal operations, what is the standards in the industry?
The industry standards follows ISO. ISO 19000 2015, they speak about 150 mu meters, but that is for a freshly built hull. What I have proposed here is a time-dependent consideration, where maybe in 60 days of idle time, how much is the increase in resistance can be predicted. If taken a right decision, actually you can save a lot of fuel and money.
Thank you, Himanshu. If there is no further questions, let's move on to our next speaker, Mr. Mebin A. Abraham from NPOL DRDO, Cochin. His paper is entitled as Life Estimation Studies of FlexiLink for Towed Interconnects. Welcome to the dais, Mr. Mebin.
Good afternoon, all. I first of all like to thank the coordinators of iCANOE for giving this opportunity. I am Mebin. I am a JRF in NPOL DRDO. My topic is life estimation studies of FlexiLink for towed interconnects. My co-authors are Sri Anshad Hussain and Sri Lijo Vijayan and Sri Ganesh Patel. Fatigue. As you all know, fatigue is a type of failure that occurs when there is a cyclic load. And the danger of fatigue is that the failure may occur very low yield strength. Failure of material may occur in less than the yield strength, and we don't have a clue when the fatigue is going to happen. That is the main problem of fatigue, and other factors other than cyclic load, temperature, size of the component, the quality of the component, etc., are affecting the fatigue life of a material. And my topic is a life estimation case study of FlexiLink. The FlexiLink is operating in a dynamic environment. The FlexiLink is actually associated with the towed array system. You can see in the figure, there is this is the FlexiLink. You can see that there is typically in a towed array system there is heavy tow cable, light tow cable, and there is a array there, and this is the towed body. The FlexiLink is used to attach the light tow cable along with array to the towed array, so that the connection between HTC and LTC is not loaded. The FlexiLink is the function of FlexiLink is that to reduce the or to avoid the loading of HTC LTC connector. And this is the typical FlexiLink photograph of FlexiLink is shown here. And usually FlexiLink is made up of titanium, and there are usually 3 to 5 links. As I said, the FlexiLink is the array is operating C. The C is usually dynamic in nature, and along with that, drag forces, flow-induced vibration, and load due to speed variation, etc., are coming. So the load acting on the FlexiLink is generally dynamic in nature, and we want a system that will have a life of 10,000 hours. Our desired operation hour is 10,000, and this is the load data we obtained when towing on a sea trial at 20 knot speed, and the mean load acting on the system is 18 kilonewton. And before going to the fatigue analysis, we first done a static and modal analysis. In the static analysis, the material of the FlexiLink taken as titanium, and we can see the loading conditions here. One end is fixed and other end is given
a bearing load of 28 kilonewton. We use a 20 nodal element for FE modeling, and one modal analysis is also done because we want to know whether a amplitude dynamic amplification is happening or not, and the first natural frequency found out to be 1530 hertz, which is far away from our loading frequency. So there is no, we can say that there is no dynamic amplification happening. And for fatigue analysis, we take an SN curve from a journal, and this is the result of fatigue analysis. We can see the red contours here. We are expecting our breakage of flex ceiling over this region, and we taken a sinusoidal loading cycle with 28 kilonewton to 8 kilonewton, and considering the surface factors, reliability factors, loading factors, we come to a fatigue strength modification factor of 0.39. And on analysis, it shows that the flex ceiling only withstand up to 5.2 million cycles. That corresponded to 153 hours of actual operating condition on the sea. And then further we go to the experiment. This is a experiment setup. Here, the flex ceiling along with HTC, LTC is shown here. One end of the LTC is fixed on the test setup, and other end of the flex ceiling is fixed to the hydraulic actuator through which the dynamic loads are applied to the system. And in the experiment, it is found out that the flex ceiling withstand only 1.9 million cycles, which corresponding to only 56 hours of actual operation. And these are the photograph of the failed flex ceiling. We can see the we can see at the exact location of the FE analysis, we can see the failure is happen. And on the right side, you can see the statistical spread of number of cycles to failure, because our FE analysis and experiment test ratio is found to be 2.7 of the value of 2.7, but in the when plotting the SN curves in several experiments, we can find that the statistical spread of data is about 7 to 10 times. So our analytical the analysis value is acceptable. And one more thing, we taken the SN curve for our analysis is from one journal paper. It is not actually taken from the actual samples for manufacturing the flex ceiling. So our desired value is 10,000 hours, and we are not met up with that 10,000 hours of life. So we redesigned our flex ceiling. We redesigned the flange size, the fillet size, the curvature, everything we modified. This is the table that shows the modification. This is the folder. This is the redesigned dimensions. And after modification, we done a FE analysis, and it is found that there is a reduction of 35% of stress value for the new model, and the model is able to withstand more than 10,000 hours. That is our desired life. Now the new model is also on the test on the new model is also under progress. So after testing, we can validate our new analysis also. And these are the conclusions that the FE analysis and experimental data are found to be in good relation, and the ratio between the predicted life of FE analysis and durability test is 2.7. As the flex sealing is not met with our requirement, the redesign of flex sealing is made, and redesign of flex sealing shows that it is meeting with our 10,000 hours of life requirement. So this is the case study, and this is the answer.
Thank you.
Thank you, Mr. Mibin. Over to the session chair for Q&A session.
Any questions for this presentation? Okay. In terms of material,
Mabin, you said that you had failure will occur after 6.1 billion cycles. How many hours is that? Because your specification is in terms of hours, but your analysis result is in terms of cycles.
It is more than 10,000. It is like it is a very big value. It is around 84,000 or something is coming. But we can consider the material is meeting the flex sealing is dealing with seawater. There is one study is there.
It's okay.
Fatigue.
Now, whenever you do FEM, you have to do a convergence study. And I think your results will not converge at that place. Did you do any convergence study?
Convergence study is one or two model only we made. No further studies are.
I think it's okay. I have one question. This 11,000 times when you mentioned, is it theoretically a good estimation in the conclusions?
1,000.
Last one, FE analysis predicts an enhancement in service life of more than 11,000 times.
1100 times. It is the stress value is reduced up to 35% for the new model. So the new life estimation is 6.1 billion cycles, and the
but with respect to material, it remains the same. Material selection and all other defect level is same.
Yes, because of the stress level reduced to 35%, we can say that, because if increase in 1% or 10% of stress will also affect reduction of fatigue by very large value. Here 35% of stress is reduced, so this value is acceptable.
Okay, let us give him a big hand. Thank you.
Thank you, Mr. Mibin. We will now proceed to our next speaker, Mr. Balaji RS from NPOL DRDO Cochin. The title of his paper is Thermal Analysis of an Underwater Electronic Enclosure. Mr. Balaji, we welcome to the dais.
Good afternoon to one and all present here. Myself, RS Balaji, working as a JRF in DRDO NPOL. I am very much glad to present the topic in this conference. My topic is about thermal analysis of an underwater electronic enclosure. And my authors are myself with Sri Anand Maman Thomas and Sri Samuel Theophilus. So here we can see the exploded view of the underwater electronic enclosure, and this enclosure is a pressure tight wet and cylindrical enclosure. And this enclosure should be operated at the submerged conditions under the hydrostatic pressure of 60 bar. And this electronic enclosure should also be operated at the onshore testing as well. So here in this enclosure, there are PCB stacks which are used to processing the acoustic signals from the sensor arrays. And these PCBs are operated continuously. During the processing of the signals, the heat is getting generated in the printed circuit boards. And this printed circuit boards, as it is heated, the temperature of that PCBs should be working under the allowable limit. See, and here we can see the PCB stacks. Here we can see the PCB stack. It contains the 3 PCB boards: pre-amplifier boards, controller boards, and connector boards. And these PCB stack is placed inside this inside the enclosure. And during the continuous operation, as it is working, if the temperature goes beyond the exceeding value, there will be a fault in processing the signals. So to overcome that, the thermal management is essential for the enclosure to carry out the enclosure to work on continuously. And here is the baseline model. We are starting with this baseline model. And after that, we are using the annular heatsink, which is placed inside the enclosure. Here we can see the annular heatsink. It is made up of a copper material. And after that, with the addition of the annular heatsink, fins also used outside the enclosure to test how much thermal performance is achieved. So these are the objectives, and it is followed by one slide. And first 3-dimensional steady state analysis is carried out in a thermal analysis software Siemens Flotham XT, which uses a finite volume method. And first it was done with the baseline model, and after that it is compared with the performance of the annular heatsink as well as fins configuration. And parametric fin study is carried out to assess the optimized fin configuration by varying the fin spacing as well as varying the fin height. So these are the literature reviews carried out. So authors were reviewed on the vertical cylinders as well as horizontal cylinders in an enclosure with the fins outside the enclosure. And also they are carried out with the Yes, sir. Yes. So this is our first part. This is our natural convection domain for the baseline model without any annular heatsink and the fins. So here the boundary condition we are using is it is testing at the ambient condition of 32 degrees Celsius. As I said, the enclosure is operated on the submerged condition, but it is also should be operated at the onshore testing. So onshore air ambient condition is a critical part. If it passes in that condition, it will be operated at better in the submerged condition. So we used the air ambient condition of 32 degrees Celsius. And this is the meshing has been done across. This is the cut view for the meshing. And this Flotham, rectangular grids are generated in the components, solids and the fluid regions of the enclosures. And we can given the mesh settings for the enclosure. We have divided the number of cells along the enclosure in X and Y and Z direction, as well as the grids are refined near the PCB regions as well as the fins region to capture accurately. And we are getting the total number of cells as 92 lakhs as a mesh counts. So next, as the material properties, we have used a super duplex stainless steel for the electronic enclosure, and the PCB cards are given are monitored by giving the layer definitions. The the PCB compact modeling option is used to capture the preamp boards, connector boards, and controller boards. Based on the number of conducting layers, the in-plane effective thermal conductivity is calculated and it is given as an input that we can see in this table for the each controller board, preamp board, and connector board. And here we can see the material properties for the other components, enclosure components, and the heatsink that PCB boards are placed are in the respective heatsink plates. That heatsink plate is made up of the aluminum material. And the annular heatsink we used as a copper material. And that annular heatsink is wrapped by the thermal pad, that is to ensure that it should make a contact with the PCB stacks as well as with the enclosure. And PCBs, printed circuit boards, are modeled as a volumetric heat generation that we have given a thermal load for each boards, preamplifier boards, controller, connector, and DC-DC converter is the power source that is attached to the top dome of the enclosure. And the thermal load is summing up to total 50 watts. So first, the thermal simulation is carried for the baseline model. We can see the temperature distribution in the enclosure, that is outside the enclosure only, and as the temperature distribution across the cut plane section of the PCB boards. And after using the initially the PCBs are cooled by the conduction path. In the baseline model, the printed circuit boards, the heat transfer from the printed circuit boards happens through the bottom surface of the enclosure. And in the next part, with the addition of the annular heatsink, the temperatures are dropped. We can see the maximum temperature distribution in the first case is 85 near, and after with the addition of annular heatsink, maximum temperature is 64 degrees Celsius. We can see some 20 degrees Celsius drop with the addition of annular heatsink. So by the addition of annular heatsink, the conduction is increased. The lateral conduction happens from the PCB stack to the outside enclosure. That is that by decreasing the internal thermal conduction resistance. So here we can see the temperature, average temperature as well as maximum temperature for the respective boards. So maximum 20 degrees Celsius drop is seen in preamp board, and 10 degrees Celsius drop in the controller board. And next we carried out for the parametric study for fins has been done outside. So our aim was to obtain the optimized fin configuration by varying the fin spacing around the enclosure. By the placing of the fins, there is a limitation in placing of the fins, because around the outside the enclosure there are connectors should be placed. Through the connectors, input power source is applied, given, and as well as output digital signals are processed. So excluding the connectors arrangements, fins are placed. So these the table 7 indicates the variation of the fin spacing. We have done with the 4 fin spacing with the constant fin height, and the heat transfer from the finned part as well as in the unfinned part are taken from the numerical results. And after that, heat transfer coefficient is calculated from the heat transfer value. So we can in the graph we can see the heat transfer coefficient is getting maximum at the fin spacing of 0.115. But by taking the heat transfer is maximum at the fin spacing at 0.05. So we are getting 2 optimum conditions. This 2 optimum condition is due to the difference in the finned area. For example, in a heat transfer coefficient, by decreasing the fin spacing below the optimum value, the heat transfer coefficient decreases, because by decreasing the fin spacing, the number of fins starts to increase. So it restricts the natural convection flow over the enclosure. But in heat transfer path, after increasing beyond, the same phenomena is obtained over here. And this is the temperature distribution for the various fin spacing. We can see that in all the fin spacing, there is somewhat little bit variation in the PCB temperature. That we can see because maximum temperature drop has been already occurred by the with the usage of the annular heatsink. by placing the fins, there is a little bit variation, and this temperature is given 2.41 degrees Celsius drop has been seen in the preamplifier PCB board for the optimized fin configuration with the addition of the fins. And with the fin height, the variation in PCB temperatures are limited only, and there is no that much variation in varying the fin height. And the experimental validation is carried out to compare the experimental results with the numerical results of the optimized fin configuration. So, and this experimental setup is used for this actual prototype is the optimized fin configuration of fin spacing 0.115, and data acquisition unit is used to monitor the temperature, and the board preamp and connector and controller boards temperatures are monitored through the display units. And we can see that the temperature are almost matching with the numerical results, with an error of 4.2% in preamplifier PCB and controller PCB is 1.4%. And this is the conclusion. First, the optimized fin configuration is obtained through the numerical results, and it is compared with the experimental results. And after that, with the addition of the annular heatsink, the preamplifier PCB temperatures are reduced by 22% and 23.4%. And the implementation of the fins enhances the heat transfer, as well as the optimum fin configuration we selected is of fin spacing of 0.115 rather than the optimum fin spacing of 0.05. By considering the manufacturing feasibility, by lesser fin spacing, what it happens means it increases the weight of the material, and also the increases the manufacturing cost. So we selected the optimum fin spacing of 0.115. Thank you.
Thank you, Mr. Balaji. Over to session chair.
Is there any question from the audience? One.
We have done the thermal analysis of water electronics. Mr. Balaji,
yes, sir.
You have done quite interesting work. So I have few queries. So what numerical models you have used to evaluate these stresses? And another thing, so what about the computation expense? So how much computation resources you have used, and have you done any grid convergence study?
Yes, actually, Flowthumb XT uses a finite volume method, Siemens software, and for solving the discretized equation, simple algorithm is used. And the grid independence is done actually, done the maximum mesh count is 92 lakhs. In that mesh count, temperature values are not changing.
Any other question? What is the device you have used to measure the temperature inside, rise in temperature? Is it a thermocouple or is it sensors?
Sir, sensors.
What type of sensors?
Sir, thermistors are placed inside the board, sir. It has been monitored through the display unit.
Okay. What is the sensitivity of it?
Sensitivity.
Sensitivity? No idea.
That I
okay. No. Thank you. Let us give him a big hand.
Thank you, Mr. Balaji. We will now proceed to the next presentation by Mr. Vaishak KB from the Department of Ship Technology, CUSAT. His paper is entitled as Comparison Studies on the Corrosion Characteristics of 32760 Super Duplex Stainless Steel, Grade A Mild Steel, 304 Stainless Steel, and 5083 Aluminum Alloy in Marine Environment. I welcome Mr. Vaishak to the stage.
Good afternoon. Myself, Vaishak KB. I am doing my PhD in our department. So, my topic is comparison studies on the corrosion characteristics of 32760 Super Duplex Stainless Steel, Grade A Mild Steel, 304 Stainless Steel, and 5083 Aluminum Alloy in a marine environment. My co-authors are Professor A. Madhiyagan sir and Mr. Krishna Prasad. Yes. So coming to the introduction. So the marine industry relies heavily on the durability and the reliability of the structures. So let's move on to some statistics. The global cost of construction is $2.5 trillion per year, which equates to about 3.4% of global GDP. And when coming to India, it's about 4%. So again, as per the NACE international report, the total cost of corrosion in the marine sector across the world comes to around 50 to 80 billion dollars annually. So what can be done to deal with it? So there are various methods such as marine coating, cathodic protection, design to prevent corrosion, and selection of suitable material in the design stage itself. So our focus is on the last strategy, that is the selection of suitable material. And for that, hence the focus of our study is on the suitability of 32760 super duplex stainless steel for application in the marine industries. So in this paper, we had investigated the corrosion properties of super duplex stainless steel using. Okay. We had investigated the corrosion properties of super duplex stainless steel using potential dynamic polarization corrosion test. So again, we have analyzed the corrosion properties of similar grades like mild steel, grade A mild steel, 304 stainless steel, then 5083 series aluminum alloy, and the results of that corrosion are compared with that of super duplex stainless steel. We had also analyzed the microstructure, composition, and the mechanical properties like toughness and hardness of super duplex stainless steel. So our material that we used in our study is supplied by Outokumpu, Sweden. Their headquarters in Finland. It's a solution annealed and straightened, peel turned, and polished materials conforming to the STM standards. This is supplied to us by Industrial Connectors Cochin. So what is the relevance of the super duplex stainless steel in this current era? So basically, I am showing some examples that had taken place in European countries. So very recent developments we have shown here. Earlier, the super duplex was used for minor components in the marine industry, but nowadays, the entire hull is being constructed using the super duplex stainless steel in developed European countries. You can see in Usaki shipyard in 2014, in Japan, it was the first time the Class NK guidelines were used for construction of bulkheads using super duplex stainless steel. So again, in USA, some floating hulls that were used for solar and wave power generation. The work is now going on. Hundreds of 85-meter floating structures are being proposed. And they're claiming that they can stand in marine environment for more than 50 years without any maintenance. So this is, we come to our methodology portion. First, we have analyzed the composition and the microstructure of the super duplex stainless steel that we have purchased. Then we had done the corrosion studies for the super duplex steel and also the other similar grades of steel like mild steel, stainless steel, and also 5083 aluminum alloy. And coming to the mechanical testing, we had done the some hardness test and also to check the fracture absorption impact absorption capability. So we had done the sharp impact test and the specifications are mentioned here. So coming to the results and analysis portion, first we will deal with the composition and the microstructure. So this is actually what is composed of the super duplex stainless steel. It composed of approximately 27% of chromium, about 7% of nickel is there, then manganese is there, then nickel is there, molybdenum is there. The carbon content is very less compared to other types of steel. It comes around only 0.016. So this is just the EDS spectrum of that elemental composition. The figure is there in that slide. That's blank. What PDF is there actually? That is same as the result. Back. Okay. I will. So this is a microstructure that we have obtained. We had done optical microscopy. So we can see here at 5x zoom, this is the microstructure at 10x, 20x, and 50x. So what we can see here is that it's a super duplex stainless steel. That is, it consists of both the ferrite faces and austenite faces in approximately equal proportions. So in this two views, the 20x and 50x view, we can directly see that the lighter areas are the austenite face, represents the austenite face, and the darker areas are the ferrite face. So coming on to the mechanical properties of the super duplex stainless steel, that is, we have mainly done this hardness and impact test. And for that hardness test, we have checked Rockwell hardness and Brinell hardness. Rockwell using 60 kilogram load and also with 150 kilogram load, that is A scale and C scale. And the Brinell hardness that we have done with 3000 kilogram load. So again, the values obtained are excellent considering the property of any structural material, and they are in accordance with the standard super duplex stainless steel specifications. So these are the numerical values that we have obtained for this super duplex stainless steel. They are very good values considering the reference papers. Again, this is the result of the impact test. So as I told, the super duplex stainless steel has the potential to be used in severe seawater conditions. So it needs to have the capability of withstanding impact energy due to dead loads such as cargo loads. Owing to this, it is important to analyze whether the super duplex stainless steel is good in impact toughness. A critical criteria to be checked. The value obtained is 298 joules. That is actually almost reaching the maximum capacity of the HRP impact testing machine. That means that much higher impact energy is shown by the super duplex stainless steel based on our results. So this is just a macrograph of the failed impact test specimens. We can see here, normally when we break a mild steel specimen, it will break into two pieces. But what happens here is that we can see here only a small deformation there takes place. So we can see in this figure particularly, this is the notched area, this particular area. And after the fracture area is really small. So that much energy it had absorbed. Also, we can see the large plastic deformation that had taken place over this particular zone. So that large plastic deformation is nothing but an indication of the high fracture toughness property of a super duplex stainless steel material. So this is exactly the thing that I told now. Coming to the last portion, that is the potentiodynamic polarization corrosion testing. So we have done this particular test using two methods. One is the electrochemical impedance spectroscopy technique. The next one is the analysis of corrosion rate using Tefel plot. So this is the electrochemical impedance spectroscopy results. So through this technique, we had plotted a Bode plot, which is nothing but a relation between log impedance and log frequency. And through this, what we are obtaining is that we are obtaining the corrosion resistance of the particular material that we are testing. So we have tested all the four materials, and these are the Bode plot that we have obtained for that log impedance versus frequency. From that, we got the value of log impedance, and then we obtain the value of impedance as tabulated in this particular table. We can see here, compared to mild steel and stainless steel, the super duplex stainless steel is almost 10 to the power of 4. Here it is only a fully austenitic stainless steel, which is considered to be excellent in corrosion resistance, is observed to have a corrosion resistance of in the power of 10 raised to 3. But when we coming to super duplex stainless steel, the corrosion resistance or the corrosion impedance value comes to the power of 10 raised to 4. Well, for the mild steel, it is only 10 square. But Pfizer A3 aluminum, which is a renowned corrosion resistant material, observed the peak value. So coming to the corrosion rate analysis using the Tefel plot. Tefel plot is the relation between the log current and potential. So these are the results for the Tefel curve analysis. Here also we can see, so this is a curve. Through this curve, we are obtaining the current values, and from that current values through the equation, we can obtain the corrosion rate. So these are the corrosion rate values. We can see here for a normal mild steel, it comes around 3.7. For austenitic stainless steel, the rate is 0.22. Where for the super duplex stainless steel, it is 0.11 only. So we can say that as the corrosion rate is lower, the more resistance the material is towards corrosion. So we can clearly demarcate that the super duplex stainless is a better material when regards to corrosion rate or corrosion resistance aspect. Here also aluminum exhibits the least value. So what is the scope of this particular study? So MS and mild steel and stainless steel are usually preferred for principal structural components in the shipbuilding industry. We can know that aluminum has a good strength to weight ratio, but when the strength is a major factor, steel is usually preferred. But the development of duplex and super duplex steels is a further advancement of the structural engineering sector, especially in areas of excessive corrosion. So this steel is expected to have better corrosion resistance than even fully austing stainless steels, as we have clearly demarcated in our studies. And sophisticated corrosion analysis techniques, as done in the present work, are relevant for the application of super duplex stainless steel in the marine industry. And as I told you, significant developments are being achieved in the developed European countries for application of super duplex stainless steel, even for the construction of an entire vessel or a prototype boats or let's say bulkheads and all. So our focus is that significant that owing to this, we are just the investigations as done in the current study using such sophisticated techniques can increase the confidence of the people or the community in the marine sector to adopt super duplex stainless steel as a reliable material for application in this particular field. So that's all about my presentation. These are references. Thank you.
Thank you, Mr. Vaishak. Over to session chair.
Yeah, any questions, please?
What temperature was impact testing carried out?
It's carried out at room temperature only. Yeah.
Because these duplex stainless steels are normally more utilized for low temperature applications.
Yes, sir.
So maybe comparing mild steel with these duplex steels may not be an ideal. Rather, to compare a low temperature steel with them would be more appropriate, I think so.
Yes, sir. We are also planning to do at low temperature.
Using a potentiodynamic
Polarization
test,
yeah.
Polarization test. I presume because the real way of testing has to wait for the corrosion to occur, that's not reasonable or feasible. So I assume that's why you adopted this procedure. How reliable is this test procedure that you did to simulate the corrosion resistance?
Yeah, the reliability of this particular setup is already established, and when we are comparing the results that we have obtained with those of standard testing methodology, they are also coinciding. So it's a generally accepted method, it's an accelerated technique. So we didn't get the exact value as that of the normal testing when we are waiting for such particular periods, but in fact, this value is proven to be reliable in many papers.
Okay, I have one more question.
Yeah.
Have you done a cost assessment of how much more expensive is duplex stainless steel over mild steel or conventional stainless steels used in shipbuilding? Because you stated that you foresee complete vessels being designed using super duplex.
Yeah.
But would the cost differential actually make that decision feasible?
Yeah, that's why I told you it is being mainly carried out in developed countries now. And when we inquired the industries, they're saying that is about 3 times the cost of that of normal mild steel. But one thing they're saying is that I think one of the earlier presentations also talked about that biofouling components and about the maintenance costs that are occurring for that. So as per the studies that are carrying out in these developed countries, they're claiming that they do not require any maintenance for such long period. So in fact, and that aspect, there's a cost reduction is there. And again, one more claim is that since this material has strength almost double as that of the normal mild steel or stainless steel, the thickness of the structural components can be reduced to some extent. So one is that thickness aspect, or the weight can be reduced, the total weight can be reduced. Second one is the maintenance can be reduced. So other aspects are through this biofouling and all, if this material actually can be better polished to mirror finish. So when they remain in water, it will assist in the efficiency of the vessel. It can remain in maintenance without water without much maintenance for a long period. And the aspect is the thickness aspect. These are the 2 things that they are claiming. So this research is only going on now. So more papers are required to know the exact cost aspect and all. We are also planning to do some analysis like that in our research work. Thank you.
Thank you.
Thank you, Mr. Vaishak. Now we can move to our last presentation of this session by Mr. Krishna Prasad S. He is from Cochin Shipyard. His paper is titled as Potentiodynamic Polarization Studies of a TIG-welded AL5083 and Experimental Investigation. Mr. Krishna Prasad, please come to the stage.
Good afternoon, all. The topic of my paper is potentiodynamic polarization studies of ATIC welded aluminum 5083 and experimental investigation. My paper is co-authored by Professor Dr. A. Madhyadagan, Professor in Department of Ship Technology, CUSAT. Mr. Vaishak KB, research scholar and the previous speaker. Mr. Donny Dominic A.T., who was an MTech student with the Kunyali Marine College in CUSAT. Apparently, I am the last person who is the speaker and who is in between you and the lunch. So I would not spend much time briefing you on the what are TIG welding and all. For the audiences who do not know about TIG welding is a type of welding process which is able to produce high quality welding, high quality weld joints. But the main limitation is with regard to the productivity compared to conventional other welding processes like SAW, SMAW, FCAW, MIG welding. TIG welding is generally having a very low productivity. The productivity can be measured by many means. The most quantifiable method of assessing the productivity is assessing the depth of penetration that can be produced using a single weld bead. Having known the advantages of TIG welding, the industry has in fact explored various means of improving the productivity of TIG welding. So one of the most promising innovation that has happened in TIG welding is a process called, it's actually not a new process, it's a improvement of TIG welding known as activated TIG welding, where we use active fluxes which have surface active elements on this. So the importance of surface active elements are that it will alter the behavior of the molten pool that is produced. I will go straight to the principles behind that. So what happens during the surface active elements, the influence of surface active elements in the molten pool is that it will alter the surface tension properties of the fluid. As we all know, as temperature increases, there is a tendency for any material to reduce the surface tension, and the natural tendency of any material would be to spread out. So, however, due to the effect of surface active elements, the surface tension, it is seen that the surface tension increases and the flow is reversed. That means the flow of the hot or the molten fluid will be inwards. So this inward flow of molten pool will contribute to an increase in the depth of penetration and decrease in the weld width. That means the aspect ratio of the weld produced would be increased. And this is actually a explanation of, and this process is known as a reverse Marangoni convention. And the other process, what happens during activated TIG welding is arc construction. Arc construction mainly happens due to the pool of electronegative fluxes which is formed will attract the positive ions of the arc which is produced, and then which causes a constriction of the arc. So this arc constriction and reverse Marangoni convention will play a vital role in increasing the depth of penetration of the weld produced. So here in the experimental investigation, what we have done is we have carried out activated TIG welding using 3 fluxes. 3 fluxes which we have selected for the experiments are SiO2, TiO2, and Fe2O3. The selection of the fluxes are mainly made considering in mind the commercial availability of the fluxes, the behavior of the fluxes with the molten poles, and we also refer to a diagram called Ellingen diagrams. Ellingen diagram will actually make our selection of the fluxes more easier. That means Ellingen diagram has a set of will give us how the fluxes behaves with certain materials, and how better the surface tension properties behaves. So if you take these 3 fluxes, almost all the fluxes have deoxidizing capabilities and better wetting properties. So it was analyzed that the selection of these fluxes would play some role in the activated TIG welding. And what we have done is a set of experiments were performed before the potential dynamic polarization test, which I am presenting now. We have carried out mechanical testing, microstructure studies, and then we proceeded with the corrosion studies. So these are some pictures of the microstructure studies we had performed, and the corrosion studies we have done. So the corrosion study, what we have done is potential dynamic polarization test and electropy. So to the previous speaker, one of the esteemed audience was asking, what exactly do you mean by this potential dynamic polarization test? So technically speaking, it is an accelerated corrosion study. So we could have either weighted the specimen and kept it in a seawater sample and waited for a couple of months, couple of weeks, maybe a couple of years. But this potential dynamic polarization test is technically an accelerated corrosion study. So the results would be more or less similar with the actual studies itself, but we would get the results much more easier than prolonged waiting for months, years, and weeks. So we have done a 3 electrode system potential dynamic polarization study. Some pictures of the experiments we have done here are shown here. So the 3 electrode means we do have a reference electrode, which is a standard calomel electrode, a counter electrode, which is a platinum electrode, and the 3rd electrode is naturally our test specimen. So what we have carried out is we have taken aluminum 5083, performed conventional TIG welding first, and then we have performed activated TIG welding using 3 types of fluxes, and analyze how the corrosion behaviors are. So I was just explaining, this is part of a wider experiments we have done. So the corrosion test was the last test we have done. So these are the microstructures of the aluminum the conventional TIG welded aluminum samples, and these are the tafel plots of the conventional TIG welded samples at 3 currents, namely 140 amperes, 160 amperes, and 180 amperes. So from this tafel plots, we can have an estimate on the corrosion rate of the materials. And then what we have done is we have plotted the body plots, as my previous presenter had told. It's a graph plotting the logarithmic of the impedance with the logarithmic of the frequency of the potential we are changing in the potential dynamic polarization test. And just to the information of my audience here, as I have told, activated TIG welding is a method of improving the productivity of TIG welding. So during our process, what we came to during our experimental studies, we have found out that certain fluxes like SiO2, TiO2, and Fe2O3 were giving superior depth of penetration in single run compared to the conventional TIG welding. And you can see just for an example, like these 3 colors actually shows 3 different current values during which the experiment was performed. you can see how improved the depth of penetrations are. The highest was obtained for SiO2. As a matter of fact, the productivity improvement or the depth of penetration increase was in the range of 3 times, more than 3 times for that particular flux. And on an average, the productivity improvement was around 150%. And the aspect ratio, that is the ratio of depth to width. Ideally, the depth to width ratio should be less, which is this. If you can see this, the ratio of depth to width is actually increasing, which is a quantitative measurement of how better the reverse Marangoni convention has actually played during the experiments. These are some of the microstructures of the ATIC welded samples using 3 fluxes at 3 different current values, and the TOEFL plots were obtained. What we have found out, I will go to the graph rather than the actual measured values. So when you take the corrosion rate comparison with the conventional welded sample, that the blue color is the conventional TIG welded sample, whereas the colored, that means the red, green, and yellow, activated TIG welded specimen corrosion test and the results of the corrosion rates of those specimens. So what we can infer clearly from this graph is the usage of activated flux, activated TIG welding not only improved the productivity, but also had a positive impact on the corrosion resistance. And this was slightly not anticipated that this much improvement in the corrosion rate would happen. But even after repeated test, the average test results were in this figures. And one of the from the corrosion point of view, the best flux which which gave the best result was TaO2 followed by Fe2O3 and SiO2. So that's all from my side here. So the point I would like to make is we generally use TIG welding not from a point of view of high productivity, but to carry out special welding or welding of some special materials. But when we have carried out this experiment with activated TIG welding, we got a better productivity, and the corrosion rates were also tested and was found to be superior to than of a conventional TIG welding. So thank you for your patient hearing.
Thank you, Mr. Krishna Prasad. Over to session chair.
Any questions from the audience? Yeah. Any questions from? Okay. Coming to the welding of aluminum alloy, how commercially it is possible?
So 5083 is my grade of aluminum, which is selected 5083H116. It's a weldable grade of aluminum. We have carried out welding in TIG welding, and the WPSs are already available in our yard. So we use the same parameter. It's a established welding procedure. We just adopted.
But what about the filler material requirement?
Here we have done autogenous TIG welding. In autogenous TIG welding, we are not adding any exterior filler material. And the one thing I forgot to mention was we have carried out bead on plate welding. So technically there is no need for a filler addition for a bead on plate welding. Bead on plate welding was performed to evaluate the performance of how the welding parameters are changed and what changes in the welding parameter influence the actual weld produced. So for that, bead on plate welding is the standard practice. And after ascertaining the performance, then we will proceed with butt welding or something. So that is the preliminary study we have carried out.
Okay. Let us give him a good hand. Thank you. Now with this, the session is coming to a conclusion. I give it to the organizers for their. For sticking to the timings as well as answering to the questions relevantly. It's indeed a good session to understand the research activities the same topic being covered at different institutions. All the speakers were doing very well in terms of presentation. I thank all of them. Thank you very much.
That concludes our session on materials and corrosion. I would like to extend a big thanks to all the speakers for sharing their knowledge and insight with us. Now I cordially invite Dr. M. Ravi, Session Chair, onto the dais to give away the participation certificate to the presenters. First of all, I invite Mr. Himanshu to collect the participation certificate. Thank you, Himanshu. Next, Mr. Mebin A. Abraham, please come forward to collect the certificate. Thank you, Mebin. Now I call upon Mr. Balaji to collect the certificate. Thank you, Mr. Balaji. Now I invite Mr. Vaishak KB to collect the certificate. Next, I invite Mr. Krishna Prasad to collect the certificate. Thank you. Congratulations to each and every one of you. Your dedication and hard work have brought you to this moment, and we are incredibly proud of your achievements. Before we conclude, I would like to acknowledge and express our deep gratitude to our esteemed chair and co-chair who have made this session very delightful. Their support has been invaluable. Now I kindly request Dr. A. Madhyaragan, Professor, Department of Ship Technology, CUSAT, to hand over the memento to Dr. M. Ravi. Thank you, Dr. M. Ravi and Professor Dr. A. Madhyaragan. I would also like to thank all of you for your active participation. We will now take a lunch break before the next session begins. The lunch is arranged in the first floor. Our volunteers will assist you. Thank you. Have a great day. Over to Hasina, Miss.
The Class NK award ceremony will about to start at 2:30 p.m. So I request all of you to gather here in this conference venue on time.
Hello.
Professor Anup C is adjudged the second best project. This project showcases the meticulous design and construction of a luxury yacht tailored for a passenger capacity of 12 individuals, featuring a cruise speeding of 15 knots. Iterative design updates and the creation of a 3D hull model achieved through Rhino and MaxSurf software were central to the process. Performance validation of the hull was conducted through computational fluid dynamics analysis, focusing on resistance and seakeeping. Four distinct hull forms, all adhering to the same dimension, underwent meticulous CFD analysis by the student in STAR, CCM, and ANSYS to determine the one with the lowest resistance. An integration of innovative layout, plush cabins, capacious party halls, open deck spaces, and water sports equipment delivers a seamless fusion of comfort, elegance, and entertainment. Big round of applause for Jishnu PV, please. Class NK Award for the best project for the year 2023 goes to Mr. K.S. Vidar for the design of CNG carrier under Assistant Professor Anup C. The project focuses on the design and optimization of an efficient and reliable CNG carrier capable of transporting substantial quantities of natural gas over long distances. The design briefly arrived at the main dimension after interpolations and regressions were done, and results were visualized using MATLAB. Rhino 3D has been used for hull geometry. The propulsion system was designed using KT-KQ chart, and the design optimized for better efficiency using Python. Simulation tools, namely ANSYS, have been employed to analyze the hydrodynamic performance of the hull and propeller, and also the seakeeping performance of the designed vessel. This design has efficiently utilized the trunk deck area to harness solar power, thereby reducing the dependency on fossil fuels for auxiliary power. Now coming on to the award ceremony. I would like to request Dr. Samitran Sampath, General Manager, Class NK India, to come forward and felicitate the award winners. Sir. Due to his unforeseen engagement with NAVTEC UAE, Mr. Jishnu PV, the winner of the second, I would like to invite Sub-Lieutenant Praveen PS to receive the third Best Project Award. Due to his unforeseen engagement with NAVTEC UAE, Mr. Jishnu PV, the winner of the second Best Project Award, could not be present here. So I would like to invite his parents, Mr. Govind Prakash and Mr. Vimela, to accept the award on his behalf. Sir, please. Official engagements with Albawadi Daman UAE could not allow Mr. K.S. Sridhar, to the winner of the Class NK Best Project Award, to receive the award in person. But his proud parents have graced the occasion with their presence, and I would like to request to invite Mr. and Mrs. Krishnamurthy to accept the award on behalf of Mr. K.S. Sridhar. Thank you, sir, ma'am. Now I request Now I request Dr. Sumitan Sampath, General Manager, Class NK, to address the gathering. Sir.
I think I already addressed the gathering in the morning. Anyway, I don't want to make it a very long one. Anyway, first of all, let me at the outset congratulate the winners, award winners, and the proud parents. This is something which NK likes to have these awards because we want to encourage research activity among students. For NK, research is a very important activity because our rules are developed based on research. So this is one of the initiatives that Class NK has carried out. It's not only in India, but across worldwide. We have many universities where we institute such awards for naval architect projects. And I have to appreciate the kind of projects that the winners have chosen. They are not easy projects. Totally new CNG vessel, and then you have the luxury yacht and the luxury cruise vessel, which are complicated projects. It's not normal. It's very easy to do a simple cargo vessel rather than these complicated ones. And I should really appreciate them for selecting such projects, because as a student, when I used to see which was the easiest one. Normally, that's the trend which we used to do. Though during my college days, I also did not go for a design project. I went for a towing tank project. And I also got the best project, highest in the project section. And I should again also congratulate the professors who have guided the students, because they are the most important, because without them, this project wouldn't have happened. And once again, I congratulate all the winners, and have a very great career also. I'm sure this will give you an incentive to go ahead in your career in a big way. Thank you.
Thank you, sir. Now I would like to invite upon stage Dr. Anil Das, NT, CEO, Conceptual Technologies, to felicitate the chief guest, Dr. Sumitan Sampath, General Manager, Class NK.
Good afternoon, everybody. It's my proud privilege to felicitate Class NK, Mr. Sumitran Sampath. As has been announced, I'm not a doctor, not yet. So, Class NK has been giving away these awards since long. And they have set this very essential criteria or requirement for the students to strive for excellence. That is what I appreciate most in this award. And thanks to Mr. Sampath for speaking about the professors or the guides' contribution. So these two put together brings out the excellence in the student. So that's all from my side. Thank you. Thank you so much.
Thank you, sir. For the award winners today, I'm sure it wouldn't have been a cakewalk, but would have been a story of hard work and constant, sincere effort. So now I would like to invite Sub-Lieutenant Praveen PS to come on the dais and present a thanking note.
Good afternoon to all dignitaries on and off the dais. First of all, I'd like to thank all the efforts given by my course-mates, all my friends, others, juniors who all supported me in completing this project. My guide, Lieutenant Commander Nitin Sharma, sir, had a full-on role on completion of this project. The guidance which sir had provided me throughout the tenure of this project. The officers at Naval Construction Wing, their guidance also helped me in completing this project to be a successful one. Professor Anoop, Professor Arvind, they also played a major role in this design. Initially, I was stuck in the design phase itself. I had no idea how to proceed ahead. Then I had approached Anoop. Anoop told me refer to ship design and construction, chapter 37, passenger vessels. That's what all it had started. And from there, I was always following their advices. Whatever mistakes I had done, I could rectify them only with their advices and guidances. I'll also like to thank Class NK for this recognition, and that's it. Thank you.
Now, to end the proceedings of this award ceremony, I would request Dr. K. Prasad to administer the vote of thanks.
Respected Head of the Department, Dr. Satish Babu, Head of Class NK's India region, Mr. Sumitran Sampath, Lieutenant Praveen, Sub-Lieutenant Praveen, the proud parents of Jishnu and K. Sridhar, my dear colleagues, Anil Das, who was with Navy for many years, an alumnus of this department, passed out in 1985. When I joined, he was here as a last final year student. Officers from Navy, the participants, our alumni members, sponsors of this conference, others, students, scholars. I used to do this type of talks before this year, last year. I used to do this everything for Class NK because there is one of the alumni members of this department, Dr. Rahim. He's now in London, and he suppose he get a chance, he comes over here and talks to the students, encouraging speech, inspiring speech and all. So he was instrumental in making this happen. And this has been there since 2006 without any break. This MOU is kept live because of the active participation and active, there is an inner feeling in Class NK that students should come up, they do research, they should do research, and the maritime industry should grow because of research and other activities related to that. So this is the major, the reason behind why they are keeping it live. So in this context, I would like to thank Mr. Sumitran Sampath for coming over here and presenting prestigious. The press used to give good coverage to this prize by writing as international prize for ship technology department students, and I used to read it, international award. That's a catchy word, that international award. So this they used to always they used to highlight this award. So we are thankful to Class NK. We are thankful to the award winners, the winner Praveen, and the parents of Jishnu and K. Sridhar for coming over here and receiving the award. And this award has got a very peculiar status because it is signed by the chairman of Class NK, which is the largest ship classification society in the world, and is signed. This certificate is coming from Tokyo, not from Mumbai. So that has got a relevance, and you can hang it. You can hang it in your house, Class NK certificate. So I would like to express my sincere gratitude to all of those who have attended this function and graced this occasion. Thank you.
Thank you, sir. Thank you, ladies and gentlemen. This brings us to the end of the ceremony. I would request the chief guest and professors to come forward for a good photograph with the award winners and parents. Sir. Yes, sir. Here. Outside. No, here only. Yes, sir.
Ladies and gentlemen, we'll continue with technical session 2 now of iCANOE.
Good afternoon, everyone. The Department of Ship Technology, CUSAT, warmly welcome you to the technical session 2 of the International Conference on Advances in Naval and Ocean Engineering, iCANOE 2023. The technical session 2 deals with ship design and production. We have a total 6 presentations compassing various arenas of ship design and production. The session is chaired by Dr. K. Shivaprasad and co-chaired by Sri Aravind, both from Department of Ship Technology. We are so privileged to have with us Mr. Anil Das T, CEO, Conceptia Technologies, with a professional experience of over 30 years in the shipbuilding industry. Mr. Anil Das has chiseled his knowledge in offshore platforms, spars, and marine vessels. It's my honor to invite Mr. Anil Das to give a talk on decarbonization initiatives in ship design. He has established Conceptia in 2004 to deliver value-added services in the shipbuilding and product development industry. He is having 16 years of experience in Indian Navy. He also served in Indian Naval Ship Maintenance Authority and Directorate of Fleet Maintenance. His academic background includes a postgraduate diploma in naval construction and in Indian Institute of Technology, Delhi, and a bachelor's degree in naval architecture and shipbuilding at Cochin University of Science and Technology, CUSAT. I'm sure this session will be a valuable learning experience for all of us. With that, I would like to extend a warm welcome to Mr. Anil Das T for the talk on decarbonization initiative in ship design. Please, sir.
Now we will have the second session, afternoon session of the first day. The invited speaker is Sri Anil Das, alumnus of this department. He has been in the industry, shipbuilding industry, for more than probably 40 years. So his valuable words you can listen to, especially a very hot subject, the decarbonization of maritime industry. So we will listen to his invited speech. Thank you.
Dr. Satish Babu, Dr. Shivaprasad, thanks for having me. That was a very generous introduction that has been given, and I'm thankful to Department of Ship Technology for that. I'm also happy to have participated in the Class NK Awards. Today's talk on some initiatives on decarbonization is something that has been, that is very close to me. And in the last DIMS seminar also, I had an opportunity to evangelize on this. So I am going to share my experiences in this area. Today, I'm also lucky to have 4 of my colleagues from Conceptia here. Welcome, all of you. So I feel that there's not enough talk or thinking on the aspect of decarbonization. So that if somebody speaks on that and brings out what initiatives have been taken, it becomes an incentive for the others to follow. Also, to be kept in mind is that there is no design goal right now for decarbonization. We have all the other design goals that we keep in mind for arriving at a design. So I also shall be presenting certain of these with examples so that it is appreciated in that manner. So I'll request the next slide, please. Okay, yeah. So I've just put a definition on the screen for you all. So there is a lot of greenhouse gases, more than 50% of that is carbon dioxide. That is coming into the atmosphere and into our environment because of our economic activities, our own activities, unmindful of what impact it happens onto the environment. So let's look at that. Use of natural resources. One of the main theme of my presentation today is about consumption and how to manage consumption. So when we exploit natural resources, it is quite rampant and uncontrolled, and not enough care is taken while doing this activity of exploitation. As a result of that, what we see is these kind of acid water leakage, acid mine drainage, as it is called, into our environment. These are highly acidic with heavy metals, and that causes irreparable damage to ourselves, human beings as it is, and the animal life in this planet. So in this regard, I want to share my, So I said consumption is one of the main themes. So consuming responsibly is a very important trait that we can all adapt in our lives. So I'm showing this because when we put brakes on our consumption, we also be better prepared to have certain restrictions in our life, and so the hardships that we'll have to face because of that. Now, you all must appreciate that we are talking about decarbonization. For centuries together, we have been carbonizing the atmosphere and the environment. Now we are trying to decarbonize. Therefore, definitely sacrifices is required. The next slide, it's not moving. Yeah. So this is table of paper consumption in my office. So the idea is that if we measure, then we are able to manage it better. So in the period from April to October of 2022 to 23, we can see we have saved 3 reams of A4 size paper. It takes saving of up to 12 reams to save a tree. Therefore, this is some kind of a goal that we can have in our mundane daily life activities. So this is something that to measure what we are consuming. In the maritime sector, power generation and power required for propulsion, these two are the major contributors. If we compare, it's actually not 50-50, but even if one of them, any one of them can be removed to reduce consumption of fuel oil on board the ships, we are contributing to decarbonization, right? So either power generation or propulsion. Now let's see where we can do that. So what are the strategies to reduce fuel oil consumption on board? As naval architects, we know that if we reduce the load, then there is definitely an effort towards reduction or reducing the consumption on board. So there we will see how we can do that. Some of the examples that I will be showing in this, I have 3 examples. So the first one is, this is a structure that is used for training purposes. It is a variable load. By ballasting it, you can have weight increase, and it is articulated structure. Now, because it is 70 tons that it is supported from the two and getting articulated, it has a structural strength that is required, and that has been designed using the class rules. But the difference is that when you bring in the goal of weight reduction, then you have to go beyond class rules towards optimization. And the class accept that because they need proof that, yes, your calculations, your analysis are correct. Therefore, use sophisticated tools and methods such as finite element analysis and reduce the weight of that. It is easy to use or follow class rules and then do it, but this is a step further with the goal of decarbonization or reducing of consumption. So now let's go forward. Second example. Here, during the midlife or the life extension period of a particular ship, we had to change the prime mover and the gearbox. The rest, everything remains same. So the project objective was taken also into the decarbonization aspect into consideration. And you can see the selection of the engine reduced from the previous engine, which was guzzling. There was a reduction of 34.39% of the specific fuel consumption. Now, this is a research vessel. It is deployed almost 300 days in a year. And over 15 years of life, it is able to save 23,678 tons from being burnt. So that it is a small reduction, but it plays a very important role. And you can see on the screen the amount saved, that's at 93 rupees diesel cost today. So these are fantastic savings, and such kind of projects need to be implemented. Implementation might maybe cost you 50 to 60 crores, but the results are fantastic. We saw that the weight reduction or the saving in specific fuel consumption alone gave us substantial savings. But going further is the weight that is coming in, because the old engine is going out, new, more efficient engine is coming in. It comes with lesser weight on board. Therefore, there is another effective saving of almost 16.38%. So therefore, that is additional saving, bonus, I would say. Okay. Now let's look at further. Energy efficient lighting. So during a mid-life or a life extension program, a series of opportunities like this will come. How do we take advantage of that? And how do we ensure that we consume less is of utmost importance. This is where I'm making my point. The next one, what we couldn't do in that project was noise control. The energy or the efficiencies of human beings on board or the animals in the sea, they are suffering because of noise pollution. The engine room noise levels are 125 dBA while the ship is sailing. And in harbor, it comes to about 85. But what we are looking at is of the order of 55 to 60 decibels, where you can sleep comfortably with the engines running. So that we couldn't do because if I had the opportunity, we could have gone for that. Now, with that, I would now like to show you the next one. This is our design, the hydrogen-powered tug. As you all know, fuel cells produce electricity when supplied with hydrogen. This figure explains how the power is generated. Basically, the hydrogen atom gets split into electrons and protons through the catalyst action of the anode, and the hydrogen ions pass through to the electrolyte onto the cathode, and you get electricity on the other side. So this is what we have used. Our 50-ton bollard pull tug, which is a conceptia design and operating in Kandla port, built by Hindustan Shipyard, has been converted using the power source is fuel cells, 10 of them, and compressed hydrogen cylinders are carried. I was happy to note that in the paper number 1 also had similar arrangement of hydrogen bottles, which we are coming to, but he was using LNG, I think that. So here, these compressed hydrogen is carried on board, and you have a battery bank as emergency power, not a diesel alternator. All kind of fossil fuel is removed, and the azipod thrusters take the noise completely out of the ship's envelope, and it is functioning in the water, totally silent from ABB. Then we have DC switchboards, which will take care of the DC current that is produced. And of course, on safety grounds, we need to have hydrogen elimination system, which because of safety reasons. So again, you can see what are all going out. There'll be fantastic space availability inside the engine room, because all kinds of systems that support the engine, the IC engine goes out, and the gearbox is not there, not required, because now you are getting RPM on demand, not depending on the gearbox ability to give or not. So a whole lot of facilities that are coming into it, and the funnel totally goes off. So there is, I mean, it is good for decarbonization because there's no facility for the emissions to go out. So totally that speaks volumes. So this is the GA. The dimensions of the tug remain same. The power of 1622, that is 1.6 megawatts propulsion power, is totally in the azipods and hydrogen bottles. You can see that it is on the quarter deck, vertically mounted and exposed to the atmosphere. And we will have watertight hatches preventing the water inside. And you can also see the fuel cells that is there towards the forward of the engine room. So this is the the third example as our initiative towards decarbonization. So looking closely, so this is where my earlier concern where the opportunity to put a motor has been achieved, has been adopted for this particular design. The next one is the fuel cells. So when we also should have the facility, all the propulsion or pumps get electrically driven. And that is another aspect. So totally run on electricity. Even battery powered would have been good, but this is better. So if you look at the costing, I feel, or I have done on a back of the envelope calculation to find that about it'll be 40% costlier than normal trucks. But it's worth taking that investment in view for achieving decarbonization. So in conclusion, I rest my case. Thank you for listening. These are some of the initiatives we have done at Conceptia. Thank you. Thank you so much.
Thank you, Anil Das, sir. As a token of respect, we would like to present a memento to Mr. Anil Das. Is there any questions?
Have you done anything for silencing of radiated noise? You talked about noise within the vessel.
This vessel, of course, it is not there. But then for the previous vessel, which we spoke about, the underwater radiated noise was measured by the impedance that would be brought about by the shock mounts, that is at the base of the prime mover. We also looked at the structure-borne noise. And going forward, for vessels that require, such as ocean research vessels, you will require the underwater radiated noise to be measured, which is again possible, and where we have worked with MTU, Missionary Trial Units in Mumbai, where you can drop transducers by the ship side and then measure the underwater radiated noise along the length of the ship, so that the profile of the radiations can also be measured and quantified. Thank you.
Yes, yes.
This unit inside, which classification society has got classification rules to classify this ship and the engine?
So DNV has rules for classification for fuel cells. In fact, the fuel cell that we have used is certified by DNV.
Vessel, classed vessel, what is the class notation given to?
So here is where a lot of interaction with the owner and the classification society is required, because there are several gray areas. There are logistical issues, safety issues, as well as administrative issues to be taken out, to be discussed and finalized. I know it may be a first for class also, but in Europe, the next year would be the first fuel cell powered ship that's going to be coming out for Shell, from Shell. So until now, there is nothing. DNV is working with that.
Anybody has questions?
Sir, Conception was working on a virtual some platform training. Any update on that? Or is it
No, we do not have it on the forefront right now, where we are investing the maximum. Yeah.
Okay. Sir, you mentioned that the cost is going to be about 40% more, or cost is 40% more than the actual cost or the original cost of a diesel engine?
For a tug of diesel powered tug, which we have, it is about 60 crores. So I am anticipating about 103 crores will be the total cost of this, because the fuel cell itself is €500,000. That will be, it has to come from Norway. So if you take into account, then you also have reduction in equipment that are going out, the piping systems, the valves, all those things also go out. So there is a net saving of, and therefore it becomes 40%. Otherwise it will be much higher.
So in the previous talk, wherein the CEO of SEDS mentioned that the market price is it's not your cost price.
Yeah.
The market price.
No, this is capital cost, not the operating cost.
So what would be the motivation for, first question is, what would be the motivation for an owner to invest that much in a vessel like this when he can get it at, for 40% less cost? Number two, then what do you propose are the national or international initiatives that will help promote this and finally converge into a carbon neutral?
That's true. That's a very good question. So two things. One is the proliferation of the hydrogen economy. As you know, that several of the public sector undertakings, such as NTPC and ONGC, they are all investing in hydrogen. And most importantly, private sector investments by way of Adani's, the Tatas, they are all investing in hydrogen. And world over, even if you look at Google, Europe, in Germany, you can see several outlets for hydrogen, but not in Norway. That means it is not fully proliferated. Recently, President Biden in the USA has promulgated the hydrogen investment strategy and invested a huge, fantastic sum for the hydrogen economy in the US. So these are being done because decarbonization is of utmost importance, and we have to reduce the global warming which is there. So these two things, and what incentive for the owner is, initially it will be all government subsidy, because we have a goal that all the Indian ports should be green by 2030. So there is a lot of incentive or impetus for this kind of non-polluting fuels to be used. Yeah. Thank you. Thank you so much.
Thank you, sir. As a token of respect, we would like to present a memento to Mr. Anil Das. I would like to welcome Dr. Shiva Prasad to give away the memento. We will right away move on to the paper presentations. The technical session 2 deals with ship design and production. We have a total of 6 presentations encompassing various areas of ship design and production. To the attention of the participants and chairs, the total time allotted for each presentation is 12 minutes and followed by 3 minutes for Q&A. We will be distributing participation certificates at the end of the session. The session is chaired by Dr. Shiva Prasad and co-chaired by Sri Arvind KR. Sri Arvind KR is a highly skilled and dedicated assistant professor in naval architecture and marine engineering with a strong academic background and 8+ years of industry and academic experience. He has demonstrated his expertise in ship design and construction, hydrodynamics, and naval systems analysis. He is an expert committee member of Kerala State Water Transport Department, Kerala Shipping and Inland Navigation Corporation, Kerala Maritime Board, Kerala Startup Mission, and Samagra Siksha Kerala. Over to Arvind, sir.
Thank you. Before I officially get into my responsibility, let me try to share my excitement after hearing the lecture from Anil Das, sir. Sir, we have some funded projects already in line to convert the house boats. So basically, we are in the process of purchasing the equipments, and we are in line to get a funding for the hydrogen fuel cell systems, which can be incorporated into this particular project. So by hearing this eye-opening lecture, I hope that you will be able to share some of your knowledge. If not commercially, at least we are having academic interest. So we'll discuss in detail after this. Yeah. So getting into my official responsibility to introduce this chair here. So ladies and gentlemen, it is with great honor and enthusiasm that I introduce Professor Dr. K. Shivaprasad, a luminary in the maritime domain, to lead our distinguished panel on ship design and production. Professor Shivaprasad holds a PhD degree focusing on the development of best practices in ship recycling process, a landmark achievement recognized as pioneering doctoral contribution to the field. He also has a master's degree, MSc in ship production and an undergraduate degree in naval architecture and shipbuilding from the Cochin University of Science and Technology. Additionally, he is an esteemed member of the various technical committees, which includes member of the board of director of Bharat Heavy Electricals Limited, BHEL, a distinguished Navaratna company under the Ministry of Heavy Industries in the Government of India. He is also an esteemed member of the technical committee for Class NK, the Japanese Ship Class Society based in Tokyo, Japan. His diverse expertise includes the areas like inland waterways, ship recycling, and sustainable engineering. As we embark on this session on ship design and production, we have the privilege of being guided by a true visionary in the field. Please join me in welcoming Professor Shivaprasad as he shares his insights and expertise to further enrich our understanding and progress in the areas of ship design and production. Welcome you, sir.
Very good afternoon. Arvind was mentioning about my PhD work. I did my PhD work in ship recycling. My small two kids, when I was doing this, they were, those kids were 10 years and 12 years. So they used to ask me, Father, you're teaching naval architecture and shipbuilding and you're doing shipbreaking. What is this? What is the contradiction? Teaching something and doing something else, exactly opposite to that. So we need to focus, and I used to tell that ship recycling is the most dirtiest industry, having risk and environmental pollution attached to that. So we need to find a solution to that. Nobody is touching this dirtier, one of the dirtiest industries in the world. That is why I'm touching that. So I had very difficulties in doing that because nobody was welcome to a ship recycling center, especially in Alang. Because if you are entering into that, you may get some information from that. And if you are giving it outside, then you will be caught. Because everything was inside a kind of a hideout. There was a hideout, and nobody was revealing the secret of ship recycling. That was one of the unsafe industry. So when we want to explore, when we want to do some research in shipbuilding, it is always very difficult because shipbuilding is still considered to be an industry with a lot of human labor content and inaccessible areas. Oxygen, absolutely no oxygen inside some of the regions, no light, no sound, nothing. It's an isolated, even now it is an isolated place, just shipbuilding industry. So if you want to do some research and come out with paper, it is difficult in shipbuilding, ship production, or marine engineering and all. And we are here, this department is here to explore possibilities in ship design, ship construction, ship recycling and all. And I'm very happy that this session, second version of iCANOE has attracted more papers on ship design, construction, and welding or whatever it is. So very happy to chair this. Let us listen to the speakers, what they are coming up with. Please, the speakers, please restrict to your time limit, maximum time limit. And I expect the participant to ask questions. If you are not asking questions, I will not give marks to that particular paper because there is a marking system. I will not give best paper award is there. If there is no question, 0 mark. Questions should come. Then only the paper will be treated as presented. Please ask questions, come up with good questions, and make this presentation more live and attractive. Thank you.
We will be starting with paper ID 102, Mr. Tajuddin A.K., Department of Ship Technology. Title is Repair Welding of Aluminum Alloys in Marine Industries, a Critical Review.
Respected dignitaries and other delegates, good afternoon. Today, I am here to give you a brief idea about the review of the paper about repair welding of aluminum alloys in marine industries. These are the contents. Introduction, aluminum alloys for marine application, 5000 series and 6000 series, properties and characteristics, repair welding of aluminum alloy, microstructural changes, mechanical properties, corrosion studies, conclusion, future scope of repair welding, and references. In the metal industry, the volume of repair and maintenance is far more than that of manufacturing. When the defects are detected in the vicinity of the weldment, repairs are required to extend the service life of that component. Repair welding is one of the important maintenance and repair process. In shipbuilding industry, the repair welding process is used extensively to improve the service life of the component. Aluminum alloys are the most important materials, and 5000 and 6000 series are commonly used in marine applications, where low density, good mechanical properties, and better resistance to corrosion are desired. When these metals are exposed to marine condition, different types of destructive attack can occur. Then most of the investigations have been performed on aluminum alloy to study the effect of alloying elements, various heat treatments, and welding techniques on microstructure, oxide film, creep, and fatigue behaviors. This review focuses on the investigations on aluminum alloys and studies related to mechanical, microstructural changes and corrosion behaviors under multiple weld repair effect. Aluminum alloys for marine industries. Aluminum and its alloys are recognized as the most useful materials and for offshore and marine constructions. Aluminum is one of the lightest material and are very easy to extrude and fabricate. The important properties are high strength, excellent corrosion resistance, high strength to weight ratio, lightweight, high thermal conductivity, etc. Coming to 5000 series, in 5000 series, magnesium is the main alloying element. It has high strength and toughness, excellent corrosion resistance, good weldability and durability, and which has a typical ultimate tensile strength of 317 megapascal and yield strength of 288 megapascal. Here, the most commonly used 5000 series alloy, aluminum alloy in shipbuilding industry is 5083, which can be easily formable and are used in weight-sensitive vessels for hulls, hull stiffness, deck, and superstructures. Then, by using 5000 series, it is preferable to avoid the use of aluminum alloys with having more than 3% of magnesium, where the temperature exceeds 100 degrees Celsius. In such cases, they are they could undergo sensitization, and they are vulnerable to stress corrosion cracking. Then the other alloys in 5000 series are used in marine constructions are 5086, 5454, 5456 preliminary in the form of sheets and plates. Then coming to 6000 series, they are heat treatable alloys and have magnesium and silicon are the main alloying elements. Then they have excellent corrosion resistance, great extrudability, moderate strength, good weldability, etc. They have ultimate tensile strength of 310 megapascal and yield strength of 276 megapascal. They are used in the fabrication of deck panels, railings, walkways, stairways, and marine frames within ship structures. Other 6000 series aluminum alloys in marine environments are 6061, 6063, and 6082. Among them, 6063 find extensive application in the construction of boats and ships. And here 6061 is applied in the ship structural stiffening element and can be used in the creation of most stiffened deck panels. Then repair welding of aluminum alloys. Repair welding is one of the important maintenance and repair process. To improve the life of the structural component, the defect present in the weldment has to be repaired by using suitable repair methods. This method usually comprises of mechanical removal of the part of the weld and redeposition by using same welding parameters. This is the schematic diagram of the different weld pass, and if there is any defect present in that weld pass, that part has to be removed mechanically and redeposit by using the same welding parameters. Here, such repair approach unavoidably subjects the remaining part of the weld to additional thermal cycles, which are responsible for microstructural changes. Repair welding finds a broad range of industrial applications where components or structures need to be restored, reinforced, or fixed due to wear, damage, or other issues. Then microstructural changes. The microstructural changes can be checked by using scanning electron microscopic or transition electron microscopic techniques. The studies shows that the base metal features smaller grain size than the weld metal, which has a coarser grain size. Then subjecting the base metal to elevated temperature near its melting point led to the occurrence of grain growth phenomenon and the creation of interconnected precipitate networks along the grain boundaries. Here the figure shows the microscopic microstructure of base metal, then heat affected zone and weld metal. Here we can see that the microstructure of the base metal is smaller grain size than the weld metal or the heat affected zone. The microstructure of the top two weld passes exhibited consistency in each repair, displaying uniform grain size and a consistent range of hardness. The grain size increased in the lower weld pass in direct proportion to the number of repairs, and the bottom pass of the weld will be softened due to the additional thermal cycles. Due to the additional thermal cycles, because of the multiple weld repairs, there will be a softening of heat affected zone also. Then coming to the mechanical properties, the different types of mechanical tests have been performed, and the conclusions are the tensile strength decreased with the increasing number of repair welding. The reduction in tensile strength can be due to the existence of porosities and reduction in hardness within the weld metal. The microstructural changes caused by the multiple heat cycles may be the cause of the hardness drop. Then studies have indicated that the potential connection between the elevated tensile strength and the improved fatigue properties of welded aluminum alloys. Here in the case of 7N01 aluminum alloys, MIG welded joints, the tensile strength value for the initial joint is 283 megapascal, and after repair welding, it has been reduced to 280 megapascal. It may be possible to reduce the size and occurrence of defects introduced through the weld repair process by implementing post and pre-weld heat treatments on the material. The figure shows the schematic diagram of the tensile test specimen and impact test specimen. This is the actual photograph of the specimen after bend test. Coming to the corrosion studies, aluminum alloy 5083 hardness 112 was repair welded up to 4 times with aluminum alloy 5183 filler wire, and they are using 2 techniques, that is nitric acid mass loss test and linear polarization resistance test, and concluded that after each repair, the susceptibility, corrosion susceptibility will increase. Then aluminum alloy 1100 and 5083 were examined in the natural seawater at room temperature and at elevated temperature. Then corrosion behavior was investigated using potential dynamic polarization test, immersion test, and potential time measurements. And the conclusion was found that the both aluminum alloy 1100 and 5083 experienced pitting corrosion at room temperature and at elevated temperature also, and the severity will increase from when the temperature increases. And this is the optical photograph of surface morphology of aluminum alloy specimen after the potential dynamic polarization experiment in seawater at room temperature for 5083 and 1100. And coming to the conclusion, aluminum is almost three times lighter than steel, and if you use that material in shipbuilding industry, we can get enhanced speed, increased payload capacity, reduction in fuel consumption, emission, environmental pollution, and carbon footprints also. 5000 and 6000 series aluminum alloys are frequently used in marine application and exhibit excellent corrosion resistance and high strength and are suitable for marine applications. Repair welding is one of the important maintenance and repair process in which the defective parts can be removed or repaired and they used to extend the service life of the component. There will be a softening effect produced when the parent metal was heated and resulting in 10% reduction in hardness. Then due to the additional thermal cycles. Then the microstructure of the top 2 passes exhibit consistency in each repair, displaying uniform grain size and consistent hardness values. The tensile strength decreased with increase in number of repairs, and the reduction in tensile strength can be due to the existence of porosities. And also there is a decrease in hardness values also. The number of when the number of repairs increases, and the hardness drop is due to the additional thermal cycles. From the design perspective, any strategy incorporating more than 2 repairs would make the entire process time intensive and economically impractical, because the tensile strength will be lowered, the corrosion susceptibility will be increased. So after 2 repairs. Then coming to the feature scope, investigation on pre and post weld heat treatments of repair welded components are necessary to improve the hardness and other properties of the material. The enhancement of fatigue life of repair welded components need to be investigated. Then optimization of repair welding parameters and techniques has much importance among most of the industries. These are the references.
Thank you very much for a very nice talk. My question is, you said the tensile strength reduces due to repeated repair welding. Do you have any limit as to how many times can it be before it loses the strength for the required purpose?
Yeah, there is one investigation, and after they concluded that after 2 repair welding, all the properties are reduced significantly. So up to 2 repairs, it is safe to do the repair welding.
Thank you.
I have what I have been made to understand about the concept of welding as a fabrication process is that typically after welding, the structure is stronger than the parent metal itself. I'm talking about ferrous welding. Now you are talking about aluminum welding. Why do you think the aluminum welds after weld corrective action or rewelding as you simulated, why is the strength reducing? You mentioned certain reasons like porosity or is that, if that is the case, then why is that not there in ferrous welding? Because we don't see this issue of strength reduction during weld correction in ferrous welding techniques.
Yes, sir. Sir, during welding, there will be a possibility of defects like lack of fusion, porosities, and some defects will be there. There is a possibility. And if there is a defect present in that weldment, the strength will be reduced. If we find that defect in any type of non-destructive testings will be there, and if we find any defects, we have to repair that. We have to remove that part and we re-weld that part. And if after rebuilding, the additional thermal cycles will be involved there. So due to these additional thermal cycles, the microstructure will be altered. And if the microstructure changes will be there, then the properties will change. That's why the strength reduction will be there. And after two or three repairs based on that material, it will not be recommendable to after repair welding.
Yeah, I realize you're talking in the context of aluminum weld repair,
yes,
but will this also apply to ferrous weldings?
Yes, sir. This is applicable to ferrous and aluminum, but I have studied on aluminum metals.
Okay, thank you.
My question is regarding the microstructures. First, let me introduce myself. I'm Shija from Indian Maritime University. When the microstructure changes, you say the properties are changing. Then what is the guarantee that your properties are conducive for the operations for which the component is meant for? How do you ascertain this? Or are you doing any kind of heat treatment or any other relieving process to get back the microstructure back to the original microstructure? Because every microstructure comes with certain properties.
Yes.
And you can't afford to have a complete change in microstructure for just because you have conducted a repair. That's a slight concern I have, and if you can throw some light on this, I'll be grateful to you.
Yeah. Actually, not only the microstructure changes, but also there will be a softening of that part. Okay, so the entire hardness of that material will also lose. So after a number of repairs. So that's why the reduction in the properties or the strength is that will be the reduction there.
So actually, when we do welding, the basic philosophy is the weldment, that is, should be of more strength than its parent components. So if the philosophy of welding is lost, then what is the purpose of doing this? I'm a bit perplexed. So could you please tell me this? You said there is a compromise on strength.
Yes. Compromise in strength
Have you carried out any finite element analysis or any small structural analysis on a component's stress carrying capacity or something before the welding and after the welding to justify your reasons?
Yeah, ma'am. Before and after the weldment, the investigation shows that the tensile strength, there is a reduction in tensile strength after repair welding, not after welding. After repair welding, a number of repairs, if the number of repairs increased, there is a reduction in tensile strength. There is an investigation value. The experimental value is there.
Thank you. Thank you so much.
What can you explain what is meaning of repair welding? Are you removing the full welding and then re-welding? What is exactly you mean by repair welding?
Sir, actually, repair welding is if there is any defect present in that weldment, we have removed that defective part only. We have removed that defective part only and re-weld that part. That is repair welding.
And are you using heat to remove that?
No, mechanically we have removed that part.
Hello, myself Sahid from CSL. My doubt is like which type of welding has been considered for in this repair welding case? Like which type of welding has been investigated? Is it? I saw in one slide MIG welding has been mentioned, or have you investigated TIG welding also?
Yeah, this is in that paper I have referred. Only MIG welding is there. And this is aluminum. I have considered only aluminum alloys, and MIG welding has been considered there.
Only MIG welding
MIG
has
welding.
been considered.
Yeah.
Because usually during construction of vessels and all, for the aluminum, TIG welding is more preferred.
Okay.
So I just wanted to know, you have only considered MIG welding.
Yeah, that no, this paper only referred on MIG welding.
What is the impact of you have only investigated repair welding related to MIG welding part?
Yeah.
Okay.
Okay. Thank you.
Working tea is arranged outside the conference venue. We don't have a separate tea break due to the time constraint. Please be comfortable. At 5 p.m., we will be starting the scheduled water metro trip. Next, I would like to welcome paper ID 105, Mr. Sumitra Sampath, class NK.
Okay. Okay. Good afternoon, everyone. This is not a very technical paper. It is some kind of a proposal that we are making to IMO IACS as Class NK, as a classification society, for going ahead with the learning of autonomous ships. MAS is full form is Maritime Autonomous Surface Ships, but there's no clear definition as of today. What is an autonomous ship? What is not an autonomous ship? Obviously, IMO is discussing the definitions. Meanwhile, classification societies we have already come out with certain guidelines where we say level 1, level 2, level 3, so on. So you might find tomorrow that's an autonomous ship when the definition comes in. At some point of some level, you might even have a normal ship which is having an unmanned engine room be at one of the levels. Anyway, this is the calendar which shows the implementation date or a release date for various guidelines which were released for the autonomous ships. And important thing is that initially the class societies came out with the guidelines, and then the regulatory scoping exercise was completed by IMO. Then the flag states came out with the guidelines. Important to note is from 2019 onwards, the actual demonstration tests for autonomous ships have already started taking place. Why I'm saying it is the technology has started being implemented and demonstration has started taking place while the code is still being developed. So there is a lag between the technology implementation and the code development. Now, MAS is basically to address certain issues such as shortage of seafarers This is not meant for India. Obviously, it is shortage of seafarers in countries, developed countries like Norway or Japan. And reduction of seafarers burden. We say that 80% of the accidents are attributed to human error. So with mass technology, we could address that area. And energy saving and zero emissions, when you have new technologies coming in, most of them will get automated. But there is a hesitancy still whether mass can be applied, because social acceptance is a problem. Because all of us would not be ready. No, I think most of us would not be ready to sit in a driverless car even today, because we are not very sure whether it's safe, fully safe. So that society has to accept it as definitely safe, and then only it can be accepted. So based on this, class NK, based on this, class NK has released a white paper, and where we said that, which is the basis of my presentation today, we said that we have to look at certain safety requirements. We have to look at the gaps that are there in the existing technology. And also we require a framework for the safety assessment. Now, what do you mean by safety of an autonomous vessel? It has to be safe as the same level of that of a conventional vessel. Now, today you are going in a Kochi water metro. Maybe you consider it safe since you're taking the metro without any concerns. So when we have an autonomous vessel, it should have this. You should not have any feeling in the mind that it's not safe. So you should be able to accept the safe. So it should be equivalent to that conventional vessel. But what do we require? How do we apply this for a autonomous vessel? Is a little difficult because the tasks are different. In a conventional vessel, there is always crew is there. In case of emergency, crew will act, and what do we do for a autonomous vessel? So crew may be only a fallback. So these are issues which we have to address, and the only way to address it is that we have to have a risk assessment to do it. And for the risk assessment, we split it out into elements, and the elemental technology, we can use simulation to address each element of the technology. But when it comes to the overall system, we require not only a risk assessment, but also we have to use simulation and demonstration tests. And this is how what we call as a V-shaped perspective on system engineering. And we have the definitions, and based on the definitions, we have concept design developed. And based on the concept design, we go ahead with the basic design is a top-down approach, and then the detailed design. And then when we come to the testing, we use the bottom-up test. We start with the element test, integration test, system test, and then the system operation. And but can we check the safety of the autonomous ship uniformly? Each ship may be different. One ship may have autonomous navigation, another ship may have autonomous berthing arrangement, and therefore it is difficult to apply the safety uniformly for all type of ships. So we have to consider individual cases. Each ship is going to be quite unique because one may be remote center, maybe be available, another may have a crew on board as a fallback option. So we have to consider each one individually, but we have identified key areas which has to be considered for this risk assessment. They are which part of the ship is automated, what is the division between the systems and the humans, division of roles between system and humans, what are the system specifications for the installation, and very important is the clarification of operational design domain. Where are we going to operate? Some ships may be operating in coastal waters, some ship may be in international waters. So again, that is very important. Heavy traffic is there or not, no traffic. That's important to look at. Then fallback. What is the fallback? Is it remote center or a crew on board? Then human-machine interface, cyber security, and reliability of computer systems. We use these key areas to carry out the risk assessment, which will be unique for each type of ship. As the great philosopher Aristotle said, one must learn by doing the thing, for though you think you may know it, you have no certainty until you try. So, and mass is a new technology, so there are bound to be certain gaps which exist or certain risks which exist, which none of us may be able to foresee. So there is a requirement that we have to go ahead with the operation and take the feedback as and when there is a, maybe a near miss or defects or non-operate, where it is not possible to operate the autonomous system. Feedback is necessary for improving the system. So we propose something called as a vulnerability database. It's basically, the word vulnerability means a gap in the system. We borrow the word vulnerability from the information technology space, where they say there's a security gap is normally called as a vulnerability. And we have compared it with the other areas also, like National Institute of Standards and Technology is the nodal agency in US for reporting in IT breaches, IT incidents, and so on. And they have certain specified guidelines for not only collecting these incidents and breaches data, but also for disclosure to public, so that public can use these data for refining their systems. California also requires for the self-driving cars, they require them to report, the developers to report the incidents and identified risks, so that they can again use this data. And then we have the commercial aviation industry, which has a system of reporting the data or any near miss also to the regulator. So we also have to accept that when we are going to start operation of autonomous ships, there are going to be imperfections. It's not going to be a perfect operation, but we require the vulnerabilities or the risk to be reported back. And this data should be collected to refine the rules better. So we have taken followed the model of the aircraft industry is what we are proposing to follow. In the aircraft industry, which is, we have the International Civil Aviation Authority, which is the nodal agency for all these, collecting these information. And the authorities mentioned here are the governments who have their individual authorities. In case of India, it is DGCA. In case of US, it's Federal Aviation Authority. And the various aircraft owners or operators, they will report the various incidents, near misses, any issues that they have, not only to the authorities, but they also report to the manufacturer, Boeing or Airbus and so on. And Boeing and Airbus will also report to their authorities. So there is a total sharing of information across the authorities, operators, and designers. And finally, all this information goes to International Civil Aviation Authority. That's the iCANOE. And we also propose similar structure in IMO, so that there is a nodal agency identified, and we can have a vulnerability database which can collect all this information. And this is what we have proposing, that we have a matrix here, depending on the level of technology and also the application area, depending on the product, whether the product is under development or whether it's a new technology or it's a proven technology. There is a matrix given and you have scores. We have a vulnerability index, which can be calculated based off this matrix. And reporting will be depending on the vulnerability score that is there. And if you have a defect which is causing an accident, it is to be immediate reporting. This is the frequency of the reporting. And if you have something which is disengagement of an autonomous mode, but not resulted in an accident or a near miss, it will depend upon your vulnerability score. And then we have the reporting frequency, maybe monthly, quarterly, or semi-annually, or annually. Obviously, the nodal agency has to be established by the governments, so it has to come under IMO. And as I said, there is a lag between the technology and the regulation. So we have to learn as we go ahead with the technology. And that's why Class NK is going ahead with not only guidelines and rulemaking, but also issuing approval and principles. Approval and principles are issued when the technology is not yet fully mature, but we go ahead. It's kind of a hand-holding for the technology so that we can also prepare for the rules at the same time the technology is being applied. And also we propose these measures. We are making these proposals in IACS and IMO. With that, I end my presentation. If you have any question, please feel free to ask.
Sir, good afternoon. This is Captain Agarwal speaking. I'm on Zoom. If you will permit, I'll raise a question, sir.
Yeah, it's okay. No, it's not a problem.
There is this, I don't know whether I'm using the right word, there is this specter of AI that is looming all over engineering graduates and recent engineering, people who are in the engineering industry. It may be a boon, it may be a bane. Out of all the possible designations that a naval architect actually graduates into, or a marine engineer for that matter graduates into in the current industry, if I request you to pick 2 or 3 which are AI proof, what would they be?
AI
proof, what would they be?
I think there's infinite possibilities. We cannot say something cannot be done. When AI is replacing almost, your way of thinking, it is possible for them to do, AI to be implemented in basic elements. You cannot maybe run a ship on AI, because obviously there could be emergencies which are not foreseen, emergencies not created by that particular ship, but created by another environment as such. So these areas are there, but elemental wise, you can, yes, apply AI.
I mean, if I may just, may I be allowed to ask a follow-up question? Is it okay?
Yeah.
No, like I get the point. Thanks a lot. Clears a little bit. But I was also wondering, like, say, I'm talking on behalf of the recent naval architecture graduates. They could be going into, let's just say, project management side. They could be going to engineering. They could be going into survey side, class side, etc., etc., etc. Or marine engineers, they go into mostly engine side. Then you've got merchant navy where people go into the deck side. So out of all this, if we were to pick maybe 1 or 2 elements or 1 or 2 particular work scopes, which are the least AI sensitive or which are the least likely to be replaced by AI, again, I'm forcing you to make a choice, which probably is not right, but which do you think is the least likely to be replaced by AI out of all this that I mentioned? If I may relist them again: marine engineers who work on the engine side, merchant navy cadets who work on the deck side, naval architects who work on engineering or project management or classification societies, etc., etc., etc. Out of these, which categories?
AI has a particular, certain restriction that it is more of a refinement. It cannot think maybe innovatively or out of the box, definitely, because it's a self-learning. It is based on a self-learning. But on the other hand, you see the computers which play chess, they are able to think innovatively, but it is limited to a chess board, 8 by 8. So they are still able to think innovatively within that domain range. But when you don't have a domain range, that is a limitation of AI, that they will not be able to innovate where there is endless possibilities.
Thank you.
Which I suppose human mind is able to do.
So you were speaking about some levels of automation. I mean, you mean to say they are the degrees of autonomy, various degrees of autonomy?
Yes. What we mean by levels of automation is level 1, let's say top is a top level, or level 4 is a top level. I would say it's fully autonomous. That means there is no crew on board, and the fallback is also computer.
Okay.
We still have not reached that range anywhere now.
Yeah.
Now, level 1 would be there is an automated operation, and crew is on board to take care of it in case of a failure. So level 2 would be there is an automation on board, crew is not on board, maybe remote center is going to take care of it. So that could be different. There are different levels which are defined in our guidelines: level 1, 2, 3, and 4.
As a representative from a classification society, if you were given the option of making a class or a type of ship completely autonomous, which one do you choose? Tankers, containers, passenger ferries, which one do you choose for a complete autonomous, or the highest level of autonomy?
I think that is something that the ship owner, he decides. For example, we have already participating in some projects in Japan. So in Japan, they have targeting 3 types of ships. Okay. First is local container ships, which visits multiple port visits, short journeys around the island, in the various islands, and many berthing, unberthings. So this is one type of ship. Second is again a ferry, heavy traffic areas, that is a lot of fishing boats, and it's for a passenger ferry. Again, visiting many islands, but again, berthing, unberthing at short intervals. The third type of a ship is long distance passenger vessel, big size passenger ship. So these are the 3 type of vessels that they have targeted in Japan. And all these 3 types, the demonstration tests are going on. In case of the container carrier, it is remote operation. In case of the passenger ferry, there is a limited crew. I'm saying the short ferry, small ferry, there's a crew on board, a standby. And berthing, unberthing also is automated. The idea is in Japan, they cannot get too many people for passing the ropes. And the big size passenger liner, it's purely only for navigation purpose. So it depends on what your need is, what for the operations, which you want to automate to reduce your burden. So each one has got a different type of requirement. That's why I said one safety requirement may not be applicable to all of them.
I was just thinking whether there could be one factor that must be deciding what should be the degree of autonomy. But you gave the answer, sir. Thank you. Thank you so much.
Thank you. Thank you. Yeah. Okay.
Hello, any online audience? Do you have any questions? Any questions from online audience?
Can I raise a question, ma'am? This is Captain Agarwal.
You can read it out, I suppose.
Question. Any online audience questions?
I put a question in chat box.
You can show the chat box here.
Hello, sir. Can you please repeat the question? We can hear it.
Good afternoon, everybody. I'm Captain Agarwal speaking. My question was, how does Class NK plan to look at the need of a master to help the efforts of autonomous ships, because that is what is holding IMO to go ahead with any kind of autonomy or rule giving? Thank you.
Yeah, I think that's a very good question, because I think master on a conventional vessel not only is playing the role of a leader, but is also a legal entity. And also there are Similarly, we also are looking at, how there are legal issues which are presently being discussed in IMO as regards to who will take the liability when there is a incident. So these are all, I suppose, connected issues. And there is, if you see I don't know if any of you have seen the regulatory scoping exercise that's carried out by IMO. It was done by various class societies, flag governments. IRS also did, I think, some of them. We also did some of them. And most of the areas where the gap existed was related to the master. Now, master is responsible. What happens in an autonomous ship? Who's responsible? Obviously, that matter has to be looked into. As of now, we do not have any answer to that, who will be responsible or anything. These are issues which are finally have to be discussed and agreed upon in IMO. But definitely what we understand is that, if you look at the International Civil Aviation Authority, we are following that trend now. They have a requirement that none of the operators or pilots or engineers will face criminal proceedings for reporting any information, unless it is proven to be pure negligence. So that is the model we are following. Initially, there will be an experience building phase that will be likely to be introduced by IMO, where information is going to be collected, and people will not be held liable in such cases because of a failure, something happening. Because we require if you see this vulnerability information is a big, could be a big risk to if somebody is wanting to disclose such high risk information also, it could be a risk. So the government will have to, IMO and the governments will have to make a framework where the information can flow freely and nobody will be held responsible. So I think, I have a feeling during the experience building phase, you will have the standby master and crew available on the ship, and there will be an experience building phase over which we will collect this information, vulnerability information, and then we can further think about how we can, do away with the master's duties and so on, if it's fully autonomous. But however, that is level 4. We still have not reached that level. We are still in 1 and 2, where we still are having, either a fallback crew or a fallback even in remote operations. So that is what we are looking at as of now. So in such cases, we still have the master on board as of now. That's my opinion. Thank you. Is that okay? Yeah, thank you.
Next one, paper ID 124, Mr. Anand Ajit Kumar from Indian Register of Shipping.
Thank you. Good afternoon, everyone. Respected dignitaries, faculties, and teachers. Is it audible? Okay. Good afternoon, everyone. Respected dignitaries, faculties, and students. My name is Anand Ajit Kumar, and I'm currently working as assistant surveyor at Indian Register of Shipping. So my paper is on vulnerability assessment of a container vessel using second generation intact stability criteria. Basically, I have analyzed the stability of a vessel for all its loading condition using a new IMO criteria. And I'll be discussing its results and insights gained from the analysis. So before understanding the second generation of intact stability criteria, we must understand what is first generation intact stability. The first generation intact stability is nothing but the intact stability code 2008. So it was created in 1993. Then it got amended in 2008, and it was made mandatory by amending the SOLAS Convention. But during its creation in 1993, there was a lot of criticism from the member states and different researchers. Basically because it did not assess the different stability modes of failure when the ship is facing waves, different dynamic stability failures. Like because understanding the limitations of the first generation, IMO started working in 2002 on something called second generation of intact stability, which assessed three different fundamental reasons for stability failure in waves. And finally, in 2020, they published the interim guidelines for the second generation of intact stability. And they assess three dynamic failure modes, like stability failure can occur due to variation of GZ curves, like phenomena like pure loss of stability and parametric roll. Then it can occur due to wave forces and wind forces. That is because of the rough weather condition. They assess conditions like dead shift. It was already assessed in the weather criterion IS code also. And then they assess it can occur due to excessive acceleration. Excessive acceleration is not actually a stability failure, but I'll be explaining it later in the slide. And then the third reason for failure can be due to loss of maneuverability. There are different wave cases in which the ship loses its maneuvering power, and it can cause stability failure due to that. So this is the first reason for stability failure, that is variation in the GZ curve due to when the ship encounters wave. Let's assess a phenomenon called parametric roll. Parametric roll occurs when the wave encounter period is half of the ship roll period. Suppose when we consider the in the first case, suppose we take a regular wave and ship is encountering it when its ship is rolling, and when it goes to the port side, suppose we assess a situation in which the trough is situated in the middle and crest is in forward and aft side. So basically the water plane area here has increased because since the crest is in the forward and aft, the breadth is more on the top side. Since the crest is on forward and back, so the GZ curve has increased, and the stability, you can say the righting lever has a strong pushback, and it goes to the starboard side. And when it reaches the starboard side, as I told you, the encounter period will be half of the roll period. This phenomenon occurs when the encounter period is half of the roll period. So here you can see that the crest will be on the middle and the trough will be on forward and aft. Here the water plane area has decreased. The GZ curve also decreases. So the ship will be rolling more to the other side because there is less righting lever. And this can be repeated, amplifying the roll, and it can lead to capsize. Another phenomenon is same, pure loss of stability, but pure loss of stability only occurs in the following sea. Suppose the speed of the wave is same as that of the vessel, and this wave will be exposed to the vessel for a longer period of time. This is you can see pure loss of stability in the middle. The crest will be in the middle, and the righting lever has decreased, which might lead to capsize later if any wave forces occur and lead to capsize. And the other phenomenon like the dead shift condition and excessive acceleration is due to wave forces and wave and wind forces. The dead shift criterion is already assessed in the weather criterion of IS code, but this happens when due to where the ship is rolling and due to a sudden wind or gust occurs and it goes to the leeward side due to the wind forces, and there's a coupling moment, and if the area under the GZ curve is not enough, it could lead to capsize. Then there is excessive acceleration. Excessive acceleration is not a stability failure mode. This is actually for the safety of the, suppose the GM is high, then the roll period will be the ship will be very stiff. So suppose the crew is on the bridge and the acceleration on the top side will be, the acceleration on this top side will be more due to the distance and the roll period being same. So this acceleration could lead, make the crew loses balance or hit a bulkhead, and it is very fatal. And surf riding, this is another phenomena where the ship loses its maneuvering capacity. Like it occurs when the suppose a ship is traveling at 28 knots and there's a wave of 30 knots, and if the surge force in that wave is enough to overcome the difference between the resistance and thrust, it might capture the ship and the wave might take it with it. It can be compared to a surfer, and due to this, it occurs at a specific location. This is at the forward top of the wave, and ship will be losing its maneuverability, that phenomena is called surf riding. And due to an uncontrollable turn, the ship will be turning to the profile view, and the wave will cause it to capsize. As I told you, I have analyzed the IMO has published its interim guidelines on second generation in 2020, and they have asked all the member states to use the interim guidelines and report their experience back, because it's still in the refinement stage. So I have conducted an analysis for a container vessel, and it had 25 loading conditions, 148 meters of length, and this is the GM values. It will be, and you will note that after loading condition 9, there's a sudden significant decrease in the GM, which will be important in the later slide. I'll be telling you. So the analysis, this second generation is a multi-tier approach. There are different levels of assessment. Level 1 is basically based on simple empirical formulas, and the safety margin of it is more, and it is more conservative. And level 2 is more based on simplified physics. We'll be numerically simulating the regular waves along the length of the vessel, and it's less conservative than level 1, because it's more accurate. Level 2 is more accurate than level 1. So ship will have more probability of passing level 2 than level 1. And if a ship doesn't pass level 2, then we go to direct stability assessment that includes CFD and model testing, etc. My scope of the paper is only level 1 and level 2. If the DSA also fails, we will go for operational measures. This is the environmental condition. As I told you, we are numerically simulating the waves along the length of the vessel and for this phenomenon. And the environment which I have considered is the North Atlantic environment, which is the most conservative. This is something called a scatter diagram. It includes these boxes that you see here are basically sea state. This is the wave height, and this is the wave time period, and these boxes are the sea state, different sea state of North Atlantic. And in the level 1, when we are considering parametric roll, here the level 1, we can see that almost 7 loading conditions were failing. The red bar is the conditions which are failing, and the second one here 5 of the loading conditions were failing. Actually, level 2 consists of 2 criteria checks. The check 1 is in check 1, all the loading conditions were giving 0 criteria value, means the ship has passed the criteria. But in check 2, it's based on the vanishing stability and the this is the theoretically we are doing this, we have a numerical IRS has developed a numerical tool, and we'll be simulating the waves along the length of the vessel. You can see that when the waves reaches the middle, the GZ curve decreases, and as it's actually we are not in the GZ curve, we have considered the trim and sinkage also. In the figure on the left is a simplified version. That's why it's not showing the trim and sinkage. The level, check 1, as I told you, parametric roll, the criterion 2, the ship, all the loading conditions were satisfying the criteria, because the GZ curve, the worst case scenario is when considering a regular wave, if the wave is equal to the ship's length, that is the worst case scenario. Here the wave was we're considering the rate of change of GM, and here it was lower than the these are the wave cases that we have considered. And this is for the dead ship condition. Dead ship condition level 1 is the weather criterion. Basically, here all the loading conditions were passing, and since the level 1 in the second generation and the weather criteria of the IS code are basically almost the same. There is just a difference between the the steepness values, where we use it to like find out the healing angle. Here in weather criterion from roll period, if the roll period is more than 20 seconds, like all the steepness values will be considered as 0.035. And if in the DS level 1, it is less conservative. After the 20 roll period, the steepness values will be decreasing. So it will be less conservative. And the ship was passing all the loading conditions, and we could say that the ship wasn't vulnerable to dead ship condition. And in pure loss of stability and excessive acceleration, these both are contradicting phenomena. Pure loss of stability is because there is less GM. It happens because of the GZ curve has reduced. Excessive acceleration happens if the GM is too high. So these are both contradicting phenomena. Here you can see that from loading condition 10 to 25 was failing the pure loss of stability, and in excessive acceleration, loading condition 1 to 9 was failing. These both are contradicting. So we need to go for direct stability assessment, which was out of scope for this paper, and it can be used for later research or later purpose. And when considering the surf riding and broaching, so surf riding and broaching, all the means the loading conditions which had more resistance was less vulnerable to surf riding and broaching, because it occurs when the wave surge force is less than the difference between resistance and thrust. So the loading conditions which had more resistance were till 0.32 foot number, or the loading conditions were passing. And for loading condition which had more draft, like the 8.444 till 0.32, it was passing the criteria. After that, it was after 0.32 foot number, it was started failing. So when considering the conclusion, like for DS dead ship condition, all the loading condition was passing the criteria, because the DS level 1 criteria was similar to the weather criterion, except there was a difference in the steepness value. So we don't have to, the dead ship condition is not something which we have to worry in the second generation of intact stability. And regarding parametric roll, as I told you, in check 1, it was passing all the loading condition, because the wave cases derived from the scatter diagram was not particularly equal to the length of the vessel. Like the parametric roll usually occurs when a wave, when considering a regular wave, it will be equal to the length of the vessel. And due to that, there will be more reduction in the GZ curve. And when analyzing pure loss of stability and excessive acceleration, they were both contradicting. Excessive acceleration was failing because there was more GM, and pure loss of stability was failing due to less GM or GZ curve. Just riding lever. So from surf riding, an increase in draft showcased a reduction in the vulnerability.
Try to make it brisk. We are already running ahead of time.
Okay.
Yeah.
Yeah. This is a last. So to minimize the number of loading condition, we have we have considered particular loading cases, and since surf riding was not very sensitive to GM, we coupled a lot of loading condition together. We analyzed for just 5 loading conditions, so we can reduce the this thing. If we are using CFD, resistance can also be found out using Holtrop and other empirical methods, but CFD will be more accurate. If we are using CFD, we can use the method that I told in my paper to reduce the number of loading conditions to analyze the criteria. So thank you. That was the end of my presentation.
This is not implemented by IMO, the second generation stability.
They have not implemented it till now. They have published the interim guidelines, and they have asked all the member state and all the stakeholders to try this interim guidelines and report back their experience. It's still on the refinement stage, and after the refinement stage also
it may come in.
Yeah, may come.
We know that many examples don't prove a theorem.
Yeah.
So how will running all your test cases help IMO? What is the IMO planning to do with that data?
IMO, sorry?
What will IMO do with the results of these test cases?
Yeah, they suppose these criterions have a certain limiting values. They might, according to the since they have asked all the member state, through this result that they receive from the member state, they might change these criteria values to make it less conservative, and through data analysis, through this data that they receive, they might change this limiting values to make it less conservative when considering different levels.
Hello, just wanted to know this excessive acceleration.
Yeah.
Which point of the was it evaluated at multiple points or at a single point?
We are considering the topmost point actually. If it passes the topmost point, all the other below this also will be safe.
We will be considering that passenger accommodation topmost point.
Like the bridge, probably on the bridge.
Okay.
Thanks.
Next is paper ID 140, Mr. Avinash Gode from Indian Maritime University.
Yeah. Good afternoon to all. My name is Avinash. I'm working as an assistant professor in Indian Maritime University. So this paper is combinedly authored by myself, Professor S.C. Mishra, and Dr. Srija Janathan. The topic itself is parametric study and power assessment of ballast-free ships. So this ballast-free ship concept, which is there, has been long existing, but a real solution for the requirement is still not yet arrived at. And as you all know, the main requirement of ballast water. So the ship would be going empty to one port. So whatever the ballast water which is there is taken on board, then it is filled, the cargo is unloaded, ballast water is taken, then it goes to the other port, unloads the ballast water and takes in the cargo. This is a well-known phenomena. And during this particular process, there is a lot of invasive species which are transported from one place across to other place across the oceans. And when these invasive species are transported across the oceans, it becomes a threat to the local indigenous species which are available. So some of the requirements, as you can see, the ballast water is mainly required in terms of the propeller immersion, as well as in ballast condition, the stability to be maintained. On the ecological impact side, as I've told, if it is going to the new environment, it happens to be a threat to the local ecological invasive species or species which is there. And not only that, it imposes a health threat to the humans if it is mixing with the local environment. As per the Ballast Water Management Convention, as of now, we are at the D2 standards, wherein the ballast water is to be treated to a certain bit of accuracy so that it can be discharged at a other port. Whereas previously it was a D1 standard where it is 98% of the exchange to be done in open seas when it is being transferred from one place to another place. That is, from before it goes to the port B, it has to transfer it for 3 times, where no more it is allowed as on now, or else as on 2024. All the ships are to be equipped with ballast water treatment mechanisms. Now, after 2024, or else by installing this ballast water treatment mechanisms, there is an additional cost which is incurred. Now, the idea is, why don't we come with a option wherein ballastless water is avoided or ballast water is itself avoided, for which there are existing some concepts which are there. I'll just go through these concepts first. So mainly the hull form modifications, or else the constant weight which is being taken in terms of containers, or a B-shaped hull form which is there in the parallel middle body region, or a trimaran, or a flow-through method. The bottom 3 methods are similar to a flow-through method, which I'll be telling. So initially, when I've taken up this particular concept, I worked on a flow-through method. The flow-through method concept is like, in the ballast condition, instead of adding weight, I'll try to reduce buoyancy to achieve my same draft. This can be better explained in the next figure. Now, if you see in the conventional way, I'll have a light ship condition. This is only with respect to ballast case. I'll have a light ship condition and I have a loaded conditions, or else ballast condition, which is there, wherein weight is added in terms of ballast water. Now, the second way of thinking is, I have a light ship condition and I try to subtract some buoyancy by giving a required damage to the vessel. In this case, it was a bottom opening pipes would be directly open to the sea. And this particular concept which is there is not directly taken. It is taken from the University of Michigan flow-through method of ballast-free ship. But what they have done is, they have used in the double bottom ballast trunks, we have changed it as pipes so that the drag is reduced. And initial experiments were done at IIT Kharagpur, and in the ballast case, though it is not reflecting here, in the ballast case, it has been observed that we have increased the resistance to almost equal to that of the fully loaded condition. Now, these graphs are indicative of the experimental results and the CFD results in the fully loaded conditions, but the actual results was in the initial phase, since the pipes were kept at the double bottom, the ballast case resistance has tremendously increased because the wetted surface area in the pipes was huge. The double bottom was around 3 meters and the pipe diameter is around 2.5 meters, which is running throughout the length in the double bottom for about 6 to 7 pipes in the double bottom. So as well as this is equivalent to that of the D1 standard, where the local water is there within the ship. So though this concept was working, when it comes to 2024 and after, it would be that you have to go for a different alternative because the flow-through method is no more accepted as per the requirements which is there. The next second concept which we have worked, or the present concept which we have worked, is try to see that the hull form is modified as the case of a V-shaped hull form, which is proposed. So in this case, you'll have a conventional tanker, and the conventional tanker, we want to see that we achieve a ballastless tanker. But in this case, additionally, what I've kept to the previous designs which is there, I've kept that the cargo carrying capacity should be constant, because in all of the designs, if the cargo carrying capacity is not kept constant, and you analyze a vessel with a higher capacity, you will not know what is the baseline or what is the reference for which this whole analysis, or what are the penalties for which I'll be getting. So one constraint I've kept is the cargo capacity is to be altered. And the first method, as I've told, the flow-through method is done, but the second method is the hull form would be changed. So I have systematically changed the hull form dimensions, and the expected result which I'm looking at is 0 ballast or less ballast. And in addition to that, what would be the equivalent tanker if I have to go for a V-shaped hull form? What would be the size? What would be the depth? What would be the breadth? Then the penalties which I have to have in terms of some construction, as well as added resistance which you will get. And one initial difficulty which is there is, how do I arrive at the draft? if the data set or the design space is high. So what I've done is I've just given a rough flow methodology. So initially a CAD model for the hull form, then an offset generation. I'll just come to this offset generation, why it is there. Then there is an FFT box, which is indirectly the hull form transformations, which I'll be doing. Then parametric offset generation for the constraints which are given. Then trying to find out what is the feasible ballast designs, for which I have given one more constraint in terms of ballast draft, as well as I have varied the parameters in terms of length, breadth, depth, as well as rise of flow. Then evaluated for wave making resistance, evaluated for viscous making resistance, as well as then the total results resistance was computed for all the vessels. Later on, only for selected one vessel, we have done the propulsion calculation, self-propulsion test at full scale. So first and foremost, whenever I have a design space, I had to find out what is the increment of vessels which I have to have. The initial basic vessel which was there is around 233 meters. And I had taken these particular dimensions which are shown here based on the existing data. So I have collected the existing ships. This is basically a tanker. So I have taken tanker data, crude oil tankers. So the length, breadth ranges of the existing tankers was taken. And this final set of series of dimensions were kept as an increment or design vessels which are there. And the other challenge which I had was to estimate the light ship weight for all these vessels. So for that, I had arrived at an empirical formula by estimating all the light ship weights by an empirical method. For around 3,000 vessels, the light ship weight of vessels were estimated, a equation was formulated, and thus that equation was used in terms of light ship weight estimation. And roughly, all this set would result to around 504 vessels if I do it. So yeah, so initially I have generated the surface in Napa. Then we have used the cases platform, use the offsets in generating the ship flow. Then I have used the FFD method. The FFD method, as simply explained, whatever region which is required, we'll keep it as a box, and the box is stretched in the required direction, either in X, Y, or Z. Generally, this is done in a localized region, but for the same concept here, I have applied it for the entire ship. And I have given raise of flare as the bottom point, which is being raised up. That the displacement and light ship weight were calculated, and the initial potential flow calculations were done for wave making resistance, estimating only the wave making resistance. So this was the initial calculation which was done. Can you play, please? And first and foremost, I have been it's not okay, fine. So this is coming as the next slide. So for all these 504 vessels, initially we have done, and the first draft was constant. So all the analysis was performed in terms of all 504 vessels. Can you go on, please? Come to the next slide. I'll skip all this. So once this particular thing was done, the design draft is to be varied. So for varying the design draft, I've kept the constraint as the ballast draft. So the ballast draft was empirically calculated from rules. And for all these 504 vessels, whichever cases the ballast draft was failing, it was eliminated, and the resistance calculations was done for the vessels. Next slide, please. Next slide, next slide. Yeah. So for all 504 vessels, the bottom is the ballast cases, and the top is for the fully loaded cases. And the orange dots which are there on the top and bottom, the middle dots are the feasible designs which is there. So based on this, I have isolated all the feasible designs. So these are the ballast case and the fully loaded case feasible designs, for which the wetted surface area versus frictional resistance, as well as wetted surface area versus total resistance was plotted. For the base vessel, as well as for the finalized vessel, the difference in wetted surface area was around 100 meters square. So based on this, the final around 45 vessels were there, 52 vessels were there, which are analyzed for a viscous flow solver. So all these vessels which you are seeing are actually done on a viscous flow solver, taking the wave making resistance from the potential flow solver. So for this, we have used the ship flow and we have integrated with cases so that this particular loop can be run. So once this is done, for the self-propulsion test, I have only selected the vessel which is there, which is having less freeboard. So out of the 52 vessels, the vessel which is having the less freeboard is taken, and I've done the self-propulsion point at full scale, where the initial vessel which is there is giving around 16.7 megawatt at 90 RPM. Whereas if I go for the twin screw, since the V shape is there, the depth was increased by around 8 meters. I had the option of giving a larger propeller diameter, but this has indirectly led to another problem, that as the propeller diameter increases, the RPM reduced, and there is no feasible RPM which can be kept. So I have again done it for a single screw, which is roughly giving a 12.4 megawatt at 72 RPM, where still we can find better solutions if we just look into it. So in overall, this process indicated that a simulation-based design approach may be also employed to see that a new or innovative designs can be analyzed much quicker, easier, to more bit of accuracy, for which we have used cases, FFD transformations, and ship flow potential and flow solvers. And the initial hypothesis, which is we had, that this particular V-shape hull forms which are there, at least in terms of reducing resistance or equivalent resistance, is achievable. And maybe down the line, after about 10-15 years, when people realize that we are spending more on the ballast water treatment, more people would start on accompanying in working this kind of innovative designs, and maybe better solutions or optimum solutions can be found. So this is what is my rough analysis which is there. Thank you.
Any questions?
No, absolutely.
You showed some CFD results and some experimental results.
Yes, sir. That was the initial work. Yes, please.
Yeah, and those two curves cut each other.
Yes.
Okay. Sometimes when CFD people are told that your results are not very accurate, they say maybe, but at least my ranking is accurate.
Sir, that okay. Fine.
So in this case, it seems like even ranking between these two is not accurate.
Sir, actually, the CFD results which are there initially were done. These are a scenario where the conventional ships are not done. So the methodology itself for CFD analysis for a total open bottom. Now, whenever people are doing CFD, now they are keeping both thrusters and then trying to analyze. Now I try to create the whole bottom as the opening. So there are some numerical instabilities which are there at the initial stage, but there was also difficulties in terms of experiments, because there is no experimental procedure which states that if the wetted surface area, which is there bottomly open, it also gives the accurate results. Because when we do the experimental results, the form factor, which is coming as 1 plus K, how do I take in this case is not known. It is not known for anybody. So there are inaccuracies in model, as well as there are inaccuracies in terms of the CFD results, which may be there. Now, I don't go on both sides for the initial analysis, but for the second case where I have shown the V-shaped hull form, the initial CFD model was also tested with the ITTC benchmarking models. And it has been seen that it is within 5%, which is there of the ITTC benchmarking results, which are there at the model scale. Now, there would be again a case where if I have changed the hull form to V-shape, whether the same bit of accuracy would they be there or not, which can be only done by experiments. And this V-shaped hull form, ITTC frictional line, whatever it is mentioning, it follows that rule. So we'll have a better accuracy maybe at that point of time.
Your concluding slide showed, can you go back at, no, the one before that. Yeah. So here you mentioned 16.7 megawatt at 90 RPM and for a V-shaped equivalent vessel 12.4 megawatt at 72 RPM. Are you conveying that there is like a 25% reduction in the engine power?
At this point of time, I cannot directly tell that there would be a reduction which is there, because there are two things which is there. I have only analyzed at the full draft condition. Now, when I go to the, and I have taken a very high propeller diameter than conventional one, because this additional V-shape raise has been an option for me, because of which I can go for a larger propeller diameters. Now, whenever I go for larger propeller diameters, the available engine which is there in the market, maybe maximum of RPM it may provide is around 75 or 70. Now, the initial calculations which I have done are indicative, but it is not totally concrete that it would reduce by 25%. So initially, it is showing a reduction, but it is to be in detail studied, because I have used an B-series method for estimating the propeller P/D ratios and other things. So it is to be physically modeled, and then it is to be established. And I have used an actuator disk method to see that this particular thing is taken. So these things are to be checked. I don't, maybe I need to still analyze a bit to give a concrete statement that I have 25% reduction, which is there. I may say that in this manner, better I'll keep it in terms of wetted surface area. So the wetted surface area is only more or less equal. So I can say that if I have an option for higher propeller diameter, this may definitely reduce my power requirement. But I don't quantify that it is 25% reduced.
I'll just clarify why I asked this question. I represent Aries Marine Engineering, and we have done ballast water treatment system integration designs for about 1,500 vessels. Nobody in the world has done more. So we have a reasonably good idea about what is the cost involved in retrofitting a ballast water plant in a vessel. And if it's a new build, then it's still lesser than on an existing vessel. So now your primary intention of going for a ballastless vessel is to prevent this installation of this system of the ballast water treatment system.
It is to mainly see that it is like, sir, initially double hull tankers were not there. Later, there is a mandatory rule which is there. Same IMO may say that no more ballast water. In fact, if we actually design bulk carriers trade route properly, there would not be any ballast condition. Container trade route properly, there would not be any ballast condition. But for tankers, that two crude oil tankers, I don't have an option. The return voyage which is there would be having a ballast water. So because if I want to project, cost would be a main factor. Yeah. So if I don't bring in cost or reduction which is there, yes, there would be additional cost in terms of construction. So I want to quantify the additional cost in construction, which would be reduced during the lifetime by not installing this ballast water treatment mechanism at the end.
Yeah, see, what I was trying to convey is the ballast treatment system itself, the installation of that, the delta or the change in the overall cost of the capex of the vessel is not appreciable considering the overall. I actually was disinterested in your presentation at the start until I saw this slide. Because if this is something which you can achieve with a V-shaped hull form, then suddenly ballast system it becomes irrelevant.
Yes,
it becomes secondary. If with a V-shape you can achieve this kind of cost reduction, then the ballast less ship it will be applicable everywhere. I mean, people will vote for it regardless of whether BWTS is needed or not.
Yes, sir. But my final aim would be that. But at this point of time, I cannot say, because there are a lot of analysis. The main aim of this whole project was actually to link actual stability calculations, loading conditions, and the steel weight assumption is what I've taken is an empirical one, which cannot be quantified. Now, I want it as an automative algorithm using a cases platform to integrate all this to get multiple design solution and find out what is the optimum out of it. Now, from morning, everybody is talking about optimization, but I'm trying to find out optimization or similar to that of optimization to find out a ballastless option. So hopefully maybe better or a feasible design for the next time I can bring it out. But I surely feel that this V-shape, one of the things which I have expected during my analysis is I expected an increase in length, because of which I have much more higher problems. But what I had was a feasible design, almost same, but increase in depth. So that becomes a more feasible solution. Whenever increasing length is there, in terms of sea keeping and maneuvering, I have more problems to handle. But same, the V-shaped ballast condition, how the vessel would behave in waves is a big question mark which is to be addressed. Unless until that is addressed, though this gives a positive response in terms of reduced power, the overall picture of the ship would not be considered. 15 knots, sir. Both are for the same speed, but the propeller diameters are different. For the V-shape, I had a propeller diameter which is higher, which is around 9.3. And for the normal vessel, the baseline vessel, it was around 6.8.
Planning something outside. So we will restrict the questions. We'll go to the next speaker.
Thank you.
Next is paper ID 134, Mr. Prabhakaran K from Cochin Shipyard Limited.
Good evening to everyone. Actually, my topic here is about integration of green energy sources on the onboard vessels. So this is the flow of the presentation. Actually, first is the introduction. Next, what are all the green sources? Next, what are all the challenges which are faced? And what is the system configuration which is more suitable for implementation? And then few conclusions on the studies. So before starting to why green sources, so this is the place where it starts from. So from IMO 2023 GHG strategy, which has aligned to meet the Paris Agreement, which has happened in 2015. So based on this, there are certain key points which has to be taken into account. So first is the carbon intensity of the ship has to be declined by having an improved efficiency or design of the ship. So this is something like which has to put forth in starting from hull development onwards. Second is that to reduce the CO2 emissions by at least 40% in 2030 compared to 2008 levels. So this is a very huge step which has been taken by IMO on this aspect. Next is uptake of zero or near zero GHG emissions by 2050. So for this, at present, there are energy sources and fuels which are they have taken at least a 5% which has to be implemented by 2030. So which is pushed forward to go ahead for 10%. So there is a tagline which came up from the IMO itself, where take urgent action to combat climate change. So this is a major impact and things which has started for these green sources which are available, and we have to look for implementation in the ships. So first, which comes is the battery system. So when we say about the battery system, there are a lot of debate which will be happening, because batteries, once we put on board, it can be used with a lot of safeties and everything, but from where it can be charged. So again, the grid has to be green. So only then our GHG emissions or carbon emissions will get reduced. So most popular batteries at present, which has been developed for marine, is lithium-ion batteries, which has its own merits and demerits. And the most commonly used type in lithium-ion is NMC, which is a nickel, manganese, cobalt type. And we have other two batteries also, which is LFP and LTO. So if you see, there are different density, energy density variations between all three types. If you see for NMC, it is 120 to 180 kilowatt per kg, whereas for LFP is 90 to 125 kilowatt per kg, whereas LTO is much lesser. But if you see the life cycle aspects, LTO has the greatest life cycle, whereas compared to all other batteries. Similarly, if you take the charging and discharging rate, that is also for LTO is much higher. But if you see where it can be used, so application is something which has to be looked into it. So for that, if you see the selection of battery, which battery type which we have to go for, it depends on these 5 major parameters. First is what is the total energy requirement on board the vessel. Second is what is the energy density which we are looking into it. Next is what is the peak power requirement from the vessel. Next is charging time. What is the interval of journeys? That is something which is more taken into account. Next is the lifetime of batteries which we are looking on board the vessels. So normally if a vessel is constructed, its lifetime is 25 years. But whereas in case of batteries, at present, it is around 10 years. That is the maximum life which can be accepted. Right? So after 10 years, it has to be replaced. So there is a cost involved. So a lot of things has to be put into this. Next is the future fuels. The so-called, we have a lot of ammonia, methanol, biofuels, hydrogen fuels. So these are all various fuels which are coming into the market. So if you see this, which gives the comparison over the various parameters. So first is the energy density. If you have an energy density, of course, low sulfur fuel has the highest energy density, whereas all our future fuels has comparatively or slightly lesser than what current fuels we have. But if you consider our GHG emissions, it is completely opposite. It means like current fuels has the highest of GHG emissions, whereas the future fuels has lowest. And if you see the technological maturity on all these fuels, currently whatever the fuels we have all are running in diesel. So that is like highly matured. But whereas if you see for methanol or LPG, it is to a mature level, but it is slightly lower than for implementations. Whereas if you have for ammonia and hydrogen as a fuel, direct fuels for engines, still it is in developments. Probably in another 3 years, we will have a first ammonia vessel, but still hydrogen is in a research stage. If you go for the cost wise, of course, going for a full electric or hydrogen or ammonia cost is much higher, at least at this point of time, because of no standardized engines or systems which are available. And then there are certain key parameters which are meant for the safety. First is flammability, toxicity. So if you see that flammability and toxicity, all are like incomparable, because when you take like new fuels, future fuels that are highly flammable compared to our diesels. And if you take toxicity, if you take in case of ammonia, that is the highest ever toxicity which we have it right now. And then if you take the regulations and guidelines which are currently available with respect to complete IACS members, so we don't have a predefined set of rules and regulations for any of these fuels, except for the diesels, which we are currently operating in. But these regulations are like upcoming, or it is in building, or it is in trials and test stages with various OEMs. So at any point of time, it can be like mandate rule or set of regulations which has to be implemented on board the ships for going ahead with these kind of fuels. It would come. So when we say challenges are seen in various aspects. One is implementations and administrative aspects, and then operational aspects. So if you take it like first is the rate of green fuel which is available. So if you take roughly approximately at today's present, hydrogen is roughly around 2,500 to 3,000 per kg. So that's going to be a huge amount. And if you take infrastructure development, yes, of course, we don't have much of hydrogen storage locations or hydrogen fueling stations or hydrogen bunkering stations. So, or not only for hydrogen, it also puts for all other fuels also. Next is the storage capacity on board the vessel when compared to diesel to achieve the same endurance, same power or same performance, we need to have higher storage capacities for all other fuels also. So there are like a lot of challenges on this, and the low energy density is also a factor to it. And then how we store the fuels in the board. Next is the capital investment. So at this point of time, when we take into the capital investment, it will be the higher, but due to the development of technologies and strive to implement all these green sources, it will be getting down drastically, probably in next 5 to 10 years timeline. So now we came to know about all these fuels and battery systems. So what is the best solutions which we can go ahead? As you know, like in our till now, whatever the propulsion systems or configurations we have, it all comes into these three categories. That is conventional, electric, and hybrid categories. So can we go ahead with the same configurations when we have these fuels? Of course, we can go ahead, but with slight modifications. Because when you take hydrogen powered engines, yes, it is going to be in line with whatever we have done now. But when we look into your fuel cell aspects, which are again hydrogen powered, so we will have a lot of challenges because the output of fuel cells are in DC, not in AC or like in case of generators. So we need to have some mode of integration on board the vessel, which gives a complete flexibility for the operators, so that whenever there is an new fuel developments or new systems which comes into places, it can be utilized. So in that aspect, because of introduction of all these different types of batteries and fuels, there are few innovations which has been taken up. That is, first is a DC grid solutions, which are meant largely involved for all the vessels commonly, which is more used now. And next is the dual fuel engines, which are future ready engines. So now it has been made it like, first it will be running in diesel. Then once the infrastructure and bunkering facilities are available, it will go to green items. So this is a major. And next is about various configurations like hybrid. This is a conventional mechanical hybrid systems, which we have it right now. In this, if we need to integrate all our fuel cells or any kind of solar or whatever the renewable energies which we are bringing in, so we need to have a common bus system. So that is where we have a DC bus and an AC bus system. So we can go ahead with both the configurations, which I will come in the next slide, how both comparisons are meant to be. So this is a pure electric system where electric and hybrid configurations are more viable till we have fuels which are available in the market, used for all the commonly available. So this is the AC and DC comparison. So if you see AC system, it involves a lot of equipments if you go for a pure electric system. And if you have a DC, of course, it is also involving a lot of components, but there is a flexibility to concise all these converters into a single unit. So this has brought into different perspective of involving all these systems on board the vessel. So if we take a comparison overall, so if you see the space requirement comes down, system weight comes down, entire system integration complexities comes down, and cable quantities also comes down. But there is a much more challenging, we have it in case of DC, that is our short circuit current protections and the challenges on the system protection. So till now, as far as the technologies are concerned, most for a low powered systems, there are HRC fuses, which is fast acting HRC fuses, which are used. But for a high power system, there are solid state breakers, which has been used. So based on all these data which are available, there is a conclusion which has been made, like how a system integration to be done, what are all the major parameters which has to be considered. So first is the operation profile. Next, what are all the energy sources which are planned to come on board, because that determines our whether we can stick with our old system or we can go for something new technologies. And then what is the amount of reduction in carbon emissions which we are looking into it. From this, we have categorized into 3 different categories. So first is the inland and short sea shipping vessels. where we can go ahead with battery solutions, or based on governmental policies, recent Indian government has given more stress on hydrogen hubs, increasing lot of hydrogen fuel available. So in that aspect, we can go for even hydrogen fuel cell systems also. Next is the coastal shipping and also the deep sea shipping. If you see both cases, it is hybrid systems with alternative fuel engines and also batteries. But there is a small difference between both the cases. In case of coastal shippings, entire battery system will be acting as a primary, whereas alternative fuel cells will be alternative fuel engines, which will be acting as a secondary source of power supply, and it will be utilized only when there is a peak power requirement or peak demand which is on board the vessel. But whereas for the deep sea shipping, where it requires a long range of endurance, so we need to have a alternative fuel engines as the main source, and batteries will come in and come out for the peak power requirements. So these are all the final observations on this. Thank you.
Yeah, you mentioned that some of the features you have to consider while selecting a battery system.
Yes, sir.
But weight was not included on one of them as one of the aspects you have to consider. For smaller vessels, I suppose weight is also a major criteria
Yes, of
you would
course.
have to look at. Among
Correct,
the
sir.
3 batteries, you said which is the least weight option?
Sir, I have shown some parameter called energy density. So if you take energy densities, if you take a NMC, LFP and LTO, NMC has the highest density. So energy density is nothing but a power to weight ratio. So when I say it has a highest energy density, it means that is going to be a less weight for a total power requirement. For the same power requirement, LTO would be the highest weight. So this is how it is categorized into it. But of course, safety is concerned, then most safest battery would be the LTO, at least for now in the market. So it is like trading off between both the things and how the systems are developed. As I said, like most of the classification societies has developed a framework for implementing battery systems on board the vessels, but nowhere it is like a complete mandate requirement. This is to be there. Most of them are in a, I would say, like implemented, or it's in a maybe in a little bit of an advanced state. So it is going to be implemented or going to be made it as a mandatory requirement. So this is how it is.
Thank you.
Thank you.
Next is an online presentation, paper ID 114 by Captain Dr. Nitin Agarwal, Indian Navy.
Good evening, everybody. I hope the presentation is moving. If you can just confirm, please. Can you hear me?
Sir, it's audible and we can see the screen and the slides are.
Okay, wonderful. Yeah, perfect. Good evening, everybody. I'm Captain Agarwal, a student or ex-student of the Department of Ship Technology. The topic of discussion today is the utility of 3D printing in ship repairs. Now, in the ongoing sessions, I heard about sustainability and how shipping can be made better through automation, etc., etc. So this is one more one more effort towards moving towards sustainability and trying to see how automation can come into play as far as the ships are concerned. Now, one may wonder that why am I talking of ship repairs and not about shipbuilding per se and using 3D printing? Why so? Because we all are aware as naval architects that when we get onto the usage of the ships and the ship has got a breakage or has got a defect at sea, then definitely it needs to be repaired and it needs to be made available. And that also has to be made available in quick time. So if you wait for the actual part and if you wait for the spare to be available, then possibly it is possible that the amount of time that may be required will be very large. So there are provisions wherein 3D printing has been found to be effective. So that is what the whole thought process is, to see how best 3D printing can be incorporated in ship repairs and whether we have reached a state and moment of time which allows us to use 3D printing in ship repairs. So to make the life simpler, I have broken down the entire presentation in the following heads in front of you, giving you a basic idea with respect to what 3D printing is in general and how it is involved in the maritime sector, shipping, ship repairs. Look at a case study, some challenges, some way ahead, and then conclude the discussion. Now, as on date, what we know about in terms of the actual manufacturing of any equipment or any spare part is through subtractive manufacturing, wherein you have a block of metal or a block of material out of which based on the requirement, you remove the material and you undertake subtractive manufacturing. That means you are subtracting the material and creating it or converting into a shape which allows you to be using it as a spare part. When you talk about additive manufacturing, that is the 3D printing, then what you are doing is you are building up the product in layers. If you see the picture in front of you, it is showing layer after layer which has been deposited and the structure has been created. Now, this technology, if you see very clearly, is not something very new. It is, if you look at the pyramids, they were built out of this kind of a technology. The same has been used even by the Egyptians in some fashion or the other. So it is not something which is new. It is just that we have forgotten that this kind of a technology could be used. And with the improvement of materials, with the improvement of technology of materials, we are now trying to look at using 3D printing in some form or the other in our usage. Now, the basic way how the 3D printing works is that you have a photograph that could be for a spare part, convert it into a 3D model, then digitize it in some fashion or the other, and then create a digital file. That file could be in STL and OBJ format, and you have to ensure that the file is such that it is a closed file. It should not have any kind of holes, and no loose pieces, etc., should be available as far as the file is concerned, digital file is concerned. What is done is the entire product is built layer after layer as shown in front of you, and that is what is going to give you the final product. Now, once you have come to that point, you need to look at what kind of materials can be substituted for 3D printing, whether they are we have the technology as far as that is concerned or not. So presently, what we have technology is to replace materials such as concrete, metal, powdered metals, chocolates, and other foods, and even living tissues as far as 3D printing is concerned. And the most common material which is used for doing all this is polymers. Polymers could be again in different fashions or different forms. They could be in terms of rolls, reels, and filaments, liquids or resin powder, or they could be made out of fossil fuels. But usually what is used in the industry today with respect to 3D printing is the polylactic acid and plant-based and biodegradable polymers. So that is what needs to be defined as to what polymer is going to be used for your go ahead. Then you have to look at the technology or the process that has to be used. We are human beings. We keep creating new and new technologies. So there are a lot of technologies which are available, which are in front of you. Then once the technology has been defined, then you start looking at what kind of a process has to be used. The processes which are usually available as far as 3D printing are flashed in front of you. I'm not going to go into the details because then the entire process goes into a kind of a lengthy process. So just to give you a flavor of it, there are a lot of 3D printing processes. You have to select which kind of a 3D printing process you would like to use before the product can be manufactured as shown in front of you. Now, once the product has been manufactured, usually you would like to have an excess material to get the correct finish or correct resolution of the product, which is then done through normal subtractive methods, processes, in terms of maybe finishing, in terms of using a sandpaper or some other methodology. And this is what gives you the final product. So where are we with respect to 3D printing in industries? If you look at the industries, today 3D printing is used to some form in the aerospace industry, the architecture industry, the automotive industry, medical and dental industry, film, food, fashion, and many more. But if you were to look at the maritime industry, it is still to gain any traction per se. Some serious interest was shown in 2015 when a consortium of over 27 port-related companies of Port of Rotterdam had come together to define whether there is any advantage and economic viability of using printed parts or not. This resulted into a number of studies which basically looked at analyzing response time, inventory reduction on transportation costs, dependencies in terms of printing time, influence of spare part management, and things like that. And out of these studies, then some samples were created, which included a titanium variable ballast tank to map the Arctic seabed, aluminum keel for a custom-built yacht, underwater scooters, and a variety of boats, such that some trials could be undertaken, and then you could see whether they could be done. Please note that herein we are talking about new items being manufactured as a whole, not in terms of really spare parts per se. But yes, the basic interest was brought about as far as the maritime industry is concerned. While we have done all this, we should understand that even though after 25 years wherein the maritime industry has been experimenting with 3D printing for their industries, we have not been able to use it in any sensible form. And the major hold-ups which have been found are the diverse nature of the fleet, which do not allow any kind of a stabilization of the product per se. The data management systems which are available from with various ship owners is so very discrete and so very varied that you cannot come down to some kind of an analysis as far as what are the kind of added points which you need to build up in terms of understanding how the 3D printing can be used. And definitely when you don't have all this, and you require trained manpower and well laid out procedures and specific materials, and if there is no market, definitely you are not able to develop this, and that becomes a bigger whole point in terms of human resources as such. But it is believed that once this technology, this 3D printing is brought about, it is likely to replace several traditional manufacturing technologies, allow development of intelligent sensors. It will revolutionize the availability and delivery of spares because of its quick availability. It will be helpful in terms of personalizing parts. That means some specific parts which need some modification, that will be easier to do, and definitely reduce the cost of spares, transportation and delivery time and delays, because then the manufacturing of the part could be done at the site where exactly it is required and in quick time. Photographs to show you as to what all has already been done. You have had propellers being done, engine casings being done. 3D printed boat also has been done. Basically, the boat was done in 4 parts as shown in front of you. It was printed in 4 parts, and then it was joined together to form one complete boat, such that you had a floating boat, and then it was tested and it was proven that yes, it can be done. Overall, if you see the advantages which have been shown to be there with respect to 3D printing and shipbuilding is concerned, is or rather in shipbuilding is concerned, is basically the cost reduction, time saving, modern manufacturing processes, environmental friendly, and less space in terms of the stocking of materials and stocking of spare parts. So if you look at the maritime sector per se, a lot of effort has gone in by a lot of concerns. There are some institutions which are encouraging the usage of or the research on 3D printing, of which PJ Diesel and partners have been trying to study as to how repair and reconditioning of parts can be done. The Rotterdam Additive Manufacturing Laboratory has manufactured a complete 3D printer to be used for the marine environment. Hyundai Heavy Industries have produced close to about 165 key parts. The China Shipbuilding Industry Corporation had their own version of the powder bed fusion, such that their technology can be worked upon and it can be improved. The Singapore Investment and Center for 3D Printing has been looking at large joints such that they can be looked at and how best they can be done. And a joint industry program with DNVGL has been launched in Singapore to allow a development of a concept for future supply chains of the additive manufacturing spare parts. And that is how and where it is just limited to. But believe me, there is a lot of work which has happened and is going on to ensure that there is something substantial which is undertaken in it. Now, if we were to look at or focus on specifically ship repairs, because this what I've spoken of is in general as far as the maritime industry is concerned. If we look at the ship repairs in particular, then we have only manufactured some components quickly and expensively. That is what the whole idea is. And critical components, for critical components, if we were to manufacture critical components for repairs, then the process becomes complex due to the greater reliability and maintainability, which is dictated by the area of use. We will appreciate that if it is a critical component, and when we define a critical component, it means that it is a component which will undergo a lot of wear and tear. It will be subjected to a lot of forces. Then definitely it needs to be looked at carefully. And definitely you cannot have a breakdown of that part in any form. So the reliability and maintainability of that part has to be much higher. So that is why and where for the merchant vessels, some effort which has been done towards it in terms of ship repairs itself. The RAM Lab, that is the Rotterdam laboratory, has used a 6-axis robotic arm to fabricate shipbuilding components for small and larger ships. The Danish company Created Real is looking at using 3D printing on board such that the IP right protection is taken care of. Willman and Thyssen Group is trying to create a network of manufacturing partners such that the product as and when is required is available in a much faster manner. The UCOM engineers have created a ceramic device, fitted it on the 3D printed material part to record the degradation for overheating and such that the product can be replaced beforehand rather than waiting for a long time. And the Gazinev, which is a Russian firm or a Russian owner, he has been trying to see how best he can support his icebreakers by replacement and repair of his icebreaking equipment at sea itself. And they are trying to see how best this can be the products can be certified under the standards of the Russian Maritime Register of Shipping. Because finally, at the end of it, if a critical part has to be used or some spare part has to be used, it has to go through the certification process by our registers. Now, for the naval vessels, if you look, I've spoken of the merchant vessels. If you look at the naval vessels, the US Navy is the one which has been doing most of the doing. They've been experimenting with 3D printing since 2014, but still have not been able to conclusively come out with something. They say that the US Coast Guard is using it for on board already from 2013, and they have already got 5 ships which have got 3D printers. But the reports which have been released or are available say that what has been manufactured by these Coast Guard vessels is basically some caps and some small influxuous items which are not load bearing, or they are not very critical in nature. While in the European Union per se, they are still to look at 3D printing in the defense sector in any fashion. Now, moving on further, we need to understand that there is a major difference between the subtractive technology and the additive technology, as we discussed in the beginning. The subtractive technology looks at a uniform microstructure. It gives you a uniform microstructure, and it guarantees that there will be a uniform performance as far as the product is concerned. However, the additive technology can only guarantee a shape. It cannot guarantee the material property because the microstructure per se is not uniform. It is not connected in that true sense. If you look at the naval requirements, since the requirements are very stringent in terms of material, welding, shock, vibration, hydrostatics, and operation, there is a need necessarily to first create a prototype, go into a trial basis as far as the 3D product is concerned, remove that product, analyze it, inspect it for its residual life and performance, and then only certify that yes, it can be utilized for a better, it can be utilized again, the process and the part can be utilized again in terms of qualification. Basically, the product will have to be qualified, the process will have to be qualified, and then only it will be able to give you the required user confidence and some confidence to the maintainer. Since this cannot be obtained normally, so what the US Navy is trying to do is trying to use AI such that the process can be varied in such a manner that the material quality can be obtained. But then, like always, AI is a developmental process. It's right now still in the developmental process. So this is also something for the future. But believe me, the entire process requires that first trial of a prototype, then proving, and then verifying it will only allow the usage of a 3D printed part as far as repairs is concerned. Now, if we were to look at the utilization areas, this 3D printing parts can be effectively utilized for any other for processes wherein you are trying to create a first kind of a part. That means you are trying to manufacture some kind of a trial part to see whether this fits it or not, or whether there is some modification being done and that part has to be developed. So if you were to use it with the 3D printing, it will be faster and you will be able to get a part in much better time. While the strength may or may not suffice, but yes, it will be, at least the process can be verified in some fashion or the other. If the number of pieces that have to be manufactured are small, then definitely 3D printing has some sense. If you need to customize a part in terms of making some changes, some variations in shape and size, then definitely it is a good process of doing it up. And when product characteristics make the manufacturing impossible, it could be a double curvature part or a variable part, then definitely 3D printing is much faster. I know NC machines are also available which can allow double curvature to happen, but the cost involved, the time involved and things like that is much, much higher in these terms. The next area where it can be looked at is is that the thought process has come for the marine industry only after it has been utilized in the aero industry and the space industry and the other industries. But we need to understand that while that they have been able to use that in those areas, we have not been able to use it in the marine industry, mainly because of our working in isolation and because of our stringent requirements in terms of the classification societies. Now, one may say that the aero industry is even more stringent in terms of their quality and material. Yes, they are. But at the end of it, they have been able to do that classification and that utilization because of the repeatedness and because of the availability of the same equipment again and again. However, in the maritime industry, that repeatability is very limited, as I had discussed it earlier. For the maritime repairs, we can definitely use it, but only limited to non-load bearing parts, such as the smaller components in terms of plastic syringes, oil tank caps, model planes for flight decks, nozzles for powder fire extinguishers, and things like that. For bigger components, studies have still been being undertaken as far as shipbuilding is concerned. Some areas for shipbuilding per se, in the shipbuilding sector, not the ship repair, shipbuilding sector, some bigger components have been tried out with 3D printing, like I showed you the boat in particular. One case study that I would like to bring out is that of the repair of the ship's automatic firefighting system, the BARC-M, which is a project 1135-6 project. It's a Russian ship It's a Russian warship to be specific. And what is the part is right in front of you in the photograph here. If you look at this, this is the sensor. It is sealed to ensure that there is no moisture which is going on. It has got delicate parts, and to protect the delicate part, this is the sensor inside. If you see, to protect the sensor, excuse me, to protect the sensor, there is a cap which has been provided on top of it. Now, what happens usually is that this, while the cap has been provided, it is susceptible to damage because of the transportation and the movement and the fitment, because it's a protruding piece and there is no cover as far as the cap is concerned. So the moment the cap gets damaged, it is not available in open market as a spare part. The entire unit has per se to be completely removed and replaced, which is very costly, which comes to about 4,000 rubles. Now, and studies have shown that close to 5 to 6 caps get damaged in every cycle whenever it happens. So what was done by the JSC PSZ Yantar shipyard was that they tried using a 3D printing as far as manufacturing this entire cap is concerned. And for that, they used a Tornado 3D printer using two materials, SBS and PLA plastics. The printing time per sample was close to about 60 minutes with 15 grams or 4 meters of plastic thread. And the cost which was obtained or rather spent with respect to manufacturing was close to about 23 rubles for the SBS and 32 rubles for the PLA as against 4,000 rubles. While this cost does not include cost of electricity and wear of machinery, but definitely it was a much important advantage as far as the entire process is concerned. Please note that this was possible because this is not a load-bearing member and it did not require any certification from the classification society. That is why this entire process of printing this part was possible. Now, if we move forward to the challenges, the basic challenges that are there in front of us with respect to using 3D printing for ship repairs is high material cost, energy consumption, processing and post-processing time. There is no defined procedure. It's purely an iterative process, because if you have, if you do one cycle and if the part does not fit in correctly, or if there is no if it does not work properly, then definitely you have to make some corrections. However, it has also been shown that if you were to follow the correct process, it is not necessary that you may get the required properties of the part which you are desiring, because at the end of it, it is an iterative process and you have some problems. A bigger problem is in terms of the piracy of the IR rights, that is the property rights as far as the product is concerned. So that also is a matter of concern. What we need to do in the interim is that we need to define what we can replicate and what cannot be replicated. We need to develop the capability to qualify and certify 3D printing processes. You need to have business practices in place which create contracting, intellectual properties, legal and liability guidance. Technology is required to address the slow printing speed, sensitivity of the printer, large inventory of filler materials, inherent weakness of printing parts and things like that. And definitely some rules and regulations with the classification societies need to be put into place. While DNVGL, RENA, LRS and ABS have developed some rules for acceptance, but they are not really in place as of now for the actual usage. Broadly, some more way aheads are that you need to enable an end-to-end process integration for on-demand manufacturing. Greater awareness with respect to education, training, and certification of the entire process is required, because still you do not have the required education and the training. Definitely, you do not have the manpower available with you. And if you don't have the manpower, you definitely cannot produce 3D printed objects in any form. And definitely a lot of study is required in terms of how the speed adaptation algorithms can be considered in change in horizontal and horizontal direction, what is the kind of type of trajectory that needs to be taken, remaining path to travel after the printing has been undertaken, and another area of concern is the influence of ship motion and vibration in a seaway on 3D printing processes, because finally at the end of it, the vibration dampers which have been given to a printer are only limited to the printer vibration and not to the environmental ones, which would definitely be there when the ship is at sea and you want to manufacture something with respect to 3D printing as far as the product is concerned. While this has been discussed, in conclusion, I would only say that with a thrust on sustainability, 3D printing will definitely find support because it reduces the kind of wastage that is created. In ship repairs, it will encourage local manufacturing, reduce the foreign reliance of ships and owners, facilitate maintenance where OEM support is an issue, and it can encourage new business and opportunities because professional services such as production of 3D printers, product designers, printer operators, material support for legal help for IPR will also get created. As far as the understanding is concerned, we need to understand that 3D printing, whenever is spoken, should be spoken with respect to costing, wherein you are looking at the entire cost of operation with respect to the to understand what are the gains of 3D printing. Today, when we speak of 3D printing, unfortunately, we only talk about limited costing. We do not look at the entire gambit of the working cycle, because that is what is going to give you the overall advantage of using the 3D printing. And while we move towards 4D technology using nanotechnology and robotics, and the possibility of autonomous ships identifying a defect, replacing a spare by printing themselves using robotics is definitely a future, possible future for which 3D printing would definitely be required. I end my case. Thank you very much. I'm open to questions.
Good evening, sir. I have a question regarding the material testing. For example, we have a fixed testing procedure for conventionally produced, be it metal sheets or plates. In case of a 3D printed product, the benchmarking has not been done yet. So is there any insight towards from that end which you can provide to the audience as well?
Unfortunately, like you said, there are no benchmarks which have been created. That is where and what I mentioned, that those standards have to be made available by the classification society. I'm aware of some work being done by the classification society, but this is still wanting and it has still not reached any real value of essence effectively.
Not only the classification society.
I hope I've answered your question.
For example, we say ISO or ANSI standards or material standards, which are generally provided, ASME or anything like that.
Yes.
We say they have a standard benchmarking. Classification society comes later ahead, way ahead later. But in that realm, those parameters and indexes have not been clearly defined. Probably one reason could be that the microstructure properties which we obtain from a conventional manufacturing might not be obtained in the similar fashion. As you mentioned in one of your slide, that there are two ways where we can achieve the mechanical properties or we can achieve the shape. In one of your slide which you have mentioned, either we can.
What I mentioned there was that, correct. What I mentioned was that the subtractive technology gives you the microstructure and the strength, but it does not give you the shape. While the 3D printing or the subtractive manufacturing gives you the shape, but it does not conform to the microstructure and the strength per se. While what you mentioned in terms of ISO, definitely those are processes, but we have to understand that ISO does not happen in isolation. It comes from the industry itself. It is raised or it is proposed by the industry, and then it gets accepted as a norm over the time. Now, unfortunately, since the 3D printing, like I mentioned, for the maritime industry, it is still in the nascent stages of understanding whether we are able to utilize it fully or not. That is where and why the industry is not able to provide some kind of a way ahead as far as the material classification is concerned for the ISO or any other classification body.
Right, sir. Thank you.
Nitin, thank you.
Thank you, sir.
So that's the end of all the presentation. It was a very excellent display of knowledge by all the presenters. Now we are going into the certificate distribution ceremony. First of all, I would like to welcome Dr. D.D. Ebner, sir, to give away the certificate of appreciation to Dr. Shiva Prasad. Sir, please. Thank you, sir. Moving on to the distribution of participation certificate, I would like to welcome Dr. Shiva Prasad to give away the certificates. First, Tajuddin AK. I would like to welcome Arvind, sir, to give away the certificates. Mr. Sumitran Sampath. Next is Anand Ajit Kumar. Next, Mr. Avinash Gode. Next, Mr. Prabhakaran K. Thank you all. Now I would like to welcome Dr. Rajesh P. Nair.
Yeah, for the concluding session of today's presentation, it was a wonderful experience to have you all here for the conference. We have very VIPs, like sir is waiting till now. So I really appreciate all of you to attend this conference, and I just want to make a quick announcement. We have decided to go for Water Metro. It's dark, it's drizzling, but still those who are interested, please come with us. We have around 4 cars. In that, we will go and come back here and have dinner here. So just to have an experience of that. And I believe those who are registered are ready to go, isn't it? Anybody has any objection? No. So we'll take 4 cars and go there and come back here and have dinner here. And tomorrow's session will start sharply at 9:30 a.m. by Anandarayanan sir, and then the remaining sessions as predicted. And today's session, we are a little late in the sense that we are supposed to finish by 5. It's 5:50, but still it's okay. So let's wind up today's session. Thank you all. Hope to see you all tomorrow also. Thank you very much.